for you to get used to the syntax or know that sort worked in this way. But the goal is to show you that this is a common thing that you can do with Lambda functions in a way to make sure that you can sort with different keys. For example, this would work with a dictionary or another list inside of a list. This is a common way to adjust your sorting, and it's a pattern that you just have to remember. But it shows you the power of Lambda, where we don't really have to write these complicated functions. If we really just needed a one-time function and just a function that returns something simple, Lambda is a great tool to use. But if you didn't get this, like I said, don't worry. This is one of those things that you'll just have to remember. Let's take a break, and I'll see you in the next one. Bye-bye. Let's talk about something that's quite unique to Python and makes things really, really nice as Python programmers. And it's called comprehensions. It's one of our key terms, comprehensions. What are they? Well, they're actually called list comprehensions or set comprehensions or dictionary comprehensions. And these are some of the data types that we have in Python. And we're able to use comprehensions with these three data types. By the way, as I'm recording, there are some birds chirping in the background. I thought it would be nice to just record with birds chirping in the background. I think it'll be peaceful for you. If you get annoyed, I'm sorry. But hey, the birds have to have fun as well. Okay, so what are these comprehensions? Well, they're a quick way for us to create lists or sets or dictionary in Python instead of perhaps looping or appending to a bunch of items to lists. So let me show you. Instead of doing something like my list equals an empty list, and from here I'll do something like for character in hello, my list dot append character, just so I can create this list finally. So let's say my list, and we'll print this out. If I click run, I created a list that contains the characters from hello. All right, but is there a faster, cleaner way of doing this? And yes, there is with list comprehensions in Python. Again, it is quite unique. You don't see it in a lot of programming languages, but people that use Python really love this feature. And I do too. So how can we do this using a list comprehension? Well, the format we're going to follow is like this. We're going to say param for param in iterable. So when I say param, I mean parameter, or in our case, it could be a variable. So we can name it whatever we want. So let's name this character, like we did in here, and then character, like we did in here. And then we want an iterable. In our case, we'll say hello. So that if I remove this and I click run, I get the same thing, just like that. So upon creation on line 3, I create a list that contains character in hello. I do a for loop in here, and I create the list. So the way that I like to think about it is, hey, create a variable. And then we're going to do a for loop saying, hey, for each variable in the iterable, added to the list. Okay, let's expand upon this. Let's say I wanted to do something else. Let's call it my list 2. And I want to create, let's say, a quick list with numbers ranging from 0 to 100 or 0 to 99. How would I go about doing this? Again, using list comprehension, I'll say number for number. And then what's the iterable I'm going to use? Well, I'm going to use a range and say 0 to 100. So that if I click run here, look at that. I get a nice long list pre-populated with all these numbers. How cool is that? Okay, but here's my challenge to you. What if I wanted this, but all the numbers should be multiplied by 2? So I want a list where this equals to 0, this is 2, this is 4, this is 6, this is 8, this is 10, so on and so forth. How can I do it? Well, we can actually expand upon this so that my list 3, this time around, will use the same for loop that we've seen before, like this, but instead of just the variable, this is now an expression of how we want to act upon each character, just like we saw in lambda expressions. So I can now say num times 2 for these items. So now if I do my list 3, hey, check that out. That's pretty nice, isn't it? Okay, let's make it even more challenging. Let's say my list 3, and let's make this a little bit bigger here. My list 4, I want to change it so that in my list, I still keep here what I have, the numbers, but I want to only keep the even numbers. In this case, all of them are even because they're multiplied by 2. But if, for example, we do to the power of 2, and let's comment this out for a second and click run, we see that some numbers aren't even. So I want to keep these numbers, but only the even ones. How would I go about doing it? Well, in this case, we have a new way of creating this list expression. We'll do the exact same thing that we've done here, so I'm just going to copy that. But at the end, remember, we now have an expression here, something that we're going to do to affect whatever the item in the iterable is. We're going to loop through things. And then finally, after this, we can say if, or we can do an if condition. So let's say in our case, I'll say if num modulo 2 is equal to 0, only then add it to the list. So if we click run, and make sure that it's list 4, click run. Look at that. All of these are even numbers. So let's look at this format. Remember, these are called list comprehensions. It's a way for us to quickly create lists with Python instead of looping and using append or things that we've seen before. So it's a shorthand form for us to do things unique like this. The way we're able to do this is to have an expression here of what we want to do with each item that we're iterating over. We loop using a for loop through an iterable. We give it a variable, which we're going to act upon. And then if we want, we also have an option to add a conditional and say, hey, only include it into the list based on this condition, based on a true or false. Very, very cool. Now, although list comprehensions are really nice because they're just simple one-liners, it can get pretty confusing. Looking at this code, you have to be really familiar with list comprehensions to really understand what's going on. So although this makes code shorter, maybe even cleaner, it does take away a bit of its readability. So it might be better to just create a descriptive function like generate list of even numbers or something along those lines. So it's more descriptive and another developer might have a better idea of what's going on. So it's always a trade-off. Let's take a break and talk about set and dictionary comprehensions in the next video. Bye-bye. Let's talk about set comprehensions and dictionary comprehensions. Now, this first one is actually quite easy. You see, because we can do the same thing that we've done with lists. We simply change these bracket notation to a set, which is a curly bracket like this. So that if I do my list, the first one, I get a set. Same with the second one. If I go like this, mylist2, just like that. And I think you get the idea. Let's do one more on the final one. So mylist4. Again, you're able to do set comprehensions on sets as well. A quick way for us to generate sets. And remember, sets only allow numbers that are not duplicate, only unique items. What about dictionary comprehension? Well, let's do something like this. Using the same formula we've used, let's create a myDict. And in here, we're going to create a key and a value, just like that. And this key value can be acted upon. So in our case, let's say we want to multiply the value by 2, or to the power of 2. So this is what we want to create, a key value pair, and the value gets acted upon. Now in here, I'm going to say another for loop, for, so let's say key value, and then in, well, in what? What are we going to iterate over? Well, let's think here. In order for us to create a dictionary, we need both a key and a value, right? So I need to pass it an iterable, but I need to pass it an iterable like a dictionary that has both key and value. So we can do something simple here. We can say simple dictionary that will have A as 1 and B as 2. And now all we do is pass simple dictionary in here as an iterable. We grab the key and values by doing dot items, which we've seen before. And let's make this a little bit bigger. There you go. Let's put it all the way, just so we're all clear. It's all on one line. And now, let's just see what happens, and we'll go through it step by step. I'm going to copy this and, paste it. And if I click run, look at that. I have a new dictionary that has A equal to 1 and B equal to 4. Now let's go through it one by one. Just like we saw with list and set, the first part is what we want to do with the data. In our case, I wanted key and value, which I was going to extract here in our for loop. I could have named this whatever I want though. I could have done K and V, and you might see this commonly in Python code, just short term for key and value. And then I wanted to do the power of 2 to the value. So then this is what I wanted to do. This is the action. This is the for loop that we did. So the for loop was, hey, extract the key and value using the dictionary.items. Remember, I needed to have 2 values so I can fill in key and value. And then the value you multiply by 2, or to the power of 2. So we get that. If, for example, I wanted to add an if statement and say, hey, I only want you to add if the value is even, so let's say modulo 2 equals 0, only then I want you to add the dictionary. If I click run, only the even value 4 gets added to the dictionary. Very, very cool. Again, this makes your code a little bit less readable. So it's just a shorthand for you to use, and maybe if you see it in code, you at least know what it is. But you should be careful not to be overly clever and do these single line dictionary comprehensions just because you can. Just to solidify our knowledge, let's finish up with another example. What if instead I have this? I want to do a for number in a list 1, 2, 3. So we no longer have this dictionary, but we still need to include a key and a value pair. Could I do it so that maybe the item is the key and the item multiplied by 2 is the value? How would we do that? Pause the video and give it a go if you want. Otherwise, this is how we do it. We simply say number is the key and the value will be num times 2. Just like that. Nothing too difficult, right? If I click run, there we go. We're able to use comprehensions, list comprehensions, set comprehensions, dictionary comprehensions as a way to create lists with Python, as a way to create these data structures really fast with Python. Let's take a break and do an exercise in the next video. Welcome back. Remember this exercise that we did a few videos ago, where we had some list with letters, and I wanted you to find the duplicates and return them in a list of duplicates. In our case, we wrote this function with loops that returned b and n because both b and n were duplicates in the list. Now, this is going to be a tough one. Using what you learned about comprehensions, is there a way to do this neater? For example, I want you to say duplicates like this and create a comprehension in here that returns this exact same answer, b and n. So that if I print duplicates just in one line, I can find the duplicates. You can use set comprehensions, you can use list comprehensions, dictionary comprehension, whatever you need. Give it a go, really think about it. You can pause the video because otherwise I'm going to go with the answer. What I'm going to do is let's remove this and just start here. Now, the first thing I want to do is I want to create a list comprehension. What should I do here? Well, first, I know that I'm going to create a variable. So let's just call it x. And here, I'm not going to modify any of this. I'm just going to keep x the way it is. So x is going to represent A, B, then C, then B, then D. And I'm going to loop over and say for x in the list, some list, I want to only add the items that are repeated. So how can I check for that? Well, we can do an if statement, and in here, I'm going to say, well, some list dot count. Remember, count tells us how many times an item appears in the list. So we just give it the x parameter, so A, to let us know, hey, how many times does A appear in the list? How many times does B appear in the list? How many times does C, does B, so on and so forth. And our if statement should check if the number is greater than 1, right? So let's see what happens when I return this. If I click run, look at that. I get B, B, and N. All right, that's good, but I want to only have them once. I only need B and N. I don't need to know that, well, I don't need a list of 4 letters. So how can we do this? We know that we can create a set like this, right? I can say set and wrap it in here so that the entire list gets turned into a set. So we give this to the set, and then what happens? Oh, and this needs to be brackets, right? Because this is a function. So this is the set function that Python gives us. So if I run this, look at that. I have N and B. Almost done because, well, this is now a set. I asked you to return me a list. So what should we do? Well, we now can create a list out of that set. If I click run, there we go. We have our duplicates all in one line. Mind you, a very long line. And maybe this isn't the most readable code, but that's pretty cool. Now, this is a tough one. Maybe you didn't get it the first time around. It's okay. This is just something that you have to practice. You have to do a bunch of problems and you'll get used to eventually as you progress through your career. But that's it for comprehension. I'll see you in the next video. Bye-bye. It's time to talk about decorators. Another key term in Python. And we've actually seen decorators before. Do you remember when we were building classes? I taught you that there was a class method and a static method. And I said, hey, don't worry about this. We'll talk about this later. Well, this is now later. Decorators look like this. They have the @ sign and then some sort of name following it. But in order for us to fully understand what decorators are, we have to talk about functions in Python and why they're so powerful. This is the neat thing about Python. In Python, functions are what we call first-class citizens. That is, they can be passed around like variables. They can be an argument inside of a function. They act just like, well, variables. Let me show you. If I create a hello function, which frankly is completely useless because all it does is say, hello. If I do this, remember what I said. Functions are pretty much just variables in Python. Again, something that is not always the case with all programming languages. So if I wanted to, I can say greet equals to hello. So that if I print greet and I run this, I get hello. What if I just pass hello like this? If I run this, well, I get the function location in memory. So I would have to use greet like this and run it, right? We have to call the hello function. Okay, what if we do this? What if I say delete hello, a keyword in Python that deletes that function? What do you think will happen? Let's see. If I run this, is that what you expected? Did you expect greet to still work? The interesting thing about Python is that I create hello, and this is now created in memory. When we get to line 4, I say, hey, greet is going to point to hello. So hello can still be called down here. I can still say hello because hello is the name of the function that points to that location in memory. But when I do delete hello, all it does is say, hey, I'm going to delete this function, this name reference to this function that's in memory. However, because greet, a whole nother variable, is still pointing to this function, I'm going to delete the hello word. So if I go hello like this, I'm going to get an error. Name hello is not defined. However, the greet is still pointing in memory to this location. So Python is smart enough to say, hey, you told me to delete hello. I'll delete the name hello, but I'm not going to delete the function because greet is still pointing to it. So functions in Python act just like variables do. They're first-class citizens. We can also pass functions around inside of arguments, right? If I say hello, and then this hello receives another function that calls, let's say, function, like this, well, I can create a greet function. Let's say define greet. And this function is just going to print still here. Now, in here, if I call hello with greet, or just so we're clear, let's just say A equals to hello, greet, and if I print A, what will happen? That still works. Because what happens is I say, hey, call the function hello. Okay, I'm calling the function hello with the argument greet. So we go here and we say, hey, run function. And what's function? We want to call this function, right? Because we have these brackets. So we jump to what function is, which in our case is greet. So we go over here and say, hey, just print this. We didn't have to call it in here because the hello function calls it for us. So why did I just teach you all of that? What does that have to do with decorators? Decorators are only possible because of these features. This ability of functions to act like variables, act like first-class citizens in Python. And when we start learning about decorators, underneath the hood, they're using this power of functions. Now, in the upcoming videos, we're going to talk about how to create our own, what they mean, and expand on this idea of a decorator. But here's a short form of what decorators do. Decorators supercharge our function. If we had our, let's say, hello function here, by adding some sort of a decorator, like this, we can supercharge our function and add extra functionality to it. It lets the Python interpreter know, I want this hello function to have some extra features. But let's explore this topic a little bit more in the next video. Promise to not get mad at me, but there's actually one other thing I forgot to mention before we can talk about decorators. I know I'm building the suspense. I know you're just thinking, hey, Andre, tell me what a decorator is. You're wasting my time. But one more thing, quick video, I promise. We have to understand this idea of a higher order function. That is a higher order function, or HOC for short. Sounds super important, right? A higher order function can be one of two things. It could either be a function, let's say the greet function, that accepts another function. So this right here is a higher order function. It's a function that accepts inside of its parameters another function. Another way it can be a higher order function is if it's a function that returns another function. If we define, let's say, greet2 that just runs normally, but instead returns another function. So let's say in here we have define func. And this define func, let's say, just returns 5. And we return the function. This is a higher order function. A higher order function is any function that either accepts a function as a parameter or returns a function. And if you're thinking, hey, is that map function that we talked about, is that a higher order function because it accepts a function? Yep, that's a higher order function. So is reduce or filter. These are all higher order functions. All right, I promise in the next video, we're going to talk about why this is important and what decorators are. I'll see you in that one. Bye-bye. Let's finally write our own decorator. Remember, a decorator supercharges our function. It's simply a function that wraps another function and enhances it or changes it. But the best way for me to explain what it is to actually code our own. So let's do that. Let's define a my decorator. And this decorator is going to accept a function. Right away, we should know that this is a higher order function. Now in here, inside of here, we're going to call the function. But before we do that, we're actually going to wrap this function in another function. So we're going to say define the wrap function. So this is just a wrapper. And this wrap function is going to be a function that simply runs this func. And then finally, we'll just return wrap function. And notice here that I'm not calling it. I'm just returning it so that later on somebody can use it. Okay, now let's say we have a simple function, hello. And this simple function just prints hello. What a useless function. Now, why is this useful? Because now I can use this as decorator. Python, as soon as we write an A in front of this, is going to say, hey, this is going to be a decorator. And the decorator, as long as we follow this syntax of accepting a function, having a wrapper function, calling the function, and returning the wrapper function, can be used. So if I do my decorator, see how it's all blue? Now, this decorator can actually be used on top when defining our functions. So if we want to use my decorator on the hello function, we use it like this. So that when I call hello next in my program, I click run, I get hello. Okay, I know what you're thinking. You're thinking, this is a complete waste of time, Andre. Why did I have to do all of that? I could have just done this, just define the hello, and that was it. I'm so confused. Well, here's the thing. What we just did with the decorator hasn't changed anything. It works exactly as expected. But what it allows us to do is that now we can add extra functionality. Remember how I said that decorators is a function, like my decorator, that wraps, that is here, another function, which is the function that we pass it, and enhances it. So how can we enhance hello? Well, we can do anything inside of this wrapped function. For example, I can say print, and then we'll just print some stars in here. And maybe print another set of stars in here. So that when I call run, boom, we've just super boosted our hello function. How cool is that? And this is why decorators are useful. By just adding this one line, I'm able to super boost a function. So that, let's say I create another function called by. And this by is going to print, see ya later. By calling by here and clicking run, well, nothing changes. But if I wanted to super boost it, just like the hello, all I need to do is just copy the decorator and use it here as well. So that if I run it, there we go. We've super boosted our by. This is the power of decorators. By just using this syntax, I can add extra functionality to other functions. Now I know what you're thinking. And I know I also keep saying that a lot. It's like I can read minds. But you're thinking, this is a lot of magic. How does Python interpreter do all of this? It seems like, well, magic, right? Underneath the hood, all it does, well, let me show you. Based on what we've learned so far about functions, because they're first-class citizens, right? All we're doing is literally this. We're saying variable A equals hello, and wrapping this hello and calling it with my decorator. So I'm saying my decorator, hello. And then after that, I am running A like this. So let's say this was hello 2. Well, I'm just running it like so. So that if I run this, everything still works. All I'm doing is wrapping my hello function with my decorator and assigning it to a variable. So if we go step by step, we see that my decorator receives a function, in our case, the hello function. It then returns this wrapped function that has hello in here. So we return this wrap function. So hello2 now equals this wrapped function. And then this wrapped function gets called. And what does it get called with? Well, it prints this, then it runs the hello function, and then it prints this. It's the same as doing something like this. We simply call it again. If I run this, it works. That looks strange, doesn't it? But it should make sense. We're calling the first function, and the first function returns another function, and then we call the next returned function, which is wrap function. Now, the reason decorators are useful is because instead of doing this and frankly looking confusing, I can just add the @myDecorator, and we don't need to do all of this. Our hello gets automatically wrapped by my decorator. But essentially, this is what the @ sign is doing. See? Nothing magic about it. Now, right now, this is nice, but I bet you're still wondering why decorators are useful. So in order to really finalize our understanding of decorators, let's take a break and I'll see you in the next video. Let me ask you a question. What happens if this hello function actually took a parameter? Let's say a string or a greeting. And a greeting was going to be printed here. Let's remove the by for now. Would this still work if I run hello? Pause the video and think about it. Let's find out. Nope, that's an error. If you can, try to pause the video here and see if you can solve this. How can we make this allow arguments? I see that on line 5, right here, it says line 5. Hello is missing one required positional argument, greeting. Because when we actually call hello, we're expecting to have a parameter, but here we're not giving it any arguments. How can we solve this? Well, the one way is to just simply say greeting, right? Or we can say whatever we want. We can say X. And then this wrapper function receives the parameter. So that if I click run, line 13 is now giving me an error because, well, now we need to actually give it a greeting. So let's say hi. If I click run, all right, this works. And I hope this makes sense, right? We're calling hello with hi. So this function, hello, gets passed. We then receive as argument the X, right? Remember, underneath the hood, my decorator is saying A equals my decorator and hello, right? So all we're doing is running my decorator hello, which now turns into the wrapped function. And when we do the wrapped function A, we give it an argument of hi. So the wrapped function accepts this parameter and then runs the function hello. But here's the question. What if greeting also had an emoji that it accepts? So we're printing greeting and then the emoji. What do we do? Well, again, we'd have to create another parameter and then another parameter. And then here, call it with, let's say, a smiley face. If I click run, well, this should be a string. If I click run, this works. But this is hectic. Every time I need to change parameters, well, I have to modify this. And what if we had keyword arguments like default hi? There's actually a pattern here that we can use that makes things really, really simple for us. And all we do is this. We do the star args, which we have seen, which takes all positional arguments, and then star keyword args, which takes all the keyword arguments. And we call the function by saying star args to unpack all the positional arguments, and star keyword args to unpack all the keyword arguments. Now, if this looks confusing, don't worry. This is just a pattern that you can just copy and paste and remember. But now, check this out. I can do emoji equals to, let's say, sad face as the keyword argument. And now, if I just pass hi, like this, and hit run, and let's just remove this as well, since we don't need it. We'll call hello properly because we have the decorator, and then click run. Look at that. I get hi with the sad face. Now, the reason this is called a decorator, it's because it's a famous pattern in programming. It's called the decorator pattern. And this is the decorator pattern. It gives our decorator flexibility so that we're able to pass as many arguments as we want into our wrapped function by using star args and keyword args and then unpacking them like this inside of a function. And this syntax, let's say if we didn't even have the print statements, this syntax is why decorators are so powerful. By just using these lines of code, we're able to add functionality using the decorator pattern to decorate our functions. And the decorator patterns are used all over programming. So it's a very, very powerful concept. To finish off the lesson on decorator, I want to talk to you about some of the ways that decorators can be useful and some of the common locations that we're going to see decorator patterns in our code. And we're going to build our own performance decorator that's going to be able to tell us how our functions perform, how fast they are. And I promise you, by the end of that video, decorators are going to make sense to you. And you're going to be able to explain to other people and other friends why we should use decorators in our programs. I'll see you in that one. Bye-bye. So let's talk about some of the practical applications of decorators. I mean, we've already seen them in classes, right? We saw how class method and static method. We're able to create class methods and static methods on the class that the direct class can use. And if you don't remember these, just go back to those videos. But I want to show you one of my favorite examples of a decorator. We're going to create our own. What we're going to do is I want to have a performance decorator. And by the way, this decorator doesn't exist in Python. We're going to build it from scratch. What I want to do is be able to have a performance decorator that I can use during testing my code to see how fast my code runs. For example, if I had a function, let's say long time, that takes, well, a long time to complete. So I'm going to do a really long loop and say for I in range of, let's say, all these numbers, and I'm just going to do a random calculation, I times 5. This function, I want to know how well it performs, how many milliseconds it takes to complete this. So how can we build that? First, I'm going to do something that we haven't talked about yet that we will. Something about modules and built-in modules. So for now, we're not going to talk about this too much, but we're going to import from the time module something called, well, time. Again, something that we'll talk about in the module section of the course. I'm essentially saying, hey, when I installed Python, or in my case, when I'm using this REPL, it has access to this time if I ask for it. And in this case, I'm saying, hey, I want to use this time object or module that I get from Python. And in here, we're going to create our decorator following the pattern that we've learned. I'm going to say define performance, and performance is going to accept a function, just like we've seen before. And in here, we'll have our wrapper. So let's say wrapper function. And wrapper function, if you remember, it's going to be flexible by taking in star args and star keyword args so that we can pass it however many parameters we want, because we don't know how this function, how many parameters it's going to have, and I want to be able to use performance on all my functions. Now in here, first, what we're going to do is we're going to have the result of the function be the function that we receive right here, and then simply say run the function with star args and star keyword args. And finally, at the end of this, I want to return the results. And then finally, we're going to return the wrapper. So nothing we haven't seen before. I could have just done return here or just ran the function, but I'll show you why I did it this way in a second. Right now, our function doesn't really do anything. If I click run, well, nothing happens. If I do long time and I run this function, it just took a long time to run, but that's it. Nothing happens. This is when we make things interesting. We want to calculate from the beginning of running this function to the end of running this function. And we can use time module to do this. I can create a variable, time1, for the start, and simply say time. So I'm running this time function. That's going to start a time and say, hey, this initial time is going to be t1. And after this function, our main function, long time, gets run, I'm going to say t2 and say, hey, what's the time right now? So this time, we'll check what time it's now, and then we're going to run this function, and then this time it's going to check the time. And however much difference there is between these two is how long this part took, right? So all we do is say print an f string and say it took t1 minus t2, right? And this actually returns in milliseconds, so I'll just say ms for milliseconds. And that's it. I've wrapped my function with just this extra time piece, and then I'm printing, as soon as we run the function, how long it took. So let's check it out. If I now run my long time function right here, and I click run, all right, I get a minus number because I messed up here. This should be t2 minus t1 because the time on t1, some time passes, and then t2. So t2 is always going to be larger than t1. If I run this, all right, it took 0.16 milliseconds. I think this is actually seconds. Now let's make this long function even longer. If I go like this and click run, oh boy, that took 1.9 seconds. What if I make it even longer? If I click run, and this is the part where I keep talking until the function runs because there's going to be an awkward silence. Otherwise, hopefully this ends soon because I have nothing else to talk about. Come on, this is getting awkward. All right, come on. Oh boy. I'm going to fast forward through here. Oh boy, it took 19 seconds. That's pretty bad. But I now have this decorator that I can give to pretty much any function in my program and actually measure the performance of my function. Pretty useful, right? I could have this piece of code, and before, let's say, I deploy my code or put my code out into the world, I can test how performant my functions are, and maybe I can optimize things in different ways. Very, very useful, and I did that in just a few lines of code, 9 lines of code. Now, mind you, this performance decorator depends on the machine and how fast your CPU and memory are on your computer. So for what took me 19 seconds might take you a lot more or a lot less, depending on your machine. But this is a nice way to compare functions relatively. So I hope after this you see the power of decorators. Decorators are used a lot in Python libraries and frameworks. Web frameworks that we're going to talk about, like Django and Flask, use decorators. Maybe you want to have some authentication decorator. So you do authenticated, where each function can only be run if the user is authenticated. Maybe they have the privilege to run a function, such as logging in to a website. Or maybe you just need a login or logging decorator that just logs and lets your database know that, hey, somebody has logged into your system, or hey, somebody has purchased something from Amazon, or hey, somebody just requested a friend request. There's so many uses for decorators. And decorator is a hard topic. You're not going to see them all over Python code. They're just an extra feature that you can use as you become more and more comfortable with Python. But I hope by the end of this all, you at least understand them to maybe one day build your own or use pre-built ones by libraries and frameworks. I'll see you in the next one. Bye-bye. An unavoidable part of being a programmer is that your programs are going to give a lot of errors. You can't avoid bugs. You can't avoid programs breaking. A simple print function here with, let's say, a misspelled word with, let's say, no comma. If I run this, we've been seeing this a lot, right? We've been seeing a lot of this red throughout this course. A lot of these errors. If I try to add 1 plus, let's say, true, click run, that works. But then all of a sudden, I decide to add hello to 1. And yet again, we see that red, this time a type error. An error that crashes our program like this is called an exception. And Python raises these exceptions whenever the interpreter says, hey, I have no idea what you're doing. Something's wrong. I don't know what I'm doing anymore. I'm going to stop whatever I'm doing and I'm going to give you an output. This is bad because right now we're just playing. But if we're Google and people depend on us to maybe check their email, to watch YouTube videos, if our programs have exceptions and they stop working and they error out, that's bad. That could cost companies millions. So how can we handle these exceptions that crash our program? Well, we need something called error handling. It's a natural part of being a programmer, and a great programmer is able to handle errors in their program. Because instead of letting our programs just error, we're able to handle them so that if we get something like a type error like this, we can actually handle that error within our programs. And in this section, we're going to learn all about that. But the key takeaway is that error handling allows us to let the Python script continue running even if there are errors. Sounds pretty interesting, right? Well, before we get into that, let's just talk about some of the errors that exist in Python. We've already seen type error, where we're trying to do something between two different data types that are incompatible, such as adding int and string. And these built-in exceptions in Python, there's lots of them. And I'll link to this resource so you can take a look. But if I scroll through here, you see attribute error, end of file error. We keep going. We have a name error. We have so many errors, reference errors. just a ton. Let me just go through some of them that are quite common. One is a syntax error. If I do def and let's say hoo, and I forget a semicolon here, and I run this, I get a syntax error. It's not a standard Python syntax. I have to fix my error. I can also get something called a name error. If, let's say, I use 1 plus name, like this, and I click name like this, you can see the red underline here. I get undefined name. So that if I run this code, I'll get a name error. Name is not defined. We've seen type error. But what about this? What if we have a list, let's say li, 1, 2, 3, and I access li, let's say, an index of 5. If I run this, I get an index error. List index is out of range. What if we had a dictionary? So let's say we're creating a dictionary here. We'll say A equals 1, and I will just leave it at that. So this will be a dictionary. If I do dictionary here and just try to access something that doesn't exist and I click run, I get a key error because I'm accessing a key that doesn't exist. We can also have, let's say, 5 divided by 0, which should give me a 0 division error because I'm trying to divide by 0 and, well, you just can't do that. So there's lots of errors or built-in exceptions in Python. Now, you don't have to memorize any of these. Most of the time, they'll come up in your program and you'll know what they mean. But you can always use this as a reference to read them. But the question you should be asking yourself is, how do we avoid these? Because most programs aren't just us typing information. Usually programs interact with the outside world, right? When I log into my email, I let a user use their email and password. When I play a game, I let a user control a character. So programs are constantly interacting with the outside world, and they have to make sure that whatever input they get is the right type that they're expecting. Because if they receive something that they didn't expect, like number, and this number just happens to be, let's say, 0 that we give it, well, this user broke our program. So we need to handle these situations where a user might give something bad that we wouldn't want. In the next video, we're going to explore how we can handle our errors. I'll see you in that one. Bye-bye. Error handling allows us to let the script continue running even if there is an error. Let's try an example to show you how we can do error handling in Python. Let's say we wanted to create a program that allows us to take a user's input. Let's say that we ask the user for an age. So we use the input prompt and say, what is your age? And then here, all we're going to do is just print the age. Nice and simple program. If I run this and I type in, let's say 10, there you go. Everything is working. But what if I didn't enter a number and I go like this? Well, that still works, but is that what I wanted to do with my program? Maybe I wanted to enter the age and calculate if they can play the game or not, whether they're 18 and over. How can we fix this? Well, one thing we can do is just to wrap this in an int, right? So we convert whatever the user gives us into an integer. So that if I run this and I type this, I get an error, a value error. Invalid literal for int. I'm trying to convert this into an integer, but it's telling me that's an error. I can't do that. So how can we fix this? With error handling. In Python, we can do it this way. We have the try keyword, which says, hey, I want you to try this piece of code. And we have to make sure we indent it. So we try this piece of code. Now, anything that happens inside of the try block, I'm able to handle, see where handling is coming from errors, with the except keyword. And except says, hey, if whatever's in here in the try block, if anything errors out, I want you to say something. So instead of having this red error that exits out of the program, do something else. Do this. So I'm going to say, print, please enter a number. Let's see what happens now. If I click run, what is my age? I'm going to just write gibberish. And look at that. I get, please enter a number. I am handling my errors here by wrapping all of my code in a try block. So I could have just copy pasted my entire file here, put it inside of a try block. And what's going to happen is instead of my program erroring out before my program crashes, it's going to run this code and then it's going to say, hey, if within this block anything happens, we'll catch it in here with the except block. And I can here do whatever I want. In my case, I can say, hey, please enter a number. But we have a problem here, right? The program just ended and we want this to keep running. I have to click run again and ask for the age once again. So how can we make sure that we keep running this until, well, the user actually enters something valid? Well, we've seen this before. We can do a while loop and say while true, run this. And if this works, well, we're going to hopefully get the age. Let's see that. If I click run, what's my age? Let's say, nope, please enter a number. What's your age? Let's try to break it again. Nope, please enter a number. All right, fine. My age is 10. There you go. I get the name 10, but it's still asking me what's my age. Ideally, I want to break out of this true statement, right? So how can I do that? Well, I can use what we call in here an else block, which we've seen before. But this works with the try except block. We put it at the end. It says, hey, try this. If there's an error, do this. However, if there is no error, else do this. So in our case, we can just say break. And you know what? We can even print thank you, just so we're nice. If I stop this and run again, and I give them my age, there you go. We're done. We broke out of the loop, and everything is good. And this try except else block can go anywhere. We can wrap our entire file in a try except else block. We can just add it into our functions inside of our each individual functions. Whatever we want, we can use. This is just another tool that Python gives us to handle errors. But let me ask you something. What if I did, instead of print age, I did, let's say, 10 divided by the age? If I run my program and I type in here 0 and I enter, I get an error. Please enter a number. But I did enter a number. This is a buggy program. Although I'm typing a number, it's still giving me the same error message. So how do we handle this? How do we handle different errors? One where it is a value error, and another one that is obviously a zero division error. Well, in the except block, I can simply give it what type of error I want to handle. And remember, these are built-in errors in here that I can just copy and paste. So in my case, I want to say this is for a value error. So that if I run my program and I type in 0, I get my error. This accept block only accepts value errors. Any other errors, it does not care about. So what can we do here? Well, one option is to copy here and say, hey, let's add another accept. And in this case, I want a 0 division error. In case a user enters 0, you can say, please enter age higher than 0. So that if I run this now, and I do 0, I get, please enter age higher than 0. If I do some gibberish, I get, please enter a number. If I finally enter a number, look at that. Thank you. Everything is working. Now here's my question. What happens if we enter another value error here? And this value error is just going to say exclamation marks. What happens now? I get, please enter a number. Because this accept block is going to run only once. As soon as it catches the error it's looking for, it's going to run and then come back to the while loop. So only one of the errors will be caught. Okay, let's take a break and learn more about error handling in the next video. Bye-bye. Let's try a different example here. Let's say I'm creating a simple sum function. Yes, I know it already exists in Python, but we'll just create our own. A simple one that takes num1 and num2. And in here, we'll just return num1 plus num2. Now, if we were to just simply do sum1 and sum2, and I ran our program, well, let's print it out first. I click run. I get 1 and 2 because it just adds the two strings together. So let's just do this and click run. I get a type error. Must be string, not int. So based on what we learned, how do we handle this? Well, we can add a try block in here and wrap this function, or we can build it directly into our function. So I can say try this part, and here have an accept clause that says perhaps if we get any type of error, we'll print something is wrong. If I run this, I get something is wrong. But here's the problem. By just doing accept with no exceptions, as a programmer, I'm reading this and I don't really know what actually went wrong because it could be so many things. So a good practice is to always catch these errors based on a specific exception. This way, you know what the error is and you can be more descriptive. So here we can say type error, and this type error, we can just say, please enter numbers. So that if I run this, I get, please enter numbers. So now, all right, my error is more descriptive. I should fix this and make sure that I enter numbers. Awesome. Now, a common pattern when doing error handling is to do something like this. Type error as, and then doing something like a variable. So whatever variable we want. In our case, let's just say error. So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see it clearer. Look at that. It actually gives me the error that I want. So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use this? And I do run. All right, everything is working. Again, if I do plus error and I click run, and this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object. It's a built-in exception in Python. You can't add in here the way I have. Instead, we want to use an F string. So I do F, and then here pass it the error. So that now, if I run this, I get please enter number, unsupported operand, type S for plus, int and str. So I actually get this error available to me. Now, if I was to just print this error, let's see what it looks like. If I click run, you see this is the part of the error that we get. So it's very, very useful if you want to give meaningful errors to your users. Another interesting thing you can do is something like this, where you wrap these errors together. So let's say we have 0 division error as well. And here we'll just say, oops. If we, for example, divide num1 by num2, let's just run this first. I get oops. If I do 1 divided by 0 and I run this, I also get oops. So I can handle multiple errors the same way. I can also say as error here and just actually print out the error. And if I run this, I'll get division by 0. Or if I do a string and run this, I get the other error type. So this again is really useful to combine different errors if you want to handle them the same way. But what if we actually want to raise our own errors? That is, we want to throw our own errors. Maybe inside of this except block, I actually want the error to display for certain types of errors. How could we do that? Let's find out in the next video. Let's go back to our example of our game, where we have a user log in and they have to provide their age. Remember, if I click run, it's going to ask me, hey, what's your age? And if I give it something that it doesn't like, it's going to keep asking me until I provide a proper value. There's one other piece to the try except block that we haven't covered. So we know that we have try, we have except, and then we have else. But there's also another thing called finally. And finally runs at the end after everything has been executed. Let me show you. If I do print, let's say, okay, I'm finally done. Let's see what happens. If I click run here and I give it a proper age, I get thank you because my try block succeeded. Nothing has failed. I go to the else and I say thank you. And now I break out of the while loop. But finally says, hey, no matter what, at the end of it all, I want you to finally do something. Let's see this in action if I do something like 0. I get, please enter age higher than 0. But then also still get, okay, I'm finally done. What if I enter gibberish? I get, hey, please enter a number. But also, okay, I'm finally done. So finally runs regardless at the end of everything. Why is this useful? Maybe you're working on a game server and you want to make sure that you log out any activity on the server. So let's say a user tries to log in, even if they try to enter the wrong information. We want to log that activity so that maybe we can detect that there's people trying to break our program. or just to have our records that, hey, this user has tried to log in 10 times. So finally is very useful. Now, let me ask you a question. What happens if I do something like this? Let's say I have here continue and maybe another break statement here. And then maybe inside of here, I'm also going to have a print. Can you hear me? What happens if I do something like this? Pause the video if you need to. Otherwise, I'm going to hit run and see what's going to happen. What is going to happen if I enter 0? Ready? I get, please enter age higher than 0. Because I get a 0 division error, it catches here, and then we break out of the loop. The finally gets run, but print never runs because, well, we break out of the loop, and remember, this is surrounded by the loop. Let me remove this so we can see it better. Okay, what happens if I do something like this? What if we run the program again, and this time give it gibberish? Let's find out. I get, please enter a number. Okay, I'm finally done. And then what's your age? So what happened here? Well, we tried this. We got an error, a value error. It says, hey, please enter a number. And then it's going to continue. Now continue, instead of break, doesn't break out of the loop, out of the while loop. Instead, it comes back to the top. So it's going to try again this part. What's your age? Okay, so what if we finally try to log in properly and give it, hey, we're 18. What happens then? There you go. I get, thank you, because we've tried it, everything works, so no exception. So we're going to get thank you. And then we break out of the loop. So once again, this print never gets printed. Can you hear me? But then finally, okay, finally is done. If we didn't have this break statement here, and I click run, and give it 18, oh boy, finally, I can hear you. This print finally gets printed because we don't break out of here, we don't break out of here, and then we run this line. Hopefully that makes sense. That was a bit of a trick question, but you're starting to get the hang of it. I'll see you in the next video. Bye-bye. So we've just created a program that isn't going to error out. Hopefully, at least with value errors and 0 division errors. But sometimes errors and exceptions can be so severe that we do want to stop our programs from running. We do want to catch them like this with the except block, but at the same time, also stop whatever the program is doing. Maybe instead of print, we actually want to display that red here and says, oh, something bad's happening, stop that. Well, in that case, we either don't use the except block, or in here, we can say raise value error. Now, this is rare that you would have to do this. There are some specific use cases, but here you would just write a message saying, hey, cut it out. So that if I run this, well, if I type in a valid number, I get, please enter a number. Okay, I'm finally done. Because I raise a value error and it throws in here into the except block. So I'd have to remove this. And if I remove this like this and hit run, enter 5, and look at that. I get a value error. Hey, cut it out. So I'm able to throw my own errors. So this is really useful if you're creating your own library or tool and you want to let the user know that an error happened. I'm not going to keep doing what you're doing. And this could be any type of error. You can also do something like exception. And if I click run here, do 5, I get an exception. Hey, cut it out. The key thing to remember with errors is that errors are unavoidable in programming. What your job is as a programmer is to be able to anticipate these errors, these bugs, these exceptions, and handle them properly in your programs. And some of the biggest errors happen when we're trying to accept input from a user, not just using this input, but functions accepting arguments, classes accepting different inputs from users like method calls, and trying to change attributes. When the outside world in our programs try to communicate with each other, errors are bound to happen. Our job as programmers is to try and code in a way that handles these exceptions gracefully, and we can anticipate these errors. There's no such thing as a perfect program. However, we can try and do our best to learn from these errors and try to manage them so that our programs don't break. I'll see you in the next one. Bye-bye. Let's talk about generators. A very important key term and quite an advanced topic. What are they? Generators are available in Python and allow us to generate a sequence of values over time. What does that mean? Let's explore it. You see, we've actually learned a generator before. Do you remember range? Well, range is a generator. But what is that? A generator is a special type of thing in Python that allows us to use a special keyword called yield, and it can pause and resume functions. So let me demonstrate this with a nice little example. You see, when we use something like range versus something like list, let's say we convert a range into a list, like so. A list, what it does is actually create a giant list, let's say of 100 items in memory, in our computer's memory, versus a range. It creates them one by one. Let me show you. If I create a function, and let's call it make list, and this make list is going to accept a number, and this make list, well, we'll say result equals an empty array. Then I'm going to say for I in range of n, we're going to add result dot append, and let's just multiply for fun I times 2. And then finally, we return the result. You see, when we make a list like we just did here, we're essentially doing this. We're using range to create a list and return result which will live in memory. So let's say that here with make list, I'm going to say my list is going to equal make list 100. When I print my list and I click run, and make sure my parameter here is the right name, and make sure I can spell append, we get our list. But this list over here lives in our memory. My list is pointing to a location in memory. So this is taking up space right now. Now, range is a generator. And a generator is a little bit different because this is not being held in memory. When we do this for loop, this range doesn't create on its own a giant list of, let's say, 0 to 99, and then it starts iterating. No, with the for loop, it's going to say, hey, as a range, I'm going to give you first the number 0, then I'm going to give you the number 1, then number 2, the number 3, the number 4, all the way to 100. So in memory, it never ever creates this list like we have with, well, my list. And this can get pretty hectic, right? Let's say we want to create a giant list now. Let's say that I want to create a list with, well, this entire array. If I wanted to, let's say, print here this giant list, and I click run, oh boy, you see that? That's a lot of memory that I'm using up. And once it's done, which it's still going, only then can I use this list, and it's going to access that list in memory, and then we're able to use it. A more efficient way is to use a generator and actually generate these one at a time without taking space in memory. Now, in order for us to learn how to do that with generators and how to actually use them, we need to go to the next lesson and revisit some old knowledge. I'm going to let this complete. In the meantime, I'll see you in the next video. Bye-bye. All right, this massive list finally finished being entered in memory. But remember our key terms. Remember how I said a list is an iterable? What was an iterable? Well, an iterable is any object in Python which we're able to loop through. Underneath the hood, it has the dunder iter method. So when the object is created, this iter allows us to have an iterable object that can be iterated over. To iterate something, or iteration, is the act of taking an item from an iterable, doing something to it, then going to the next one. When we use loops, like for loops or while loops, we call that iteration. It's the process itself. And generators are actually iterable. That is, everything that is a generator is iterable. You can iterate over them. But not everything that is iterable is a generator. For example, a range is a generator. So that is always going to be iterable. But a list is an iterable, but it's not a generator. So a generator is a subset of an iterable. I know those are a lot of words. Hopefully you're still with me. The difference between a generator and a regular iterable is the way we implement them. So let me show you a general way to create a generator. Let's clear this code and define our own generator. And generators are usually functions. Just like range is a function, generators are usually created this way. So let's say generator function. And this generator function is going to have a for loop that is going to loop over a range, just like we had before. But the difference here, let's actually bring back the code that we had previously. Just going to comment this out so we can see it in terms of difference. The generator function is going to create, let's say, these many items. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here. Now, if we want, just like here, we can pass a number like this. But instead of returning and appending this list and creating all this data, we're going to use yield. Now, what does yield do? You see, yield pauses the function and comes back to it when we do something to it, which is called next, something that we'll cover shortly. So yield says, hey, pause the function, just yield I, give I, and when you tell me to keep going again, then I'll keep going. So how can we do this? Well, I can say for item in the generator function, I'm going to print the item. Now here, what's going to happen is we're going to loop over the generator function, and we'll give it to the generator function, let's say 1,000 for now. And we're going to print each item. In the generator function, because this is an iterable, it's going to run and it's going to loop. And for every item in this number, so that is range, we're going to yield y. So it's going to keep looping and looping. And when we come back, when we loop over, we're going to run this. And the yield comes back and runs again. Let me show you what I mean. I'm going to comment this out as well, and just click Run here. Did you see that? What we just did here is similar to down here, but instead of having to create that list in memory, it just kept going one by one. We only held one item in memory, and we used it however we wanted to. In our case, all we did was print item. Let's explore this yield keyword a little bit more. What does it actually do? Let's say that we want to multiply this by 2, just like we did here in our original example with lists. But now, instead of doing the for loop, let's just call the function and say g equals generator function, and we're going to give it 100. Now, if I print g and I click run, you see that I get a generator object. And remember, this is just the standard way in Python that we can create a generator function using the range and the yield keyword. But this yield keyword gives us some power, because if I just return here, we're not going to get anything special. As a matter of fact, we're just going to get a value. Instead, by using the yield keyword, what we're able to do is to turn this into a generator function that can do, well, this. I can say next g. Now, if I print next g in here and I click run, I get 0. But here's the cool part. If I do next g twice and then one time here and print it, I get 4. Why is that? Remember, the yield keyword pauses the function. So what just happened here is I ran the function with 100. The first item in range 100 was 0. Right? Now here, before I was even able to run this, it said, hey, this is a generator function. But the first time you run it, give the output 0 times 2. So that the very first time we run this function, and I click run, oh, make sure we change that to I. This is just 0. If I run it again, like this, then we have, now I want you to iterate and go to 1. So 1 times 2, what is that? Well, 1 times 2, let me fix that like this. Make sure this is I get 2, because 1 times 2 is 2. If I run it again, and I click run, I get 4. You see, yield, like I said before, pauses the function and comes back to it when next is called. So if it has a yield keyword, it becomes a generator. It keeps track of this state, what we call the value, and it only keeps the most recent data in memory. For example, 4. It remembers that because on, let's say, line 14, if I do print next g, it remembers that previously this I was, well, 4. So now, even though this piece of code already ran, if I run it on line 14, I get 6. Because 3 times 2 well, is 6. Remember, because it gets multiplied by 2. So let me ask you this. If, let's say, I only do a range of 1 here, and you know what, let's just remove multiply by 2. If I do this and I run next more than once, what is going to happen? If I click run here, I get a stop iteration. You see, next can be called as many times as we want, as many times until this range expires. And when we exceed the number of items in the range, well, we get a stop iteration error to let us know that, hey, you can't call next anymore. We've reached the end of line. And when we use for loops with ranges, it actually detects this underneath the hood for you. So we're able to run a function like this where we use range, even though range is a generator, because the for loop automatically says, hey, I'm going to stop looping as soon as I encounter this stop iteration. But that's hidden away from us as users. Now, this concept of generators is pretty hard to understand, especially at first. So you might have to look at this a couple of times. But over the next couple of videos, I want to convince you how powerful they are. I'll see you in the next one. Bye-bye. Okay, I can't see you, but I know what you're feeling. You're doubting me right now. You're thinking generators are useless. You keep saying that they're fast and performant, but I don't really get it. This yield keyword and this next, and honestly, it just doesn't make sense. Let me convince you of their true power. I'm going to select all of these and just delete them because I want to go back to an example that we've used before. Remember when we created the decorator performance in our decorator section? Using this performance decorator, let's minimize it. I have 2 functions for us. A long time function that uses a range, and another long time function that uses a range and then converts it into a list. So remember, one creates a list, and then from that list that's created in memory on our computers, it's going to go one by one and multiply things by 5. Versus a range, which is a generator that comes built into Python, that is going to just one by one hold 0 in memory and multiply by 5, hold 1 in memory but multiply by 5, and keeps going, and removes from memory any old numbers. What do you think the performance of both of these will be? Let's test it out. And by the way, I'll link to the exercise so you can test it out yourself and play around. So let's do long time and then long time 2. Place your bets, get ready, let's find out. The first function, long time, took 1.6 seconds. And then the second function took almost twice as long. That's a pretty big difference, right? But right away we can tell, all right, this is definitely more performant than, well, long time 2. Let's run it again just to test our assumptions, make sure it's correct. This time it took 1.8 and then 2.6. All right, this is so much faster, even though they both do the same thing. And think of this if you were Google. Think about how much data Google has. If you're working at Google, and imagine if this was even bigger, if this was even longer. If you can perform a task that much faster, use up a lot less resources than what Google has, I mean, they would love you. Because with generators, we're able to not hold things in memory, not have to consume all that resources, and instead process data efficiently. And look over here. I was able to solve this function in 16 seconds. I mean, yeah, that took a long time, but long time 2 actually couldn't even make it. It killed the process. If this was a Google server, that's a server that just died and is completely useless. So generators are really, really useful when calculating large sets of data. particularly if we're using long loops, where we don't really want to store that memory, and we don't need to calculate everything at the same time, maybe one by one. And a lot of libraries in Python, underneath the hood, use generators instead of using lists because they're so much faster. So remember, to create a generator, all we have to do is create a generator function that we want. And then in here, we can just simply loop over some value that perhaps we give it to a range, or we can just accept as parameter. And all we need to do is simply yield that result and do whatever we want in this block, but make sure we pause the function so that later on it can be used as a generator function. So we can do something like a for loop and say item in gen function and give it some sort of parameter. Welcome back. I want us to understand how things work underneath the hood. So I'm going to show you two examples of implementing our own for loop and then implementing our own range function. So the first one is our for loop. So I'm going to say special for loop. Underneath the hood, all it's doing is receiving an iterable, and then we're going to say iterator is going to equal an iterable. Now, for us to have an iterable, we have what we call an iter function that accepts the iterable we just passed. Now, this iter function is going to allow us to use the next function on this iterable. So stay with me. I'm going to say while true, I want to try. And in this try block, we'll say iterator. And we can perform, let's say, some sort of operation here if we want, or we can just call next iterator. You know what? Let's print something here just so we see what the iterator is. And then finally, I want us to stop when we have the stop iteration exception. Remember the one that we saw where there's no more items in the iterable. And here we simply can just break. Oh, and make sure that I have the colon set correctly. So now, if I do special for loop and give it a list of 1, 2, 3, and I click run, check it out. I loop through some iterable objects using next. And you see that this object exists in the same memory space, even though we're constantly looping through it through 1, 2, 3. So this is how for loops work underneath the hood. When we do for, let's say num in and then give it a list, it's going to go through everything. It's going to turn it into an iterable, and it's going to keep running and keep calling next iterator on it over and over and over until we finish the end of the line and then break out of the loop. And how do we check the actual values of the iterator? Well, remember, the next function is going to output whatever the item is next. So if I do print here and I click run, I get 1, 2, 3. So I can just do times 2 if I wanted to, click run, and there you go. Our special for loop just multiplied our list by 2. That's it. That's how for loops really work. But what about ranges? Can we create our own range function? We absolutely can. And this is a fun one. Let's create a class. And this class, because at the end of the day, we're just going to create an object that has actions that we can do. So I'll say my gen for my generator. And this is going to mimic what a range does. So I'm going to have a class. And this class will have a init function we'll have a self, a first, and last. So this is how a range, we're able to say start with this and end with this. And in here, we'll do the typical self.first equals to first, and then self.last equals to last. And I'm using a class here because, remember, we're just creating our own data type, our own special range in Python. Now, we have our simple generator. And ideally, we want to be able to say gen equals and instantiate my gen to have, let's say, 0 to 100, just like we would with a range. And ideally, we can say for I in gen and print I. Because, I mean, that's how we're able to use ranges, right? So how can I make this work? Well, we can use our dunder methods. So remember how we have the iter to get an iterator and use next on them? Well, we have a define dunder that is iter. And iter allows us to create an iterable. So in our case, I'll say self, and here I'm just going to return the actual class, like so. And then finally, we want to be able to run the next function on our gen, because we saw how for loops work. We need to be able to use the iter and then the next on them. So once again, we can use a dunder method, which is conveniently called next. And this is built into Python. So if I do here self, and all we want to do here is to let it know how we want next to work. Well, I'll say if, and we need some sort of state or data to keep track of where we are. Remember how generator functions remember where they are? Well, we can create a class object attribute. So I can say current equals to 0. So this is where we are currently on our iteration. And say my gen.current, as long as that is less than self.last, which will be the 100 here. If that's the case, well, I want a number to equal my gen.current. I want to increase my gen.current by 1 because we want to say, hey, we're moving up to the next location. And then return the number. Because that's how next works underneath the hood, right? We increment our current location by 1, and we're simply returning the number, which is, well, in our case, it's going to be 0. And we want to keep going, well, until current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works. I'm going to run this. And look at that. It's all working. I was able to loop through my generator and print I from 0 all the way to 99. Again, if we go back to our example here, and I know this is a little hard to look at it at first, but all I did was say I want an init function to have the option of first and last, and I'm going to want to be able to iterate through this object that I'm going to create, and I also want to be able to use the next, which for loop, if you remember from our previous example, needs. So I'm going to say for item in gen, just loop through it. I'm able to loop through it because this is now an iterator, and I'm able to use the next value on it because I allow us to loop and constantly increase by 1 until we keep returning the number until my gen.current becomes 100. And 100 is not less than 100, which is self.last. so it's going to raise a stop iteration. The for loop automatically catches that, so it doesn't error out, and it stops looping. That's how things work underneath the hood with range. Now, you don't need to know this. You're not going to be asked in your day-to-day to implement this, but I wanted to show you that this is how things work. I think that's important. Let's do a famous exercise, and this might come up as an interview question. We're going to try and implement Fibonacci numbers, and Fibonacci numbers are like this. The first number is 0, then the second number is 1. They always start with 0 and 1. Then, this is what happens. We add 0 with 1 to equal the next number. We add 1 with 1 to equal the next number. We add 1 by 2 to get the next number, 2, 3 to add the next number, 5, 8 to add the next number, so on and so forth. As you can see, this grows exponentially. Well, it grows really high, really fast. And this sort of numbering actually shows up in nature a lot. But it's also an interesting problem because these numbers, although at the beginning grow really, really slowly, they become larger and larger and larger. And it becomes a problem that can really hog up the resources. So this is what I want you to do. We're going to create a function, fib, that takes a number, and in here, this number is going to be the index number of the Fibonacci. So for example, if it was the 20th number, it should have this. So if I wanted, let's say, fib 20 here, in that case, I want you to return all these numbers using generators, so that is one by one until we get to this location. Now there's two ways of doing this. We can do it with a list, or we can do it with a generator. And you'll notice that with a generator, it's a lot easier to do than with a list because eventually with a list, you're going to run out of resources. So what I want you to do is to output on here the numbers that you see here all the way until 20. And if you want, you can keep increasing that number and see what happens. And as a bonus, you can try implementing this with a list as well, so it displays in a giant list as well. Pause the video if you want here. Otherwise, I'm going to keep going with the answer. First, what we want to do is say A is going to equal to 0 and B is equal to 1. So A and B are going to be the start of the numbers. Now in here, we're going to use the range generator to loop these number of times that we're going to provide the function. Now in here, first, I want B to now, or A to now equal whatever B was, which is 1, and B to be whatever the next number is. Remember the rule with Fibonacci. We add the first two numbers to get the third number. So we have A, B to get the next number, then A, B to get the next number, and then A, B to get the next number. So the first thing I want to do is to actually yield A and say, hey, just give me whatever A is, and then pause the function until the next part. After that, after the for loop goes to the next part, I'm going to say I want A to equal B, and I want B to equal A plus B. Let's see if that makes sense. I'm saying, hey, return or yield A from this list, so it'll be 0 at first. Then I want you to make A equal to 1 now because we're moving over. And then I want B to equal 1 because A has turned into 1. And then the 1 previously. So B becomes 2. If we look over here, that's what we want. We have A and B here, and then we want to move over just 1 like this. So B should still be 1. So what we might want to do here is to actually not modify A until we are able to do A plus B. So how can we do this? Well, we can simply say, let's say a temporary variable, and this temp is going to hold on to whatever A was when we get here, which is 0. And then we're going to modify A to equal 1. And then B is going to be, instead of A plus B, will be temp, which is 0, plus whatever B was originally, which is 1. I know this can get confusing. You might want to pause here and maybe print and see exactly what's happening. But hopefully our function works now. If now I do something like for x in fib and give it, let's say, 100. And let's just print out the answer. So print x. And I run this. All right, look at that. I get all my Fibonacci numbers. Let's do 20 like we saw in the example. If I click run, I get 4181. So I'm at 19 because remember our count starts at 0. So technically here, if we want, we can do 21 here, click run, and we should get 6765, which is what we get here. Very, very cool. But you can see how the number increases dramatically as we increase to 1,000. Now, if we were to do this in a list, it would look something like this. Let's copy here. Now, fib2 with a list would mean that we have to add a list in here. And instead of yielding, we'll do result.append. And we're going to append whatever the A value is, which is the initial value. And then we're going to do the same thing we've done before. So instead of yield, we're now just appending to this list. And at the end, we just return the list result. Now, if I return this, let's say fib2, and give it 100, and I click run, let's comment out the original one with the generator. Well, we should probably print this, shouldn't we? So let's do print, and click run. All right, that's a massive list. Now, if we were to do 1,000 here, you see that it's taking quite a bit of time. What if we do 10,000? All right, it's definitely taking some time, and you can see over here how hard this is working. You know what? I'm going to stop it and go back to our generator way, and let's do 10,000 here. Let's see how 10,000 looks with the generator. Well, it's still working hard, but I'm not keeping any of this in memory. We're taking it one by one, and I can act upon it, in our case, just printing it one by one. Now, this is a common interview question. It's actually a little bit unnecessarily confusing, I think. But it does demonstrate the power of generators. You might have to watch this video a couple of times, but hopefully by now you're feeling a little bit comfortable with using ranges and how we can improve performance using generators. I'll see you in the next one. Bye-bye. Up to this point, we've learned about a few ways to organize our Python code. The first thing we did, well, we just wrote Python in a file, and that organizes it, right? Our entire code has been so far on one single file. So that was one way that we organized our code. Next, we learned about functions. And functions were used as a way for us to not write code that we repeat over and over. We could write functions that we can use anywhere we want in our file, so that we can call these functions over and over. And we can name the functions appropriately so that our code makes sense. And then we learned about classes, right? these blueprints that we can create objects from. We can instantiate new Python data types beyond the ones that they just gave us, right? Instead of just having dictionaries and lists, we can create our own custom ones, our own lists maybe that have extra features. And we're able to use classes to organize our code, to box them up, and give each class a certain method and attribute that packages it nicely for us to use. We also learned about functional programming and how, unlike, let's say, object-oriented programming, where we see a lot of classes, with functional programming, we just use a lot of functions, a lot of pure functions. And we have data that we just pass into those functions. And we organize things into small little pieces. All of these things were meant for us to keep our code clean, make our code more maintainable, thus keeping our code organized. Because as we write more lines of code, it gets harder and harder to keep everything in your head. If other people join your team to work on your project, they need an easy way to figure out how things are working. But we still have a problem. And that problem is that everything is contained in this one file. All the functions, all the classes we've been writing has been on just one .py file. But in real life, this isn't the case. We have a lot more code. And we can't just have one file with millions of lines of code. So how do we stay organized? Well, if we had multiple files of Python, like this, because our project is getting bigger and bigger, would this work? Is there a way for us to link all of these files together? As a matter of fact, there is. And this is very common practice all across industry. And we call this way of organizing code modules. And modules are simply, well, these files. Each one of these files, each .py file is a module. And by building these modules, kind of like we built different functions, kind of like we built different classes, because inside of these files, we can have classes, we can have functions. But we can also have different files, so a layer higher, to divide up our code. And in this section, we're going to learn all about modules and try to master it and see how we can write organized code. Let's have a look. You can see over here, if I click on files in our REPL, we have main.py. And every time I click run, this file got run. But what if we have more files? What if I add another file here? And we'll call it utility.py. So based on what I just taught you, these two things are what? They're modules, right? Main.py is a module, utility.py is a module. And when writing modules, we use the same principles as variables in Python, which is snake case. That is, if there's spaces, we use underscore, everything is lowercase letter. So how do we divide up these modules? And this comes with practice. When you're just beginning, it's hard to say, hey, what goes into what file, what goes into what file? But it's similar to classes, right? Similar to functions. We want to divide up our code into chunks that make sense. Again, let's say we're working at Netflix. We might have a file dedicated to videos. We might have another file or module dedicated to the login of a user. Maybe another file dedicated to analytics and figuring out recommendations for users. We want to group these classes and functions together inside of a file that makes sense. Now, one of the most common ways to use a module is something like a utility. Let's say we want to create a utility module. That is a module that has a lot of, well, kind of like a tool belt. Very simple functions that we can use all across our project because we can imagine here having multiple files. So let's create a very simple example. I'm going to say a multiply function exists here. And this takes a num1 and num2. And in here, we're simply going to return num1 times num2. A very simple function. And once again, we'll also have a divide function. And yes, this is kind of useless because we can just use the plus or the divide operand in Python, but stick with me here. I'm trying to show you an example. All right, so num2. I'm going to return num1 divided by num2. Nice and simple. So this is our utility module that has all these functions for us. Now, notice here that we're actually not doing anything in this file. I'm simply defining functions, but I'm not running any of the functions. But let's say we have this utility module and I want to use it in my main.py file. How would we go about doing this? Well, the way we communicate between these two files is quite simple. All we need to do is use the import command. We import and then give it the file name that we want to import. What do we want to import? We want to import utility. Just like that. And notice that I'm not adding the .py because we assume that whatever we're going to import is going to be a Python file. So we don't need to do that. Just the name. Just like that. Now let's print utility here. If I run this, whoa, do you see that? We have module utility from, and then this is a file path that this website generates for us. So it doesn't really matter. Now, there's a few things that happened here. One is that we generated this PyCache folder, __ PyCache. And oh boy, what is this gibberish? This is pretty confusing, right? Well, this PyCache is created every time we run a file with, let's say, import statements. So when we're using modules. You see, what PyCache does is when we click run, the interpreter is going to create this PyCache folder and it's going to say, hey, I'm running this file, this one main.py file. Anything that main.py file imports, let's say utility in our case, I'm going to cache it. So see how here it says .pyc? This is because it's using the C Python interpreter. Remember? This is the C Python, which is the interpreter written in C. So this is actually a compiled file. So that next time I click run here on my main.py, nothing changes. Because what's going to happen is instead of loading up utility.py, it's going to load up this compiled version of utility because nothing has changed in utility.py. And this makes things faster when I try to run main.py again. That's what caching is. Caching is, hey, I'm going to remember this and this is the compiled version so I don't have to go through the compilation step again. But notice that the main.py file does not get compiled because, well, we run it every time. Now, if we change the utility function to not have the divide in there, I click run, and you don't notice it here, but this has now been rerun because we have a different file. You see that we have multiply here, but not divide. So let's bring back divide again. Go back to here, click run. And there you go. We have divide here too now. But this is something that we don't touch. This just comes underneath the hood with any editor that we use. And in a few videos, we're going to show you how this also happens when we use something like PyCharm. This is just something that editors allow us to do just so our programs can run faster. So I now have access, let's make this a little bit smaller. I now have access to utility. And here's the interesting part. If I do dot here, look at that. I have access to divide and multiply so that I can multiply numbers, let's say 2 and 3, click run. And I'm able to use the utility module in my main file. Very, very cool. If I do divide and I click run, I can use this as well. Very, very cool. And I can import as many times as I want. If I had a different file in here and I want to import another thing, let's say there's a utility2 file. Well, I can import that and import as many things as I want and use them across my files. How cool is that? So now we have a way to organize our code and have all these files communicate together. Because in real life, we have big projects. And these big projects are going to be worked on by different teams, different programmers. And we need a way to work with all these files. And by using the import statements between modules, we're able to use functionality, just like we were able to use the functionality that functions provided us between different files. And most of the time, if you're working at a company, the first couple of lines on a .py file are usually import statements because usually you're communicating with other files. Let's learn some more in the next video. Welcome back. We just learned about modules, but let's say our project is getting even bigger. We have this main file, we have some utility, but let's say that we're now working for Microsoft and we have a new, let's say, shopping functionality, an entire, let's say, shopping area where you can buy Microsoft t-shirts. Well, we can now create a folder, so we can add folders to our project. And inside of this folder, let's say we have a new file, and we'll call this the shopping cart.py. So now this shopping cart.py is a folder in our project. You see that our project is getting bigger and bigger. And let's say that here we just have a function called buy, and we give it an item. And let's say here we have a cart variable that, let's say, adds. It's not a very sophisticated buying system, but for our example, it should be fine. And then we just return the cart. Now in here, we have this buy function. And let's say in our main file, so up here, we want to also import our shopping cart buy function. How can we do that? Well, if we try to do shopping cart like this, remember that's the name of our file. You see that I get an underline that says imported but unused. Okay, so does that mean I can use it? Let's see. I'm going to say shopping cart, and if I click run, module not found error. No module named shopping cart. You see, what we've created here is what we call a package. A package is simply a folder. And we learned about module, which is these files, these Python files. A package is a level up. A package is a folder containing modules. So you can have a package with multiple modules inside of them. So this shopping cart is a module, but this shopping is a package. So the way it works when we import from a package is we say the package name. So what's the package name? It's shopping. And then we do a dot. So dot shopping cart. So package name and then the module name. Now if we do this, let's see if this works. Let's say I do shopping dot shopping cart now. If I print this, let's make this a little bit smaller. All right. Now I have access to the shopping cart module by importing the package shopping, which is the folder, and then the shopping cart. And you notice once again, we have a PyCache that was created for the shopping cart. So let's see if we can use the buy function. So I'm going to say buy, and then item, I'll say I'm buying just an apple. If I click run, there you go. I get my apple list, and I was able to import it from a package. Now, here's the thing. I want to try and copy what we've just done into a real life scenario. Instead of using this website, REPL.it, let's actually create our own project. I'm going to use PyCharm, and I recommend you use PyCharm as well, just for these next couple of videos. Let's open up PyCharm, and let's just create a new project here. Now we can call it whatever we want. So let's just call it modules for now for our project. You can see where it's being saved. And remember here, we get to pick what interpreter we want. We're going to talk about this virtual env later on in the videos, but the key thing is to make sure that our base interpreter is using Python 3. In my case, the Python 3 that we've downloaded in user local bin. If you're on a Mac or Linux, if you're on Windows, this path will probably be different. Now we can just create a project. And we see here we have our modules project. Now we're going to ignore all of these folders for now. We're going to talk about them later on. The key here is that we want to create a new file. I'm going to just right click here and say new Python file. And we can just call it, let's say, main.py. And notice here that I created in a folder called venv. We'll get back to that shortly. Now let's make this a little bit bigger so we can see. And we're going to copy whatever we've just done here. So I'm going to copy the main file like this. Oh, that did not copy. Let's try that again. Like that. And then we're also going to create a few more files. So we'll create a folder. So in here, I'm just going to say right click, say new. And right away, you see that it says Python package. I'm going to click on Python package, or I can create a directory if I want as well. And when I click here, let's name the package like we've done here as shopping. All right, we get our shopping folder. And in here, let's right click, say new file, and we'll call this the shopping cart.py. So shopping cart.py. And then finally, we'll add our utility file. I know we're doing a lot, but hey, I'm trying to prove a point here. Trust me, this is going to be important. So utility.py. There we go. So we have the same setup that we have here. Let me copy this over as well. All right. And we copy. Let's make this bigger like that. All right. So we have our files just like we have in our REPL, except this time we're actually using an IDE. Now, the reason I wanted to transfer over to the IDE is that there's an extra file here that we didn't see in the REPL. And the REPL actually hides this away from us. You see this underscore init.py file, and it's completely empty. There's nothing in here. One of the rules of a package, of a Python package, is that on the root of this package, you have to have an underscore init __.py. Now, why is that? Well, because the interpreter is going to read this and say, oh, this is a Python package. Remember how when I right-clicked here, I said new, and then I had an option of a directory or a Python package? By clicking Python package, it automatically added this init for us. So although here everything worked without a init, this is just something that REPL hides underneath the hood. Anytime you want to create a package, you'll see that we need to have an init file. And it can just be completely empty. Now, the beauty here with PyCharm is that it does it for you, which is really, really nice. Okay, so let's run this code and make sure that it still works. So this is our main.py. I can simply run the code here by going to run and then selecting run. Let's run our main file. Oop, and we get an error. Let's zoom in here. And we see that module shopping.shoppingcart has no attribute by. And that is because we did not import the buy function here. So let's do that. Let's go to shopping cart, buy. Make sure I copy that, paste it in. Let's zoom that in. And by the way, I'm zooming here on my touchpad. I can just use 2 fingers to zoom in here. If I click run again, and this time once you ran it once, you can just click on run again. And there we have it. We have Apple right here as the output. And it says process finished with exit code 0. In programming, when something exits with code 0, it means there were no errors. If you get 1, well, that's usually an error. All right, so we have everything working, and this is now our setup. We have our main file. We have our other modules like utility. And then we also have our packages, and they're packages because they have this init file, and we have different modules in them. And as projects get bigger and bigger, and we use IDEs like PyCharm, we organize our functionality, our grouping into these packages and modules. And really, really good developers are able to organize code in really nice packages that make sense, really nice modules that make sense. This is a skill that is really hard to teach. It just comes with practice, by looking at other people's projects, by working on projects. But the key thing is that you want to do what makes sense. And when we start working on some of our final projects, we have over 10 projects coming up that we're going to work on. Now, with those ones, you're going to start to learn different ways to organize code as you follow along. So don't worry. Let's take a break and explore modules a little bit more in the next video. Let's learn about different ways that we can actually import these modules. Up until now, we've only learned about import. But sometimes things can get pretty hectic. For example, we can actually have another package inside of another package. If, for example, I create a new folder here and say new Python package, we'll call this more shopping. Click OK. You see that I've initiated another package inside of a package that has its own init file. And let's move this now to, let's do refactor, move, and we'll move it inside of the more shopping folder. So I'll say more shopping. If I click OK, you'll see that I've moved this module over here. So I have a package inside of a package. And the way we would access this is to say simply shopping dot more shopping dot shopping cart. And let's copy that over and do the same here. And now when I click run, you'll see that it still works. But this is getting a little bit too crazy. You can imagine as we have more and more packages that we constantly have to do this dot, and this is getting a little too long and ugly. So how can we better this? Well, one way of doing this in a cleaner fashion is to do something like this. Instead of saying import, we say from this part, I want to import the function. So here I'm saying, hey, from package name module, import whatever function I want. In our case, we want to import the buy function. So you see here, I can just do that. And in my code, I can just run buy as if it was part of this main file. If I run this, you'll see that it still works. Awesome. So that's definitely cleaner. And we can do this with utility as well. I can say from utility, import, and actually import the two files or the two functions. So that is multiply. And if we want another function, we can just add a comma and say divide. So now we can print apple or buy apple as well as divide. Let's say 5 by 2. And we can also multiply. Oh, and make sure it's a comma here because it is a function like this. So that if I run this, you'll see that there we go. This works as well. So this is a really nice way to clean up your code. You can also do something like this, where you say from package name, and then import the entire module. So let's say I want to import the shopping cart module. I can say import, so package.package, or you could just have done one package, and import the actual module shopping cart. So now I would access it like this, shoppingcart.buy. And this is going to work as well. Perfect. Now, the reason you might want to do this instead of what we had before is that sometimes you can get name collisions. Let me show you. Let's say I had a print, and then in here we use the max function, which gives us, it's a built-in function, we give it an iterator, and it finds the max for us. So that if I run this, you'll see that the max in this list is 3. Well, imagine in our utility function, we have let's say instead of divide, or we add a max that simply says, returns an oops. Well, if I go back to my main.py and get max as my function, and I click run, well, you see I get an error. I get max takes 0 positional arguments, but 1 was given. Because now max doesn't mean what we thought we meant, at least in this file. We've imported max, and well, max is a whole different function now. So we can actually override existing functions. So by using something like this, shopping cart, we make sure that we have only one case that we might have name collision, but all the properties or all the methods that shopping cart has are connected to shopping cart. So instead of having multiple functions that could be overridden, I only have one namespace. And by the way, this is also one of the reasons that I don't recommend doing something like this. You can actually do import star. And what this says is, hey, from the utility module, import everything. And when you do that, you'll see that once again, we get an error because it imports the max as well. And because we don't even know what's being imported right now, we can't see it. We have to go to the file to see it. When we get an error like this, we're going to be like, what's going on? I thought max is working. And it's because of this line. So it's always good to be explicit and say exactly what you want to import. But let's remove max for now. But as you can see, modules can be imported in different ways. My recommendation is to always be explicit and say exactly what you want to import. And the format usually follows either using the import statement followed by the package.module or import the module, or you can do the from statement to give it package, subpackage, and module if you want, or you can do module and then saying import and the specific function or the actual module itself. Many ways of doing it depending on your need. The key takeaway here is that modules and packages help us have good engineering practices and build big projects in an organized fashion, yet still have all these files talk to each other. All right, that was a lot. Let's learn more in the next video. Welcome back. In order to finalize our understanding of modules, we have to talk about an important concept, which is this idea of main, or specifically __ main. Because as you start developing in your career, you're going to start to see a lot of code like this. Now, this is one of the most common lines you're going to see when working with Python. And in this video, I'm going to explain what it does because it is one of the most confusing topics, especially for beginners. So for now, I'm going to comment out and do a few things. We have our main.py file here. And I want to do a few things. First, I'm going to open up our shopping cart, which is right here. And at the top over here, I'm just going to print, because right now our file isn't doing anything, I'm going to say print underscore underscore name, like this. And I'm going to do the same for the utility.py. So at the top, utility.py. Now, if I run main here, let's click run here, I get these two things printed. Now, why is that? Well, when I run a Python file, usually we just run one file, right? The main file that we're working on. In our case, our main file just happens to be called main.py. So when I click run, the interpreter goes line by line through here. The first thing it does is import the utility module and import these two files. So what it's going to do is go to the utility file and run this. And automatically, each file that we run, or each module, is given a name. In our case, it's the name of the module, utility. So when you import something in Python, it finds the module, it runs the code, so it adds this code to memory because we're going to have to use multiply, divide, and max, and then goes on to the next line. In our case, it's this one where we import again from the shopping cart. So it's going to say, hey, the name of this is shopping.moreshopping.shopping cart because that's the module name. And then finally, it's going to go through here because by this point, by line 4, these files have been run and they're in memory now. Now the interpreter has access to divide, multiply, and all these functions that we've imported. Now, here's my question. What if I do here, or at the end, do print underscore underscore name on this main file? If I run here, you see that I get underscore underscore main. Is that what you expected? What if I change the name of this file? Let's say refactor and say rename. Yeah, that's okay. We want to rename it and we'll rename it to, let's say, test.py. So now this is called test.py. What do you think the underscore name of this is? If I run here, I still get underscore underscore main. So maybe this is starting to make sense now. When you see the code this, if underscore underscore name equals to underscore underscore main underscore, so these are dunders, then do something. And this, the name main is given specifically to the file that we run. Because remember, when we run a file, when I do play, or when I do in my terminal, Python 3, and then say test.py, I run that one single file. And that one single file imports different modules and runs them. That one file that we run gets this default underscore underscore main. So the reason you might see lines like this in Python is that sometimes we want to make sure that we run a module only if this is the module or the main module. So I can say here, print, please run this. And let's remove this print for now and click run. You see that this, I get, please run this. But if I copy this code and let's say put it into utility, like this, and I click run, you see that please run this does not appear in utility, only at the end when we're running this test. Because why? Well, the name of this file is not main. The name, remember, is utility. So this is a good way for us to only run code of the main file. So this is a common structure as projects get bigger and bigger. Maybe we have code that we don't want to run unless it's the main file. In our case, let's say that we don't want to run any of these unless this is the main file being called. If I run this now, you see that, oh, and I get an error. It says line 1 in module cannot import name multiply from utility because, well, we aren't able to import this because we didn't run this piece of code. So let's revert that back, come back here, and what we can do now is actually wrap this entire thing like this, so that we make sure that test only runs if, well, that only if this is the one being run. It shouldn't get imported. It should just be the main file that we run. Now, remember when we had a class? Let's say we had a main file and we created a class, let's say student. And this student, let's say, doesn't have anything, but when we do type of student and we do print here, and I click run. Oh, let's instantiate the student. So let's say student1 equals student. And let's just get the type of the student. If I click run, do you remember how we have this underscore underscore main dot student? What it's saying is this class was created in the main file that we ran. If, for example, I copy this, added it to the utility like this, and now in my main file, I import utility, and let's say utility.st1, and do type, and then print, what will happen then? Well, we get class utility.student. So whenever we saw that main, all it was saying is, hey, this was a class that was created in the main file. Again, this is one of those things that you're going to see a lot of, but at the end of the day, all it means is I want to make sure that if this is the file that's being run, because a file can be either run or it can be imported. If this is the file that gets run, it's the main file, then do something. So it's a good way to check how our modules are being used, whether imported or ran. Hopefully that made sense. In the next video, we're going to talk about something exciting called built-in modules. I'll see you in that one. Bye-bye. One of the key features of Python is that the core language that we've been learning up until now is pretty small. As a matter of fact, we've pretty much covered most of Python. Now, Python was created in this small, tiny package as a feature to keep things simple. Although you may feel like you've learned a lot, at the end of the day, it shouldn't have been that bad because there's not a lot of things to memorize. We also learned how to organize our code so that we have multiple Python files. But the reason Python is so popular, and it's used in all sorts of industries, from big tech companies like Google and Netflix to Amazon, to small projects and people like us who just maybe are single developers building tiny projects. Python is extremely useful through what we call external modules and packages. That is, outside of what we get from Python, well, we have an entire package system where we can borrow and expand on the Python functionality. And these are called Python's built-in modules. Let me show you what I mean. If you go to the Python documentation, they have the Python module index that I'll link to. And here we have all the modules that Python give us. Now, these modules actually were installed when we downloaded the Python interpreter. It comes with Python, but in order for us to use them, we have to import them. These are the built-in modules, and they're really, really nice. For example, do you want to send, an email? Well, there's an email module. Maybe you want to really do some mathematical operations that are complex. Well, there's a math module for that. And there's a module for a lot of things. Now, don't get scared. This looks like a lot, but you're not supposed to memorize any of these. You just need to know that they exist so that when you're Googling something, you can type in Python built-in module. And let's say, for example, you want to build a game. Say Python built-in module game or graphical user interface, and check if the module exists. I have to say, I've probably only used 30% of these, but they're there for us to gain extra powers. In other languages, this might be called a standard library. That is, it's a standard library maintained by the Python community members, and making sure that these packages work really, really well with Python and that they're built into the language. So let's learn how to use them and use one of my favorite ones, which is called random. So let's see here if we can find it. random. Generate pseudo-random numbers with various common distributions. And you can read all about it here. It's a long read, so let me just show you. Now, the beauty is that we've actually installed this. Whenever you install Python on your machine, you get access to all the built-in module, the standard library. So all I have to do is say import random, and now I have access to random. If I run this, let's click run. Look at that. Module random from library frameworks Python. You see that it's in versions 3.7, library, Python, and random.py. This is actually installed on my machine, and it should be installed on yours as well if you followed along and installed the Python library. Now, where is this? Where you can actually see it in our pie chart. If you go to external libraries here and you open this up, you see here that I have the Python 3.7 modules. And if I scroll down and you go to Python 3.7 or whatever your installation was, and scroll all the way down to, let's say, R, where is it? Where is it? As you can see, there's a lot. Here it is, random.py. This is installed on our machine. And if I double click this, look at that. I have the random variable generator, and this is the file that allows us to use random. And you can see over here that random is a class that is going to allow us to, well, use all this functionality. And look at that. It even has this little line that I told you about in the previous video. Only run this test function if this is the main file run. This is probably something that the maintainers of this module, whoever coded this, added to say, hey, don't run this for anybody else, but if, for example, we're working on this and we want to run the test function to test that all of these things are working, then run that. But in our case, when we use random as users or consumers of module, this is never going to run. Very, very cool. Now, you can see here how many modules we have. And we even have some packages like the email package with, well, a whole ton of things. So this is already existing in our computer. And that's why we have access to import random. So let's learn more about random. Now, what I like to do usually when I'm importing a library and I don't know what it does is to actually use the help function that comes with Python. If I run this, you'll see here that I'll get a help message with, well, all the information and documentation of what it does. So it gives you some description. If you scroll down, it shows you some of the code and some of the methods that perhaps we get, which is really, really nice. Let's lower that down. Another thing that I like to do after perhaps I read the documentation is to do the dir function. And if I click run, and let's actually print that. If I click run, here we go. It shows me all the methods available on this package. So I can see, all right, all these things that I have rand range, sample, seed that I can use. If you're using an IDE like PyCharm, I could just do dot and actually see all these methods as well, which is really, really nice. All right, let's have some fun with this random module. Random has, randomly, a random method. So random.random is going to give us, well, let's print it out and find out. It's going to give us a random number between 0 and 1, as you can see here. So this is really useful. Another thing it does is it gives you a rand int, which is a random integer, and we can give it the first parameter, where it should start and where it should end. If I run this, look at that, I get 4, then 1, then 6, then 2, just a random integer every time between the start and the finish. Another useful one with random is something called choice. And here, inside of the choice, we give it, let's say, a choice to make. For example, a list 1, 2, 3, 4, or you know what? Let's do 4, 5. If I click run, it just makes a choice. Picks one from the iterator list that we have, which is really, really nice. Just random choices. So why is this useful? Well, maybe you want to build, I don't know, a roulette game, or a game where you need a random generator between, let's say, number 1 to 10. So this is a nice way to just do that without coding it yourself. Another one that I like is called shuffle. And shuffle, if I click run here, I'm probably using it the wrong way. So how can I find out more about this? Well, this IDE allows us to actually select and do view quick documentation, which you can see is F1 in my case. It might be different based on your machine. So I can just say F1 and look at that. Well, I see that shuffle has the sequence X in place. That is, it modifies whatever list we're giving it in place, so it returns none. So what we need to do is, let's say my list, that will be 1, 2, 3. Let's add a few more, give my list in here. And instead of printing that, after we've shuffled things, we'll say my list and then just print this. If I click run now, there you go. I've shuffled my list in place. Very, very cool. Now, another import thing that I haven't shown you yet, and you don't see it as often, is to actually do something like this. I can say from random import shuffle, or I can actually do an alias. So I can say import random as, and then give it an alias. That is whatever we want to call it in this file. So let's say ooh la la. So in that case, random becomes ooh la la. So you can actually avoid name collisions if you want. So if I click run, this should still work. But again, a good practice for me personally is to always import only what you need. In our case, we want to import from random just the shuffle. So I'm going to say shuffle because I'm being explicit here, and when a developer comes and sees that I'm importing shuffle from random, they know that I'm only using this function from the random file, and there's no guessing involved. Just like this. Let's learn some other built-in modules in the next video. Welcome back. I wanted to show you one other package. Mind you, we have a video coming up on useful built-in packages in Python, and we'll go over some of my favorites. But I want to show you one that's a little bit different than what we've seen, which is random. And this one is called sys for system. Now, import sys, if I do something like, let's say print sys, and I click run, I get a module sys built in. And sys is a really, really useful one that you're going to see a lot of. Now, with sys, you can do something really interesting. For example, sys has something called argv. And argv gives you some interesting powers. You see, up until this point, we've just kind of ran our code inside our IDE. But what if we had a terminal here on our desktop? And by the way, see over here that we have the venv. Again, something that we'll cover, so don't worry. Now, in here, I have a 1.py file, which is completely empty. It doesn't do anything. So let's just open that up. I'm going to open it up with Sublime Text just because it'll be easy. And in here, I'll just say print hi. So this is a Python file that lives on my desktop. So I'm going to save that. And imagine here that I did Python 3 and then do 1.py. If I ran this, I get hi from my terminal because this file's on desktop and I ran the Python interpreter on this. But what if I wanted to do something interesting? What if I wanted to give parameters to this file? Perhaps say that my name is Andre. Well, with sys.argv, we can actually access those. And I can give it as many parameters as I want. So let's give it another one like this. Let's go back to 1.py. Once again, open up with Sublime. And in here, I'm going to import sysrgv, and I can access these parameters like this by an index. So 0 index will be Andre, and 1 index will be Nagoe. So let's try that. I'm going to say first equals sys.rgv 0, and then last will be sys.rgv 1. So that now I can do an f string and say hi first, then last. Just like that. So if I save this and now go back to here and ran my file like this, all right, I get hi 1.py Andre. And I made a little bit of a mistake here. It looks like the first index is actually the file name. And then you get the optional names. So it's an easy fix, right? All we have to do is say 1 and 2. If I save that and click run, look at that. I get hi, Andre, Nagoe. Now, using this knowledge that we've gathered so far, I want you to use the built-in module, this sys and the RGV, to build a game. I want a game where I can run it like this from the terminal or the command prompt, where it's going to ask me for an input and say, hey, guess a number between 1 and 10. And it's going to let me keep guessing until I get that number right. So you might want to use, I don't know, the random module that we've learned. So take a break, try to create that. Now, this game, beyond just asking for a user's input and giving you a guess, 1 to 10, can also be customized. So that instead of just, let's say, running the file, I can also do something like Python 3, run the file. Let's say that this test file is going to be called randomgame.py that we're going to write. And in here, I can give it options of, let's say, 1 and 100. And this program is going to take, using sys.rgv, the number from start to end. So this game is going to be really difficult because we're going to try and guess a number 1 to 100, or 1 to, let's say, 2, which makes the game really simple. So again, the goal is for you to write a program, call it randomgame.py, ask a user to guess a number, let's say between 1 and 10, get that information, try to randomly generate a number 1 to 10. The user is going to be asked, when I get prompted, hey, I want you to guess a number 1 to 10. And from there, we're going to keep guessing until I get it right, and hopefully at the end say, you're a genius. Or if I keep getting it wrong, well, it's going to keep asking me until I get it right and maybe do a couple of validation as well to make sure that the user actually enters what we want. Good luck, and I'll see you in the answer video. Welcome back. How did you do with the random game? Were you able to solve it? Let's give it a try here. Now, I'm just going to use the test.py. Actually, let's just rename it, just so it's not confusing. I'm going to rename it to random game.py. All right. Now, in here, I want to be able to, first of all, well, let's think about what we need. So the first thing we need is to generate a number 1 through 10. Then what we need to do next is to get an input from user, right? And then we want to do some sort of an input check. So let's say check that input is a number 1 through 10. And then check if number is the right guess. Otherwise, ask again. So that seems like a good program that we can write. So how can we do this? Well, the first task is to generate a number 1 to 10. I know that I'm definitely going to want to import the random library from here, and specifically the rand_int. So I can just say from random import rand_int, which we've seen. And here I can generate the numbers. So let's call it the answer is going to be rand_int from 1 to 10. So this is going to be our machine-generated random number that we need to try and guess. Next is we have to get the input from the user. So how can we do this? Well, simple, right? We can get a guess as input from the user, and we get the prompt. So we'll say guess a number 1 through 10. All right, so that's looking good. What about check that input that it's a number 1 to 10? So we have to do a bit of checking here. Now, because we want to keep looping while the user is guessing, I'm going to do a while true loop that we have to make sure we break out of so we don't have an infinite loop. And in the first part of the while loop, I want to check what the user inputs. So I'm going to say if guess. Well, we know right away that the input is going to give us a string. So we have to make sure we convert this into an int first. So let's do that. I'm going to say if int guess is greater than 1 and int guess is less than 11. So in our case, let's do 0 here because we want to make sure that if it's 1, it's still good. If it's 10, it's still good. In that case, well, we can actually try and check if it's the right guess. Now, what happens if this fails? What if the user enters a string that can't be turned into an int? For example, if I go to my terminal here and I just turn on the Python interpreter and say int and then just give it some gibberish, I get a value error. Invalid literal for int with base 10. I have no idea what you're trying to do. So we can check for a value error here. So what I'm going to say is to try this bit of code. And for now, we'll just pass in here. And if for some reason it doesn't pass and we'll check for value error, then I'm going to print, please enter a number. Awesome. So we're checking that the input is a number 1 to 10. So for now, just to make sure that this is working, let's just do this. Let's break out of this loop or print all good in here and break out of this loop, considering that right now we're entering a number 1 to 10. And let's just make this a little bit smaller just so you can see it better. There you go. And for here, we'll just do continue, because we'll just keep looping until we get the right answer. So again, we're importing randint, generating some random number, 1 to 10. We're getting the guess from the user, and then we want to check that the input is a number 1 to 10. So I have a loop that I'm going to keep running, and I'm going to ask, is the number 0 to 11? If it is, then we're all good. If for some reason we get a value error, then we're going to say, hey, please enter a number. So let's just test that out. I'm going to go to my terminal, or actually we can just run this here. Let's run it. All right, guess a number 1 to 10. 5. And I get all good. Like, I think we need a couple of spaces here. It looks a little weird. So let's just say, guess a number 1 to 10 and give some spaces. Let's run that again. There you go. And I've actually already noticed a bug that we need to fix. If, let's say, I enter gibberish. Oh boy. I get, please enter a number, please enter a number. And we need to stop this because it's going to get destroyed. All right, so what happened here? Well, we didn't break out of this loop. We continued, and we just kept going while true, while true, while true. And we kept getting a value error. So you have to be careful here. Remember, when we continue, it goes back to the try block or back to the while loop, and it's going to try this again. But we're not asking for the input or a new input again. This is going to fail, and then another value error happens. And then this is going to fail, another value error happens. So we need to put the guess inside here, right? Inside of the try block. So now if I run this, all right, let's guess a number. Let's give gibberish. I get, hey, please enter a number. All right, we'll enter a number. We'll enter, how about 0? Nope, this doesn't work. It's going to keep asking me because, well, the number that we entered, it's less than 1 to 10, but it's a wrong answer. We could check is wrong. You know what? Let's do that. Let's say else. We'll say, hey, bozo, I said 1 through 10. That'll be a fun one. All right, let's run this. Let's do 0. Hey, bozo, I said 1 to 10. All right. Let's do 5. Hey, I guessed the number 1 to 10. Everything's good. All good. All right. So now what I'm going to do is just see if the guess matches whatever the answer right here is. Now, before I do that, you see here how the PyCharm IDE gives me a little hint, a yellow line that says, hey, this simplified chain comparison can actually be improved. It's why IDEs are so powerful. And here I can actually simplify this. I can say if int guess is higher than 0 and less than 11, then do this. And look at that. I just simplify my code, and the editor gave me a nice hint. Okay, let's go through here. So instead of saying print all good, let's say if this is the case, we're going to have another conditional and say if the int guess equals to the answer, we'll print you're a genius. And we'll break out of that. Now, notice here how we're doing int guess a couple of times. Maybe a better way of doing it is to just do an int here so we don't repeat ourselves and run the same function over and over. And just have guess like this. So again, we're cleaning up our code, making it read more like English. That's nice. And now if we run this, guess a number, let's say 5. No, that's not right. Let's do 6. What about 7, 8, 9? This guy's a tough cookie. 1, 2, 3, 4. Oh, come on. Is it 10? Wow. We are definitely not geniuses because we just, well, tried 10 times. But this looks like it's working. Let's make sure that we're actually working this properly by cheating a little bit. I'm going to actually print out here the answer. So I see what the answer is before I type it in. Let's do that actually right here. If I click run, all right, the number is 4. If I type in 4, all right, now I'm a genius. First try. All right, we're cheating, but it looks like this is working. That's pretty cool. Now, the last part here is that up until now, I've used the input, but I said I wanted to run it in a terminal. And I want to be able to actually, well, give it parameters, right? We give it the start parameter and the end parameter of randint. So we can make the game as hard as we want. So that's pretty simple. We have the import sys here. And we simply say sys.argv. The first parameter, remember the first one's going to be the file name. And then the third parameter. And that's going to be the numbers that we're giving it. So let's use this file now. Let's copy the code. And just for this example, because it's simpler, we'll just add it to our Sublime text file. Oh, and it looks like we have to do sys.argv here as well. Make sure we don't forget that. So let's fix that as well. Like that. That's better. And if we run this, not int, because remember the parameters that we're going to give it are going to be turned into strings. So we just have to make sure that we convert this into an int, like this. Now if we just copy this, run this over here, let's run it again. So I'm pressing up here because it remembers my previous command. Let's give that a go. Guess a number, 1 or 2. Let's go with 1. There you go. I am a genius. And our program is now working. Our guessing game is now working. Very, very cool. If you got this, good job. If you didn't, well, you can just take a look at my code and hopefully see where you went wrong. But good job getting this far. I'll see you in the next one. Bye-bye. Up to this point, we learned that the power of Python really comes into play when we talk about modules, but more importantly, when we talk about the standard library that it comes with. That is, the ability for us to have these built-in modules that we can just import into Python to extend the language and have things like random module, the sys module, to be able to use in our code. And these were called the standard library. But the true power of Python, and I argue the reason that Python is such a big part of any company, really, in this day and age, and why Python has just exploded in popularity, is because of this third part. It's because of developers like you and I who have the ability to create our own Python files, thousands, millions, trillions of Python files, and actually share them with each other so that we can actually, instead of just having our own code, our own standard library code that we download with our Python interpreter, also have all the code that others share on the internet so that we don't keep reinventing the wheel. If somebody else wrote a really, really good module that maybe can be used in another project across the world, well, they can share it and we can download that module and import it into our projects. And that's why really amazing libraries like NumPy, Pandas, TensorFlow, all these things that we're going to talk about later in the course are libraries built by the outside developer community. Not the Python community, but in general, just developers like you and I, or developers working at Google. It could be developers that are working in South Africa, that are working in Fiji. It doesn't matter. We're able to use each other's code. And we're able to do that using the pip install command. And in these next couple of videos, you're going to see the true power of Python, how we're able to stand on the shoulders of giants, learn from previous mistakes so that we don't constantly reinvent the wheel. If we want to build a game, if we want to build a website, we don't have to code it absolutely from scratch. We can use bits and pieces, modules and libraries from all these different parts to combine it so that we can fast track and build our project even faster. So how can we do this? How can we use this knowledge base of the world? Well, we have a website for that. It's called the Python Package Index, or PyPy for short. As you can see, pypy.org. And right now, there are 182,000 projects, 335,000 users on this website that have shared code that you can use. Unlike the Python module index, which, had a lot, but that's it. This has a lot more. Let's say I wanted to do email. Well, look at all the packages that I have for sending email with my code. Let's say I wanted to do, image optimization with code. Well, look at that. All these packages for image optimization that I can do. What if, for example, I wanted to, read Excel files or CSV files? Well, there's packages for that as well. And there are a lot of them. Pretty much anything you need, you can probably find on here. Now, a good practice is to first check that something exists in, the built-in module. Maybe the standard Python module, standard library has it already. Otherwise, you come over here. Now, you get really, really good at noticing which projects are good, which projects are bad. For example, if I click on here, I can read about the project. I can see who's worked on the project. I can see what kind of license it has. I can see what Python programming language version it's compatible with. But I can also look at the release history and see, has this person been working on this project recently? Doesn't look like too much has happened with this project. So you get really, really good at deciding which packages are good, which ones are bad. You can go to the homepage of the project. What I like to usually do is, let's say I wanted to read CSV files. I would say read CSV Python 3, and then say maybe built-in to see if there's any built-in modules. And I see over here that there's some Python documentation, official documentation that maybe I can read. And I see that it has import CSV. So I can go to over here and just check, hey, is CSV actually a built-in module? Oh, yeah, looks like it is. So I probably should use that because, if it's a built-in module, I'm sure the Python community has worked really, really hard to make sure that it works well. But maybe I wanted some extra features that I can't find here. In that case, I would just go back and maybe type in, instead of built-in, PYPI. And now I can just browse through these and see which one I like. There are so many packages that you can do pretty much anything you want. That's the beauty of Python, this massive community. And it's not just Python. There's communities like JavaScript that use, instead of PyPy, they use NPM. You have Ruby developers that use something like Ruby Gems. This is what programmers do. They share code so that others can use it. And most of these are just completely free to use. You can use them in your code and not have to worry about it, which is really, really nice. And on top of that, you can also create your own packages. If you wrote a really, really nice module that you want to share, you can publish your own packages to the Python package index. But enough talk about this. Let's actually learn how to use this power, how to install something from third-party developers that we can use in our program. And by the way, I'm about to show you a few little packages, but in our final projects, when we build over 10 projects, we're going to be using a lot of these. So we're going to learn a lot more later on in the course. So don't worry, I'm going to cover some really exciting ones like texting, email, reading PDFs, checking out images, and machine learning, Excel, and a ton of things. So bear with me. as we start to learn about pip install. Welcome back. I just found this Python package, pyjokes. And mind you, I have never installed this, so I'm going to try and do this from scratch so you can see what the steps would be like. So this is a completely useless package. It looks like it gives us one-line jokes for programmers, so I think this will be appropriate. I also like the fact that it has GitHub stars. So here, sometimes some of these packages are hosted on GitHub. And GitHub is essentially a social network for programmers. You're able to put up your code up here and people can view your code and download it. And a good measure of how popular a package is usually something like stars or forks, because stars are given by people that really like the package, or fork is people who copy the package and use it in their own coding, maybe on their own GitHub profiles. So this looks like a very simple library, so let's install it. So there's several ways that we can actually install this package. You can see here that the command is pip install pyjokes, but I want to show you first how it works with PyCharm and then show you how to do it with the command line. So I have PyCharm over here. We have some relics of our old project. Now in here in PyCharm, again, it's an IDE, so it comes with a lot of built-in things. I can do PyCharm, preferences, and then simply go to project modules. I can go to project interpreter. And then here I see that this interpreter has some modules already pre-installed. I see that I have pip, but all I need to do is click on the plus sign here. If I click plus, I can actually here search for packages. So these are all the available packages that we have. So what was our thing called again? Pyjokes. All right, let's search for pyjokes. Pyjokes. There it is. I think it was this one with 0.5. With the author, Pyjoke Society, just making sure that it's the same one. Yep, author, Pyjoke Society. So all we need to do here is to simply install package. There you go. Pyjokes installed successfully. So now that I have pyjokes here, let's have a look at how we can use it. By the way, I can actually test to see that I have this installed. If I go to lib, Python 3.7, site packages, there's my pyjokes distribution. Awesome. So let's see how we can use it. Again, I've actually never used this before, so let's have a look. You can also access jokes in your own project by importing pyjokes. All right, let me just copy that. And using the function getJoke and getJokes. All right, sounds simple enough. Let's give that a go. I'm going to import pyjokes like that. And then what was the function? The function was getJoke. So let's do pyjokes and then say getJoke. And I can see that I can give it a language and category. So let's say getJoke here. So string is English. So we want the joke in English. And category, let's see. It says we can do neutral. What are the options here? Neutral is neutral geek jokes. No adult jokes for us. We can do Chuck Norris jokes. All right, neutral is fine. That's the default. So we actually don't even need to pass anything here, but just to be safe, let's do neutral. All right. Let's, I don't know what it's going to do. So let's just run this program and see what happens. All right, let's print out the joke. Let's say joke equals, and then say print joke. If I click run, real programmers can write assembly code in any language. Ha, ha, ha. All right, there's our completely useless package. Let's do another one. Let's see if there's any funny ones. How to explain the movie Inception to a programmer. When you run a VM inside another VM, everything runs real slow. All right, some of these jokes I'm sure are pretty funny. Some of them might be a little bit advanced, but hey, that's actually not bad. You know what? I might use this package in the future. I think this is fun, but I won't bore you with me keep pressing play. I might not record for a few hours and just waste time reading these jokes. But I just wanted to show the process of how I would go about doing something like this. Now, most programmers that don't use PyCharm, instead of doing what I did, will most likely use, let's say, their terminal to actually do this. So I have my Sublime text here and my terminal or command prompt, if you're on Windows, right here. And if I do present working directory, again, this is a Linux and Mac command. So I see I'm on the desktop, which is where my 1.py file is. Now, if I wanted to use the PyJokes in here, and I click run, so let's say Python 3 1.py, module not found. No module named PyJokes. That's not good, but that's because we installed it for our PyCharm environment, but not for us to use outside of PyCharm. So how can we do that? Well, we can do pip to install from the pypi library or the repository. So again, if I go all the way up, you see that I have pip install PyJokes. So I can even copy this and just install it for myself here. Now here's the thing. Depending on how you have your machine set up, if I do pip-v with capital V, it's going to give me the version of pip, but you see here that it says from Python 2.7. We want to make sure we're using Python 3. So in your case, if you do pip3-v, you'll get the right version of pip. So make sure you check that and make sure that you're using with the Python 3 or higher. In my case, I'll have to call pip3. You can always set this up so that pip refers to the Python 3. But for now, let's say pip3, and then we're going to install. And here, all we say is the package name we want to install. In our case, it's the PyJokes package. All right. It's collecting PyJokes, successfully installed PyJokes 0.5. I also get a little warning here. You're using pip version 19.0.3. However, version 19.1 is available. And you might get this. And I always recommend just upgrading. So I'm just going to copy the command that they give us. And I'm going to say pip install upgrade pip. And I'm going to do pip3. All right. So I've successfully updated pip. So again, pip3v now has version 19.1.1. If I now, let's say, clear here and do pip list, I see that it shows me all the lists of the packages that I have. And if I scroll up here, I see that I have, where is it? Oh, I used the pip command instead of pip3. So let's do pip3 list. So this is something that you just have to be careful of. You can see pip3 list is looking a lot nicer. Let's see. I see that PyJokes is installed. Awesome. So now that I have this, let's run it. So I can run Python 3 and then say 1.py. Oh, what an appropriate joke. I swear I did not time this. This is just the programming universe telling us something. It says, friends, don't let friends use Python 2.7 because, hey, we should get this joke. Python 3 is the current and latest. Oh, that's funny. That's actually, I'm pretty pleased. I feel like we should end the video here because this is just perfect. All right, well, this is how you install packages with PyPI. We are able to really use the power of the developers all around the world using just a simple command, pip or pip3 install, and whatever package we want across the world, across the internet, we have access to in our projects. I'll see you in the next one. Bye-bye. Welcome back. We've learned the true power of Python, and the true power of Python comes from the community and the fact that there are so many Python developers that we're able to leverage all these modules, all these libraries that people have built to really do really interesting things so that we can fast track our progress and build some really great projects really, really fast. Something that we're definitely going to do in this course. But you may have a question. This PyJokes that I just installed, this library, it has version 0.5.0, and this is called versioning in Python and in most programming languages, where the first number is usually a version where if you have bug fixes, you would go from 0 to 1 to 2 so that you update. 5 will be a new release, maybe some added features. And the last number, or based on how you look at it, the first number, the major number, is usually breaking changes or major versions. So PyJokes looks like it's fairly young. It's 0.5. But something like PyCodeStyle that is 2.5 looks like a mature library because they're in version 2.5. And here's the thing. Libraries are maintained by people, right? By programmers. We're constantly making mistakes. There's always going to be bugs. There's always going to be things that you can improve upon. So these are always improving. Versions are always increasing. And when you start working on large projects, you start installing different packages, different modules that perhaps only work with certain versions together. So that maybe PyJokes 0.5 is fine, but on a new project, 2 years from now, I want to use PyJokes. But the latest version of PyJokes, well, what can I do? In this case, I can uninstall, let's say pip3, uninstall the old version of PyJokes. So let's say PyJokes. And maybe have a new version of PyJokes that I can install. Now, when I do pip3 install PyJokes, this is going to give me the latest version. Or I could even do double equals and then give it a version like 0.4.0. So now if I do pip3 list, I have the older version of PyJokes. Now, the reason I'm showing you this is that sometimes you want for your different projects different versions of a library. Because maybe a project that you started 5 years ago really requires PyJokes 0.4, and this new project that you're starting requires PyJokes that's, well, let's say upgraded to version 2. So how do we do this? Because right now, the way we've installed things, there's only one version on my computer that I can use. This is what we use for what we call virtual environments. And it answers the question of, hey, how can we have two versions of all these packages, of all these modules on the same machine and still have different projects using different versions? Well, there's a tool that you can install called pipenv, which allows you to use pip and also this virtual env to install packages based on each project. So each project has its own packages. Or if you're using PyCharm, which I usually recommend, especially on big projects, you have virtual environments by default. Remember this venv folder? Well, venv folder is a virtual environment created by Python. As a matter of fact, let's say I want to create a new project. Here, I can create a project, let's say V or new jokes project. And here, if in the dropdown, you see that I have a new environment using virtual env. So I can use virtual env, which is built into PyCharm, to create a virtual environment. You also see that I have something called pipenv, which I mentioned. But usually you select the virtual environment, and when you do create, let's say this window is fine. When we do create, you'll see that new jokes has its own virtual environment. And now any library that I install in here will have its own package right in here. So it doesn't affect any other projects. If I go to pyvenv.cfg, you see that the environment is set up with version 3.7. This is my home. And we're able to add packages right in here. And you see that, nope, I don't have any PyJokes in here because this is a new project with a whole new environment. If I create a new file, let's say in here, we'll say new file, and let's call it test.py. And let's say import PyJokes. We'll say PyJokes.get joke. What was it? Yeah, let's just copy this. And if I run this, whoop, I get an error. No module named PyJokes because I have an entire virtual environment. It's like a separate universe where I can install here whatever I want so that it doesn't interfere with the outside world. And usually when you're working on project, you want to create them in virtual environments like this. Again, this may not seem like a big problem right now, especially if you haven't worked in the industry, but this, trust me, is a common problem where packages are constantly being updated and you have packages that depend on other packages that need to have certain versions. So a virtual environment to contain all the packages that you use into your project, into this small little environment is really, really important. And as you start working for bigger companies, you'll notice that in your workplace, they're definitely going to be using this system. That's a lot of talking for me. Let's take a break, and I'll see you in the next one. Bye-bye. Welcome back. Now we're going to be spending a good chunk of this course building some projects and using some built-in Python modules, as well as using some popular third-party libraries from Python Package Index. However, I wanted to just show you a quick video on some of the useful modules that I personally like in the built-in modules that we have from Python. And some of these really useful modules actually allow us to have more data types in Python. Remember this list at the beginning of the course where I talked about the data types that comes with Python? And then we learned about classes and how we're able to create our own data types, our own objects in Python. But we also have these specialized data types that come as, well, built into the Python standard library, which are really, really nice. And this can make our programs really, really powerful. Now, they're specialized because you're not going to see them everywhere, but it's good to know that they exist, and I'm going to go over some of my favorite. The first one I'm going to show you is the collection module. So the collection module is from collection or collections. And there's three things that I really like here. So I'm going to say import. I'm going to import the counter, the default dictionary, and then the ordered dictionary. Now notice how some of them are classes because they're capital letters, and some of them look to be just a function. And you can read up on the collections module by just, again, scrolling through here and just looking at collections, and you can see all the ones that we have. So in these collections, let's start off with the first one. A counter is extremely useful. Let's say I have a list that contains 1, 2, 3, 4, 5, 6, 7. And I want to count how many items in a list. If I do print counter, you can see over here what it does. But essentially, if I give it a list and click run, all right, what just happened here? It creates a dictionary where 1 has 1, 2 has 1, 3 has 1. What if we add another 7 here? Let's say 7. If I click run, did you see that? 7 now has 2. So what it does is it creates a dictionary that keeps track of how many times an item occurred in an iterable. So that 7 occurred twice, so 7 has a value of 2. Another way we can use this is, let's say we have a sentence. And say in the sentence, I want to check well, let's just write something. I'll say blah, 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 thinking about Python. If I was to do a counter here, and let's say give it sentence, if I click run, check that out. I see which letter occurred the most. In our case, H occurred 5 times, space occurred 5 times, and then B occurred 4 times. And this is really, really cool, because this type of calculation of a counter, of turning an item like a list into what we call a hash map or a dictionary like this to keep count, is actually a very useful function that you see all over programming. It actually helps a lot with optimization problems. Now, we were not going to get into it there, but I just wanted to show you that counter is something that is really, really useful. If you want to count duplicate users or duplicate emails, counter can be really, really useful. What about the next one? Default dict. God, that's a really hard word to say. All right, so let's say we have a dictionary here, and this dictionary will have, well, a very insignificant dictionary. We'll have A1 and B2. What a simple dictionary. Now in here, I can say dictionary dot or bracket A, and I'll be able to grab the value, right? If I click run, oh, and I did not spell dictionary right. Let's fix that. That's better. Let's comment this out for now because we don't need this. You'll see that I get a value of 1. But if I try to access something that doesn't exist, like C, I'll get an error. With a default dictionary, I'm actually going to get a default value if something doesn't exist. So let's convert this into a default dictionary like this. And now if I run this, we get an error. First argument must be callable or none. So what default dict does is it allows us to access a key like this, but give it a default value. In our case, we need to give it something like a callable object in here. And callable means something like a function that can be called. So if I do run, I get 0. Why is that? Well, when I run int like this with nothing inside of it, we get 0. So a shorthand way, because this is going to be run, is to give it a quick function that we're not going to use. So let's just do a lambda and just give it, let's say, 5. So now if I run this, let's do dictionary here. Run. Oh, and let's try and grab something that doesn't exist. If I click run, I get 5. So this is a common pattern you see with default dict. We just give it a value or a callable object. In our case, we're just giving it this function, a lambda function, that simply returns 5. So I can even say in here, does not exist. The second parameter will be whatever we want. And if I hit run, I get does not exist, even though I'm accessing a key that, well, doesn't exist. Now, if I do A here and I click run, everything works. I still get 1. And if I do B, I get run as well. Again, another useful little data type. Next one is ordered dict. And this one is another interesting one. An ordered dictionary retains the order that you insert into a dictionary. Let me show you. So if we have, let's say, dictionary, and this dictionary will be an ordered dictionary. So this is how we create it. Now, in here, if I do D equals to A, and this is going to equal to 1, and then D, B is going to equal to 2, And I now copy this and make a second dictionary. Let's say D2, D2, D2. And I check, hey, print, does D2 equal D? Remember, this is going to check for the values. If I run this, I get true. Yep, they're equal. But if I change the order of insertion here, and I click run, I get false. Sorry, this is not the same thing because it maintains the order. If this was a regular dictionary, so let's say instead of what we have here, I'm going to just simply create a dictionary, and we'll just do a simple C here that has, let's say, 100, and do the same for this one as well. D2 equals to this. If I now run this, I get true because all the keys and values are the same. With a regular dictionary, we don't really care. There's no order. And I mentioned this before too, right? A dictionary in Python has no sense of order. Although when we print out the keys, we might get things in order. As our dictionary gets larger and larger, there's no guarantee that when we print out all the keys that we're going to get them in order. In the case of an ordered dictionary though, we get that guarantee. Now there are some performance implications for those. However, overall, it can be useful in some situations. All right, a few more to go through, but this video is getting long, so let's take a break and I'll see you in the next video. Bye-bye. Another really useful module that you might use actually quite often in your programming career is the date-time module. And as the name suggests, it allows us to manipulate date values, which is really, really useful. So let me just show you quickly how that would work. I can say from date, time, and in here, well, there's a ton of functionality, but you can do simple things like date, time, dot time, and give it in here some options. Oh, and make sure I import here, like that. So that now, if I look at time, print here, if I click run, I get a time of 0. But if I, in here, let's say I do, the time is 5:45, and let's say 2 seconds. If I click run, I get 5:45 and 2 seconds. I get the time. So I can create time objects here, which is really, really nice. Another useful one is the date. And date gives us some really useful things like today. Hey, what's today? Well, today, hint, hint, this is when I'm recording this video. So I get a date object that I can now use, which is really useful. Maybe a user signs up for your startup and you want to make sure that when they sign up, you want to keep track of what day they started on. Maybe they got a membership and it expires in 30 days. Well, we can use the datetime module to keep track of that. And there's lots of things that we can do with dates. As you can imagine, there's things like time zones and different time data that we can manipulate. Very, very useful. I almost forgot this one, but remember when we built our decorator, our performance decorator that measures how long of a time a function takes? Well, we used a module here, didn't we? And this is another one of my favorite modules. It's the time module. And we can use it, well, like this. It tells us the time, and we can use 2 instances of the time to essentially figure out what the difference between the time instances are. Again, another really useful one. All right, I think we have time for one more because these videos could last forever. I could just keep showing you these, but like I said, these are modules that you're going to use whenever a need arises. You're going to start Googling and find out, hey, I need to get date information. Well, you're going to start Googling and find out that there's a date module or there's a date py package. All right, the last one is called an array. And we have an array package that we can use from, well, the array module. Now in here, what is an array? And this is something that I may have mentioned because lists in Python are sometimes called arrays in other languages, but they are a little bit different. You see, lists in Python are what we call just dynamic. That is, anytime we need data into a list, we can make it as big as we want. We can just incrementally increase this list and fill up our memory. And we've seen that before when we try to, let's say, print out a massive list. Arrays that Python gives us actually take up less memory and perform faster. So if you have a large list and let's say you don't want to use generators, you can improve it with an array. And that is because when we create an array, it sets how much memory we can use in our machine. Now, this is a pretty big computer science topic. You can learn about arrays online or some of my other courses. But for now, the way we would use it is like this. We'd say array, and we first have to give it a type code. So a type code with an array is what type of data is this array going to hold. And this is part of the optimization. By telling it what type of data we're going to hold, the memory is better used. So for example, if I go to the array module in here, you see that we have different type codes. And if I wanted, let's say, an integer, so that is, if I want a signed int, or maybe I want a float. And usually we want something like a signed int, so this is a Python integer. And it shows you what the minimum size in bytes is. But let's say we just want small numbers. So I can say, hey, the type code is going to be I. It's going to be a signed integer. And then I'm just going to give it 1, 2, 3. So now if I have an array like this, and I print array, if I click run, there you go. We have an array, but I can access it just like I would a list. Very, very cool. And this is a little bit more performant than lists. Again, if you don't want to use generators, if you have a massive list, this is a quick, easy way to optimize your code. The possibilities are endless. There are so many packages that we can use, so many built-in tools. The key thing is searching for it and looking for it when the problem arises, but there's no way that you can memorize all of these. As you progress through your career, there'll be certain ones that keep coming up that you'll just get used to, but you just have to trust me on this. This is one of those things that just comes with experience and as you code more and more. So the best way to learn these is to just keep coding. I'll see you in the next one. Bye-bye. Let's get into another developer fundamental, and that is pros and cons of libraries. You want to be careful with packages because it's not always good to use them. Now, what do I mean by that? Well, these packages are created by developers and programmers. You can have people that are creating really, really good packages, but also people that are creating bad packages that may be buggy and don't work well. So you have to develop that skill to make sure you're able to see, hey, this package is really popular, or this package is being maintained, or this library is really popular with the community, so most likely it's a good package to use. So this is a skill that you need to develop. Also, keep in mind that every time you add a library to, let's say, your project, you're adding more and more code, which means more and more bytes of data. So your project gets heavier and heavier and heavier. So that's also something that you want to consider. Before you're importing a library, ask yourself this: could I just write this myself? You usually want to pull in a library when writing something from scratch yourself is going to be really time consuming and you don't have the expertise in that area. At the same time, it's what makes programming so powerful, right? Because we don't have to start everything from scratch. And most of the time, when you're working as a developer, what you're doing is essentially matching and pulling in different libraries and getting them to all work together. A lot of your work is going to involve working with these libraries, reading the documentation of these libraries, and figuring things out as you go. as you try and build a useful tool by combining everything together. So there's pros and cons to everything. And this is just something that you will develop as you progress through your career. Just keep an open mind, be careful of using just any library, but also learn to read library documentation, learn how to use all these different tools to combine to create something useful. I'll see you in the next video. Bye-bye. Let's talk about a very important topic if you want to be a great programmer, and that is called debugging. You see, nobody writes perfect programs. It's honestly impossible. We're always going to make mistakes, and programs are constantly being improved. We constantly improve our code as we find more and more mistakes. Because programs are full of errors, or what we call bugs or exceptions at runtime when the code is running. You see, the act of finding and removing these bugs or errors from our code is called debugging. And a big chunk of our time as programmers is debugging code, whether it's our own code or other people's code, and figuring out, hey, how come this doesn't work? And the senior developers are really, really good at debugging. So let's talk about in this video about some of my recommendations for debugging and what some good practices are. Now keep in mind that you get better at debugging code as you code more and more. So the best thing you can do is to just keep practicing, keep writing Python code. So what are some of my tips? Well, first, you definitely want to use some linting. And what is linting? Well, we've talked about it, right? When we set up our developer environment. Linting allows us to detect, as we code, some issues with our code. For example, if I do num plus 4 here, and I get a red underline, and you see here that the pyflakes linter notices before I even run my code that, hey, there's an undefined named num. So linting allows us to find these errors before we even run our code. And we saw that we can use IDEs like PyCharm that has linting already built in, or use Sublime Text or Visual Studio Code and install packages and extensions like PyLint to actually have linting in our code. That is a really, really important tool. Next, I recommend always using some sort of an IDE or editor. Because these editors and IDEs, especially the ones that are specific for Python, like PyCharm, have all these built-in tools for us to use, such as auto-formatting based on PEP 8. Remember, the official style guide that the Python community has. It allows us to detect errors in our code with, let's say, highlighting and formatting of our code. So it becomes easy for us to detect any errors before we even run the code. Finally, you want to be able to learn to read errors. And this is something that I try to practice with you as we've learned Python. For example, if I do 4 plus, let's say, gibberish here, and I click run, right away I see, hey, on line 6, there's an error in my main.py file. There's a type error. And I see here that I'm trying to add int and a string. So we're able to read errors and understand what they mean. Maybe I do something like this. If I click run, I get a syntax error. And a syntax error, I know, means that, hey, Python interpreter is trying to read my code, but what you just wrote is not Python. I have no idea what you're doing. Here, I see that it's end of line while scanning string literal. So I'm trying to read this string and all of a sudden the program ends. Like you're supposed to end the string, remember? So being able to read these errors is really, really important. And we've discussed some of them in this course. Some of the most common ones like syntax error, where you're just writing something that Python interpreter doesn't understand. We have something like name error, right? Where we use a variable that doesn't exist. So Python doesn't understand, hey, I have no idea what name is. What's the value of name? We have things like type error. That is when we mismatch data type and do, let's say, a string plus 4. We have things like value error. We have things like key error, where we're trying to access a key that doesn't exist, or attribute error, where we're trying to access the method of an object and that method doesn't exist. Now, these errors are something that we've been seeing throughout the course, and we're going to see a few more. I would say that there's about 15 to 20 errors that are really, really common that show up 90% of the time. And if you remember, you can always go to the Python documentation to learn about them. But this just comes with practice. If you see an error that you've never seen before, I recommend going to the documentation and reading up on it. Once you see it, you usually tend to remember when it comes up next. But let me show you my favorite way to debug code. And it's called PDB, or Python Debugger. And PDB is a built-in module in Python, right here. Again, remember, our built-in module are part of the standard library that Python comes with. And PDB is the Python debugger for interactive interpreters. And you can read about it here, but let me show you what it does. You see, PDB is extremely useful because it allows us to interact with the code. So previously, when we had a function, let's say we have function add, and we have num1, num2, and then this function simply returns num1 plus num2. Now before, if we wanted to, let's say, debug this code, and let's say we're adding 4 plus some gibberish, and it's giving us an error, the first step that I would take is most likely adding a print in here. So I could say print, hey, what's going on? Let me see num1 and num2 and what it's giving me. And print is a really, really quick way and easy way to debug your code. I use it all the time. But PDB gives us a little extra boost. So we can use it like this. We simply import PDB, and instead of using something like a print function, we can simply say, let me add a space in here. We can simply say PDB for Python debugger, and then say set trace. And set trace, I would say, is the most useful method that we have on this PDB object that we imported. You see, when I run set method, it now gives me an interactive Python debugger that I can now type commands in here and actually test out my code. And here's the interesting part. Right now in this PDB, I'm right inside of line 8. So my code tried to run, but then it paused as soon as it said PDB, set trace, and now I'm in this world. And I can test out what's going on. So I can actually say, hey, num1, what is it? Well, num1 is 4. What about num2? Well, num2 is a string, and I could be like, oh, I'm trying to add a string and an int. This doesn't work. So I can detect errors this way as well. Now, this PDB interactive actually has a ton of useful things. So if I type in help here, you see that I have commands that I can use in the PDB. So I have a ton here. I have exit, which I'm assuming is going to exit me out of this PDB, Python debugger. But I also have things like, let's say, list. Let's see what list does. So when I type in list here, and right now the website is really not showing me too much, but hopefully you can still see list. And I get some sort of an output. I see that I get a list of my code, and okay, but let's say I don't know exactly what list does. Well, PDB allows us to type help and then list. And when we do that, it actually gives us the documentation just like we have here. If we go to, let's say, list. Let's see, list. Right here, it gives me the documentation right in here. So it says list source for the current file. Right, so it just lists the source code that we wrote. Okay, that's cool. What else is there? Well, we also have something like step, or S for short. And step is really, really cool. Let's actually use clear to bring this up to the top. So I'm going to say clear so that it clears all breaks. Let's make this a little bit bigger so you can see. There you go. That's better. All right, so now I can actually do something like step. And step is going to allow us to go to the next line. So again, if we make this a little bit bigger, step is going to say, hey, go to line 9. So let's see what happens. I'm going to type in step. Oh, and I got step twice, so let's write step. And look at that. I go to the next line in my code, and it gets me, hey, you get a typo error, the error that we got. So let's add another line in here. Let's say that we're trying to add 4 plus 5 in here, or 4 multiplied by 5, and assign it to a t variable. If I stop this and run this again, I'm now inside over here. If I type in t, I get a name error. T is not defined because, well, I'm inside the code here on line 8, but we haven't ran line 9 yet. So let's do step. And now I'm on the next side. So if I do t now, I get, hey, t equals to 20. Awesome. So step, I can step through the code, which is really, really useful. I also have things like continue, which lets me continue through the code until I return something. And I continue and exit out of PDB, and look at that, I get the error. Let's run this again. Another useful command is a. And a actually gives me all the arguments of the current function that we're in. So look at that, I get all the arguments, which again is really useful. There's also the command w, which shows me the context of the current line it is executing. So you can see here where we are. We're in the add function. We called it with these arguments, and we're now about to run this line. And then finally, as we're debugging this, all right, I think I finally see that we have an error. We should have given it a number. So I can now just exit out of here and simply fix this to 5. So now I can just remove my PDB, and everything should be working fine with my code. Awesome. So PDB is awesome to step through your code and debug and try different things. It does require a bit of practice, but after a day of just playing around with PDB, you will become really, really good at debugging. So after this video, I recommend that you write PDB, and hopefully you have a large enough Python file that you can just step over and experiment with different commands, using help, using list to see what you have available to you. I actually want to show you one last thing. So let's say we go back to our code, our PDB set trace. I click run. Could I do something like this where I notice that I type A and I have, all right, my code is working, but could I change num2 to now equal some gibberish? Well, let's see. If I do next now, and let's do next to run this final line, I get an error. So I'm also able to change variables in here and write Python code to perhaps test out my functions. This is now working. I can test out, hey, what happens if we change this variable to another value? Again, very, very useful. Let's talk about file I/O. What does I/O mean? You'll see this a lot in programming. I/O stands for input output. You see, most of the times, machines are not communicating in just one environment. For example, so far we've been writing our code in let's say, an editor like Sublime Text that I have here, or PyCharm, or an online REPL. But usually you want to interact with different parts of the system. Maybe you want to speak to another website. Maybe you want to speak to something that's on your desktop, maybe a file. Maybe two different machines are communicating with each other. Maybe you're speaking to a database. I/O simply means, hey, I want you to input something from the outside world and output something into the outside world. And one of the most common ways that we use things like I/O is through reading files. You might think about Python and how wouldn't it be nice if we can perhaps write a script that compresses images? Well, we need I/O then. I need to input an image, and then I need to output the compressed image. Maybe I want to work with a PDF file and maybe add a watermark to all my PDF pages. Well, then we input a PDF and output a new version of a PDF. So this is a very common task that we see a lot of. And reading and writing files is a very important tool in our tool belt. And by the way, we have a project coming up where we actually are going to use this with PDFs. But for now, how can we do this file input-output with Python? Well, Python has a built-in function that allows us to open and write to files. And it's simply called open. Nice and easy. So using open, we can do something like this. I can create a sample text file in our desktop. So I'm going to use my terminal here. So if we look at present working directory, I'm on a desktop. If you're on Windows, then you might have to do some different commands in here. But by now, you should be pretty familiar that you can create a file if you wanted to. Now, I can do this manually, or in my terminal, I can actually do, if you're on a Mac, you can just do touch, and then I'll say test.txt. So if I do ls here, you see that I have a test.txt file and a script.py file. And again, just to double check, if I go to my desktop, yep, I have these two right here. Perfect. Now, in here, we can simply say, in our script file, open, and the name of the file. In our case, it's test, make sure it's string, test.txt, just like that. Now, I can assign this to a variable, calling it my file. And now we have, well, the file object. So let's check this out. If I do here, print my file, let's see what happens. I'm going to run my code. So let's say Python 3, and then run script.py. All right. I get an object, a text IO wrapper. I get the name, which is text. I get mode, which I'm not sure what it is yet. We'll learn. And then encodings, which is how this file is encoded, which is UTF-8. Most of the files are usually encoded in UTF-8. All right. So how can I actually read this file? All we need to do is my file has a .read method on it. So that if I run this now, well, I get a blank piece of space because there's nothing on this test.txt file. So let's write something. I'll open this file in Sublime Text and just write, hi, my name is Andre Nagoy. I got really creative with this one. Good job. All right, let's go back. So now if I read this file, look at that. I'm able to read, hi, my name is Andre. And now, there you go. I've read my file. Nice and easy. Now, if I run this again, let's just read this multiple times. If I click run, I'm able to read the first time around, but these two times, I'm not reading anything. Why is that? Well, this open function has this idea of a cursor. That is, you can only read the file once. And once you open, it returns a file object, and the contents of the file you can read. And the contents of the file are read with a cursor, just like you see here, one by one and printed onto the screen. But by the end of this first reading, the cursor is going to be at the end of the file. So now when it tries to read, it's going to be end of the file and nothing will be left there. So the way we get around this is to do something like this. We simply say myfile.seek, which moves our cursor to whatever index we want. In our case, seek 0. So if I run this now, there you go. And if I move the cursor back and I save, and run this. All right, that's a lot better now. And this is just to demonstrate that Python uses this idea of a cursor to read a file. Now, another unique thing that I can do is to do read line. So that if I run this, it reads the line. But let's say our text file has different lines. So how are you? Let's say a smiley face in here. If I now read the line, I get, hi, my name is Andre. If I read the line again, hi, my name is Andre, because I get each line. I only get the first line. If I print this multiple times and I run this, all right, that's better. I get, hi, my name is Andre, smiley face, how are you? Again, the cursor keeps moving, right? So I can just keep reading the lines. Another thing that I can do is to just say read lines. If I run this, I get a list that contains the entire file, reads all the lines, and you see here that I have, hi, my name is Andre Nagoy. I have a new line here, a smiley face, a new line. Remember, this is escape sequencing. And then, how are you? And no new line here because there's no new line. It's the end of the file. So these are extremely useful. Maybe we can use regular expressions to search for a piece of text in a file. That's pretty useful, right? Now, the very last thing we need to do, and this is a little annoying, so I'll show you how we don't need to do it in the future. But you actually have to manually close the file after you've opened it with open, so you can use it somewhere else in the program. It's just a good standard. So what you have to do is say myfile.close after you're done with it. You tell your computer, hey, you need to stop whatever you're doing. I'm not interested in the file anymore. We're done with it. You can use it somewhere else. So usually we do something like this and we're all done. Let's take a break and learn some more in the next video. Up until this point, we've learned how to read files. But we had this annoying thing with the cursor, and then we had to close the file. So how can we fix this? Well, a better way to actually do something like this and do file I/O with Python is with the built-in with statement. Let me show you. Instead of what we had before, what we're going to say is with open the name of the file, and say as whatever the variable you want. So my file. So now with open, you can actually do something like this, but you don't have to worry about closing. So most of the time, you want to use the with statement. This is the proper way to work with files in Python. And if I save here and run my script, I get an error because I forgot the column here. If I run again, there you go. I get my output and I don't need to close my file. Everything is done for me. So this is a standard way to read a file. Now, what if we wanted to write to a file? So far, we've only read. And actually, underneath the hood, open has a default parameter called mode equals to R, which stands for read. So with mode R, we are able to read files. When we don't specify the mode, it automatically just assumes we're reading. But if we wanted to write to a file, we can simply do W for write. So if I run this, you see that I get an error now. Unsupported operation, not readable. Because, well, the file can only be written. So in order for me to read and write, I can write RW, right? Well, let's see. Nope, that's actually not how it works. You would think it'll be RW, but this is a bit of a trick. In order to read and write, we do read plus. So that if I run this, all right, I'm reading and writing. And I get an empty list because this is now empty. Okay, so let's write to a file here. Let's make this a little bit smaller just so we can see. That's better. Let's say that in this file, I want to have text. And in this text, I'm going to say my file dot write. And I can write whatever piece of text I want. So let's say, hey, it's me. So now in here, if I do print text and I run this, I get 11. What is this 11? Well, this isn't really important right now. What we want to focus on is, hey, it's me. I've written to a file. Okay, so let's say I wanted to open the file again and actually write again. Let's say this time around, I'm going to write a smiley face. If I run this and go back, all right, it looks like I wrote to the file, but is this what we wanted? When we write something to a file, the cursor resets. Remember, when we open a file, the cursor goes to 0, and we write to the file. And if there's something already existing in there, well, we overwrite it. So we have to be careful. And by the way, this text file just gave us that we wrote 2 characters, the smiley face. Okay, so how can we fix this? How can we make sure that we don't break what we had previously, which is, hey, it's me, and I just want to add a smiley face at the end? Well, we can use the append mode. The append mode is A, and this appends to the end of the file. If I run this, look at that. Hey, it's me with a smiley face. It appends to the end. So that's the append mode. Again, we can use W to write, and if I run this, it adds a smiley face. Now, why did it not do like last time and overwrite the existing thing? Well, it's because of our mode. W allows us to write to a file. Previously, when we did read and write, what happened was we read the file. Let's run this again. Actually, let's go back to, hey, it's me, the way it was. And if I run this again, because we did read and write, the cursor was set to 0 and overrode it. Versus if we just did the write, it will assume this is a new file and we just want to, just add the smiley face. If I click run here, you see that now is just smiley face. So you want to be careful that you use the right mode based on what you need. Now, let's say we wanted to create a file that doesn't exist. Let's have a file called happy.txt. Or actually, no, let's do sad. And this writes a sad face. But remember, we don't have this on our desktop. If I clear this and look at our desktop, we don't have a sad.txt. If I do read plus here, so read and write, and I run this, I get a file not found error. If I do a write here, and I run this, all right, it looks like it worked. If I look at the files, I have a sad text now. So now if I open it, I have a sad face text. So write also creates a new file if it doesn't exist already or overwrites the existing one. So you want to be careful once again with the mode, whether you want to append, whether you want to read, whether you want to read and write. But most of the time, the most common ones are read, write, and append. Now, in the next video, I want to talk about this idea of a file. I've written text files for now, but we could have written anything. We could have done a .py file if I wanted to. But what about accessing files that are in different locations, such as inside of folders? We're going to explore that topic in the next video. I want to talk quickly about file paths, because for some people, this might be a new concept. up until now, I wrote, let's say something like sad.py or sad.text, and I was able to run this code because when I ran it in my terminal or command prompt, they were all in the same folder on my desktop. If I do present working directory on a Mac, it shows me where I'm currently at, which is the desktop. So I was able to run it like this because my script file was in the same folder as my sad and test text. But what happens if this wasn't the case? We can actually jump back a directory by saying cd ... So if we go back, my present working directory is now user anagoe. So I'm not on the desktop anymore. So that if I try and run Python 3 and then say script.py, well, can't find the file, right? So let's go back to desktop and try to figure out this problem. I'm going to, for now, make a directory and call it, let's say, well, a very generic folder. Or let's just call it app. So now I have an app folder. I can move this sad text into the app folder now. So if I grab the sad text and move it to the app folder, if I go back now and try to access sad.text, so let's say Python 3 script.py, well, if I go back, I've appended sad.text, so it's actually creating it for me. So instead, let's actually remove sad.text because we actually have one already in here in the app. Instead of appending it, let's just do a read. If I try to read now, I get a file not found error. Sad.text doesn't exist because it checks the desktop. And on the desktop, we have nothing. We don't have sad.text. So how can we get around this? Well, I simply say that I want to go into the directory app/sad.text. So that if I run this, now it's reading it, but it's an unsupported operation. So let's just turn this into a read. And we don't need any of this, so let's just print read here. If I run this, all right, it's working now. I'm able to change the file path. Now, if you're on a non-Unix-based system, that is, if you're not on a Mac or Linux and you're on Windows, most of the time, instead of this slash, it's a backslash, like this. So Windows and Unix systems have different file paths and file system in place. So this is something that you can read up on. Depending on your file path and what your present working directory is, you'll have a better idea of how it should look. On Windows, it's usually something like C and then backslash, and then you'll have different file paths. Now, this is called a relative path. So relative to where I am, where I'm running the script from, I am going to go from here into the app into sad.text. I could have also copied this entire file path like this. And this is called an absolute path. So if I run this, this still works because I'm giving it an absolute path. It's saying, hey, on this computer, this exists from the root user all the way into here. So this is another way of doing it. But most of the time you'll see relative because it's a lot simpler. Finally, you might sometimes see something like a dot slash. Dot slash simply means from the current folder. So if I run this, it's still going to work. It's going to say, hey, from the current folder, go to app folder, then go to the text folder. If I do dot slash like this, if I run this, I'll get an error. Dot means back a folder. So instead of our present working directory being desktop, because we did dot, we'll actually go into my user account, and it's going to try and find anagoe/app sad.txt, which is not going to find. Anyway, this is a bit of a tangent, but I wanted to let you know that these file paths are important, and it's really dependent on what operating system you're using, like Mac or Windows, and also where you're calling the file from. Let's continue our discussion of files in the next video. One quick note that I forgot to mention, there's a really useful built-in module in Python, and you can see here it's new in version 3.4, called pathlib. It's an object-oriented file system path. Now, the main thing is you can see how to use it through the documentation, but the key thing is that if you're building a program that, let's say, reads something from the file system, like a file, and this program can be used both on Windows and Mac and Linux systems, you want a way to make sure that it works on both, right? Because we saw how Mac and Windows have different file system with different slashes. Well, pathlib library actually works with both. You can see over here, if you want to manipulate Windows path on a Unix machine or vice versa, this is going to work for you. And it's a good way for you to create software that is compatible with both systems, because pathlib is going to take care of the file paths for you based on what machine is running your code. Now, this is something you can read on your own and experiment, but I wanted to let you know that this does exist and it is a useful library for you to have in the back of your pocket. That's it for now. I'll see you in the next one. Bye-bye. Welcome back. One of the common patterns when working with files is to actually put them in a try except block. So in here, we can say try and actually put them like this, and try out to see if the file exists. So we can say except, and let's say file not found error, which we've seen before. And here I can say as error, and inside we'll say print file does not exist. So that now if I run this, and remember in our current directory, we don't have sad.txt. If I run this, I get an error, file does not exist. We can even raise this error if we wanted to. So we can say raise error. So now it works as expected. I'll get file does not exist and then give a file not found error. So this is a common way to work with files to handle different errors. Another common one with files is this idea of an I/O error. And an I/O error usually happens when the computer or the machine you're on has some issue reading or writing or doing any sort of I/O operation. So you can have something like I/O error in here and raise that error if you want. Again, if I run this, file not found error. If for some reason I give it a weird mode to do, I get an unsupported operation error. The options are endless, but I hope by now you have an idea of how to do file I/O. But let's do a fun exercise, because up until now, we haven't really done anything exciting. We just read a bunch of text from a file and that was it. Nothing that's creative, right? So let's do something fun. In the next video, we're going to try and build a translator. That's right. I'll see you in the next video. Bye-bye. All right, it's time for an exercise. And I think this is going to be fun. I want to use what we've learned up until now to build a translator. Let's say somebody gives you a massive text file. I mean, in our case, this is going to be the text file, but you can grab any text file that you want. It doesn't have to be a text file. It can be anything. It could be a Py file. It could be just a Word document. And type in a bunch of sentences in here, whatever you want, and just save it. In my case, I just have this. Now, somebody just told you, hey, I want you to translate this into, let's say, Japanese. Based on what you just learned about modules and files in Python, can you build a tool that allows us to run a command through that file, read it, and then translate it into Japanese? Now, if you really want to get challenged, you can pause the video and try it out. Or if you want a hint what module or library to use, well then keep watching, because I'm going to show you the recommended package to use. Okay, so what I actually did was I Googled Python offline translate using the PyPy index. Now, I wanted an offline translation service because if you look, there's something like Google Translation that you can do. But what that does is actually make a call to the Google servers to do Google Translate for you. And that gets pretty complicated when we talk about APIs and API keys, something that we're going to worry about later on in the course. I wanted something offline, so I can download the translation service offline and just be able to use it right here. So the one that I found was, as I was Googling, I think it was called this one. Yeah. So this is just a translation service. It looks like it has some stars and forks on GitHub, so I always like that. I always like checking out their repository. So translate Python. Everything looks good. You can read about the documentation here. Hasn't been updated in 2 years really, but you know what? It's not that bad. It'll do the job. So using this package, you can try and read through the documentation and see if you can figure out how to solve this problem of translating that file into Japanese. You can pause the video here, give it a go. Otherwise, I'm going to provide the answer. Now, the first thing I'm going to do is, before I even install this, I want to make sure I can read this file. So once again, I'm going to say try, and I'll have a file with open. We'll see where the file is. Let's say ls. We have the test file right in here, so we can just do // and say test.txt. And then I'll say as my file. We'll add the mode as read for now because we just want to read the file. But at least this way we're being explicit and we're saying, hey, this is exactly what we want to do. And then finally, I'll just, for now, print my file just to know that it's working. And we'll add some exceptions in here. It's except, not exception. And we can just, let's say, do file not found, error. We'll say as E. And we'll just, for fun, say here, print, check your file path, silly. And leave it at that. If I run this code, let's say Python 3 script.py. All right, I have my name is Andre. Awesome. Let's install the package. So over here, I can see that I have to install translate. That's what the package is called. Now, I'll use pip3 in my case to make sure that I'm using the Python version 3 and say install translate. Now, I've actually done this before just because, well, I tested this out beforehand, so it's already installed. So let's clear that out and read about how we can use this package. So you can see here the usage. So I can use it from the command line. Okay, that's interesting, but I want to use it as a module. Okay, here you go. Use as a Python module. So it shows you exactly what to do. So we import it first. So let's do that. I'm going to import this library. All right, so now we have the translator. And we can use a translator like this. All right, so we have the translator. So we create the translator class. And we want to say to what language. All right, what languages are available? Let's go to the read the docs here for documentation and see if they have Japanese in here. All right, let's see. Search docs, Japanese. All right, that doesn't help us. Let's look at overview. And by the way, I'm showing you the thought process that I usually have when I look through things. because sometimes people show you what the answer is without showing you the process. So hopefully this is useful. Okay, so I'm looking through here. It doesn't look like they're providing a list of languages, although, oh, I see it here, available languages. It looks like we're using this Wikipedia page as a reference. And oh yeah, these are the short terms for the languages that it's using. All right. So based on this, it looks like this is the standard that they're using, but actually while reading the documentation, I see that there's a JA. I'm assuming this is Japanese. So let's do that. I'm going to say JA. All right. And then let's see, go back to the documentation here. Let's look at overview. Let's go back actually. Okay, so once I've created the translator, I've given it the language. All we need to do is say translator.translate and give it what we want to translate. Okay, nice and easy. So in here, because myfile.read is going to give us the output that we saw, I'm going to say text equals myfile.read and simply do the translation equals to, what was it again? It was translator translate. So let's just copy that. So translator translate, and we want to give it the text. So let's see that. Whoop, that's not what I want to do. Let's do text. All right. So if everything works, hopefully it does. Maybe it doesn't the first time around. Let's give it a go. If I run Python 3 script.py, well, we definitely forgot to print here. Looks like we're not getting any errors, which is good. So let's do print translation. Let's run this again. Hey, look at that. Watashi no namae wa Andore Neagoe desu. By the way, I feel like I've been talking a lot and you haven't really talked back to me, but let's get to know each other. I actually learned Japanese before I even learned English. Fun fact about me. All right, let's get back to the topic at hand. This is working. This is actually pretty cool. Let's finalize this by actually converting this file to a translated version. So I'm going to say, I'm going to read this file, and once I'm done with this translation, I'm going to, with open, I'm going to create a new file. Call it, let's say, test-ja for Japanese .text. The mode is going to be to write. And I'm going to say as my file. And in here, I'm going to simply say, or let's do my file 2, so it's not a name conflict, and say simply, let's make this a little bit bigger just so you can see. And in here, we'll just say myfile2.write and write the translation. All right, let's see if this works. I'm going to run it again. Okay. Now, if we go to our desktop, there's a test.ja text, and look at that. We have a translated file in Japanese. I think my name should be in katakana, but hey, this still works. Pretty cool, right? Hopefully you got this far. If you didn't, you see the power of reading and writing files and also using libraries to do different things to your data. Very, very cool. Let's take a break, and I'll see you in the next section. Bye-bye. Let's talk about regular expressions. Now, regular expressions aren't unique to Python. As a matter of fact, you see them all over programming languages. But I'm going to teach you regular expression just quickly because they are very useful, especially when you're doing, let's say, validation, like checking that somebody has entered the right email, or you have password requirements, or you want to check if a piece of string exists in a piece of text. So this is something that we're going to explore in this video. Regular expressions. What are they? Well, luckily for us, Python comes with a regular expression module. Remember, regular expressions aren't Python specific. You can use them pretty much in any language. But they're very useful for finding things in a piece of text. So let's say we have a string here. And we can say string search inside of this text, please. There we go. Now, let's say I wanted to search for something here. First of all, could I do something like this? Could I say search in string? Let's print here. And if I click run, I get true. And this is a simple way for us to search something inside of a string. So why do we even need regular expressions? Well, regular expressions are a little bit more powerful than just this, because maybe we want to search how many times search occurs in the string, or maybe we have a complicated string. Let me show you what I mean. The way we use something like regular expressions is using this format. So I can say re dot, and then in here use search. And as you can see here, we give it a pattern and a string and some flags. We'll talk about that a little bit later. So all we need to say is, what pattern do you want to do? Well, I want to search if this exists in the string. So I can say this, and then give it the actual string. In our case, well, this is our string. So if I run this, well, let's print out what happens here. So let's do print. If I click run, all right, I get what I call a match object. A regular expression gives us an output, not just true or false, but an actual object that tells us a little bit more information about this. And you can see over here, one of the information is the span. So where it occurs in the string. It occurs at index of 17 and ends at index of 21. So that's really useful. Let's store this information and just say A here. So what can we do with this match object? Well, the first thing we can do is to check what we have. So we have, first of all, span, which we've seen. And if I run this, it tells me where the string occurs as a tuple. So index of 17 to index of 21. I can also do start, and start, well, tells me when the text starts. And I can also do group, or actually, I can also do end to show me where it ends. And then I can also do group. And group returns the part of the string where there was the match. And let's say there was another this in here. If I click run, you see that, well, it only gives me that piece of or part of the string that there was the match. Now, group is really useful when we're trying to do multiple searches. So in our case, we are just doing one search. So we have a pattern that we're trying to match. But there's ways that we can do multiple searches within the one line. But before I show you that, what happens if we do something that doesn't exist, such as this with a capital S? If I click run, I get an error because now A is going to be none. Because if the regular expression doesn't find anything, it's going to return none. So it's either going to return a match object or none. Now, how can we make this more advanced? Well, one thing we can do is to create a pattern that we want to check for. So let's say pattern here. And this pattern, we're going to use regular expression dot compile. And the compile is going to allow us to give, just like we did here, a pattern. So let's say in here, I simply want to check for this. Now, this pattern I can use, instead of just doing re.search, I can just use the pattern now to do the search for me. So again, if I run this, well, now I don't have to pass it this. I need to just pass it the string that we want to search. See that this is being captured? And I can use pattern now everywhere, multiple times. So let's say I can do pattern dot all the methods that we have. We have quite a lot, actually. Let me show you some of the useful ones. We have find all, which finds all the instances of the match. So let's say in here, B, and click run. Look at that. I have this and this. So I get both instances of this inside of a list. I can also do something like full match. And full match, well, makes you sure that everything matches fully. So if I click run here, let's print C here, click run, I get none because I don't get a full match. In order for a full match to return the match, it has to be the exact string that we're searching. So if I click run, there you go. I get a match object now. Now let's say I have a question mark in here instead of an exclamation mark. If I click run, it's none. If I have exclamation mark and then maybe something else afterwards, I still get none. We also have another option, which is match. And match, as you can see, matches 0 or more characters at the beginning of the string. So if I do string here and I print D, well, actually, let me change this up. Let's do here, Andre, in the string that we're actually comparing. And if I click run, I still get a match object versus if I do C, which uses a full match, which gives me a none because, well, we only want an exact match here versus a match that matches the string and then doesn't care what comes afterwards. So this is extremely useful. But up until now, I mean, we get a couple of methods that we can use, which are quite useful, but this doesn't seem that powerful. Why do all languages have regular expressions? Why do we really care? Well, in the next video, we're going to explore this idea of pattern and how we can do some really advanced patterns. I'll see you in the next video. Bye-bye. Welcome back. Up until now, we've found just simple patterns, simple text patterns in our string. Nothing too crazy. But where regular expressions become really useful is for advanced patterns. You see, with regular expressions, you can do some crazy patterns like, let's say, this. And this looks like complete gibberish, right? But this means something in regular expression. You can think of regular expression as an entire language in itself, with different patterns that you use to find, well, patterns inside of text. Now, the whole world of regular expression is really, really complicated. As a programmer, I don't expect you to learn all these patterns. You can see some of them here. We have special sequences that mean something, like /d returns a match where the string contains digits, number from 0 to 9. You have things like sets over here, where if you type in a regular expression this, it returns a match for any characters, alphabetically between A and Z, whether they're lowercase or uppercase. So there's all these little shortcuts and tricks that you can write in a regular expression. And things can get really, really complicated. So nobody actually memorizes these things. You develop them as the need arises. And as a matter of fact, later on in the videos, we'll do an exercise where we'll actually experiment with this and create a password checker and an email checker. Now, one of the tools that I really, really like is called regex101.com. It's super, super useful. All you do is we'll pick Python, and it'll give you regular expressions and a testing ground for you to test. For example, if I wrote something like, hey, how are you? I can now enter a regular expression here and try things out. So for example, if I type in, hey, how are you? Well, this doesn't really work. Maybe I can add some quotes around here. But nope. And it actually gives you some options and information as to what you can use. So for example, let's say we wanted to check if, well, right here, a character in a range A to Z or A to Z. If I copy this and I paste it in, look at that. It gives me full matches that I have. In this case, I am checking to see, hey, does it match any character between A to Z, both lowercase and capitalized? Everything is matching right now. You see over here that we have match 1, match 2, match 3, so on and so forth. I can also group things. So I can do brackets here. And now this is the first capturing group. And then I can do something else here. Let's say in here I want, let's say anything that is A. So what does it mean here? Well, I have an explanation on the right-hand side. The first capturing group says, hey, match a single character present in the list below. So it tells you A to Z, capital A to Z. And then the second capturing group is, hey, match a single character present in the list below, which is A. Now in here, I have two capturing groups. So the first capturing group and then the second capturing group. If I add a dot here, which is a special meaning in regular expression, if I hover over, you see that it matches any character except for line terminators. So what am I doing here? Well, I'm first have, hey, I want you to check for the first capturing group, which is any single character in the range between A to Z. And then after that, I want any character. And then after that, I want you to search, well, for any matches of A. So this is what we match for. We match W because we're looking for any letter, and then a space or any character, and then an A. So now we have a full match, which is W to A, and then we have group 1, which is W because it matches the first group, and then group 2, which matches the A. Now, I know this is confusing. Regular expressions is one of those things that it's really hard to figure out at first. So let me show you how we can use it. If I go to code generator here, you'll see that I can actually just, well, give you a sample code that you can use in Python. But what I like doing is actually copying this piece of text like this and going back to our code editor. And in the compile, paste it in. Now you'll notice that there's an R here, and R stands for a raw string. Because in Python, something like a slash, backslash has special meaning because remember, with backslashes, we can do special things like new line or tab. An R says, hey, this is a raw string. Ignore everything that Python interpreter might interpret. I want this to just be a pure string. So you'll see this a lot with regular expressions. Now, if I run this code, you see that I have SEA here. Again, it's because I am searching for a letter, followed by anything, followed by A. And if I have a group here, which I'm searching through, if I do group 1, I get S. If I do group 2, I get A, just like we did in our playground here. Another useful thing is in here. If you look at the quick reference, you can actually search for things. So let's say I wanted to check if a test string has maybe starts with. So I can type in start here, and you can see here that, oh, it gives me a quick reference. So if I do start of string, it shows me, hey, use this character and it'll help you do start of string. So if I do, let's say, in here, this caret and say, hey, look at that. It matches it for me. So it says, hey, assert position at the start of line. It explains exactly here how it works. And it tells me that I have a full match here. Now, most of the time, the way you'll be using regular expressions isn't like this. It would actually be quite hard if you're just figuring everything out yourself. Like I said, nobody really memorizes these things. You can see that we have quick references with common tokens that you can look through and understand. But a more practical way of actually learning about regular expressions is to see a real-life use case. Now, I'm going to leave some exercises for you that you can do if you want to learn about some of the common patterns. From my experiences, this is not something that anybody's going to ask you about in an interview. You don't really have to memorize regular expressions. You just need to know what they do. So try the exercises if you want. Otherwise, I'll see you in the next video to show you exactly how you would use regular expressions in a real life scenario. I'll see you in that one. Bye-bye. Welcome back. Up until now, we talked about regular expressions quite loosely. And I mean, you should understand that it helps us match different things together. But the problem is, well, how can I really apply this to real life scenarios? Well, a good use case is perhaps when you're collecting emails. Maybe you're creating a startup. This startup wants to collect, let's say, emails of interested customers. Now, we want to make sure that whoever is interested in our startup enters proper email addresses, right? Because we don't want anybody to fill our databases or our Excel sheets with random words. We want to make sure that something is a correct email. Otherwise, it says, hey, this is not a correct email. Please try again. And regular expression is a great thing to use for validation and just making sure that whatever a user inputs or whatever another machine inputs into your code is in the correct form. So let me show you an example of how I would do this. Let's say I want to do an email validation. Well, the first thing I would do is simply type in Python email validation regex. And here you see here that we have a lot. How to check for valid email addresses. And pretty much the first couple of answers are going to be what you're looking for. I like this one. Email address regular expression that works 99.99% of the time. That's good enough for me. So in here, you see that we have some idea of what we can use. If I scroll down, looks like we have regular expression for different languages. All right, let's do Python. I'm simply going to copy this. And now in here, let's go to our regular expression 101 and just copy this in here. Now, I get an error because you see here that the R is already included because I've selected Python here. So let's just remove the brackets. Again, if we hover over here, it's going to tell us about each thing that it's trying to do. And we also have the explanation. So this is how I like using regular expression. I find something online that people have used in the past. I don't try to reinvent the wheel and then try to understand it. So just to test this out, if I type in an email address here, look at that. I get a match. I get a full match and it matches the group one. Let's go one by one. First, I see that I have the brackets. So this is the capturing group. I'm trying to capture one data point. If, let's say, I enter another email here, that's not going to capture it. If I go like this, it's not going to capture it because, well, we're looking for one capturing group. Okay, next I see that it's asserting a position at the start of the line. So at the start of the line, we want to make sure that it captures this. So it matches a single character present in a set. So this email can be anything. It could be letters, it could be numbers, and then finally it could be underscore. It could have a dot in there. It could have plus, it could have minus, and then finally plus is a quantifier. So it matches between 1 and unlimited times. So this string can be as long as I want, and it's still going to work. It's going to accept plus, minus, it's going to accept underscore, but it's not going to accept an exclamation mark because it's not in here. All right, so that's good. What about next? Well, the next part is the @ sign. It's literally the @ sign. We have to make sure we have it. And then after the @ sign, again, once again, we have the characters that we can use with a plus at the end to say, hey, you can have as many of these as you want. Perfect. Next, we have a special one. matches the character dot literally. So because dot in regex, if I remove it, actually means something, it matches any character, 1, we want to make sure that the dot, well, is exactly what we're looking for. There needs to be a dot for, let's say, .com or .ca or .net or .org. If instead I didn't have this slash, this could be any character. This is still a matching string without a dot. So again, special character right here. And again, it actually gives you explanation. So if you scroll down through here, it'll tell you exactly what it does. All right, after the dot, once again, we have anything that we want within these square brackets, then as long as we want, and then finally this $sign says, hey, it has to end with this. This is the end of the line. Awesome. So using just that, we're able to figure out exactly how to do an email validation. So all I need to do now is, let's say, go to code generator, copy this piece of code. Again, we're using a raw string because we want to make sure that Python interpreter just doesn't try to add any special abilities to it. We just want to make sure that this is a raw string. Make sure I end that. All right, perfect. So now inside of this string, let's say I have an email address that a user sends me, such as b@b.com. If I just remove all of these and just do a pattern, and let's just simply do, well, let's just check if A exists. If I click run, all right, this matches. But if somebody gives me a wrong email address or something that's not formatted properly, let's say just like this, and I click run, I get none. So I could do an if statement saying, hey, if there's no matching object, well then tell them, sorry, try again. Very, very cool. So I have an exercise for you. Using what you've just learned, and definitely your Google skills, because with regular expressions, you will Google. You're not going to memorize any of this. I mean, I don't. What I want you to do is to create also a password checker. So the password has to have a few requirements. So the password has to be at least 8 characters long, and it can contain any sort of letters, numbers, and you know what? It can contain, how about these symbols? That's it. So write a regular expression just like this using this regex 101. And in the next video, we're going to try and do this as well. I'll see you in the next one. Bye-bye. All right, let's see how you did here. Now, I could just Google this and figure it out on my own, and I recommend that you do that as well. But for now, just based on the fact that we only have 2 things, let's try and write this from scratch. Again, not something that I recommend, but hey, this will be fun. Let's give it a go. So how would I search for this? Let's say I want to make sure that it's a password, again, 8 characters long or more. But first I want to make sure that the password contains any sort of letters, numbers, and these symbols. You know what? Just for fun, I'm going to add an extra challenge. I'm going to say it also has to end with a number. Now, I know this is completely useless because you wouldn't want a password like that. That's way too restrictive, but I think this would be fun. Now, in here, we want to check a password. Let's say it's super secret. It has some of those symbols that I mentioned, and it has to end with a number. So we have to match all of this, and it's over 8 characters. The first thing I'm going to do is use our square brackets and say that we want to check for A to Z, which we've seen before. If I scroll here, we have A to Z. We also want to make sure it's lowercase as well, so A to Z as well. All right, we're matching some of the things. You also want to make sure that, yeah, you can use numbers, 0 to 9. All right, so we have some numbers in here. Let's say if I added some numbers, that works as well. And we also want to make sure that we can use some of the symbols. So let's just add the symbols that we can use. Let's go back to here. We can use these symbols. So let's just copy them and paste them in. All right. Everything in here that matches is good. And looks like, yeah, we're matching things right now. That's good. But if I enter another letter here, that's not going to work. We want to make sure that it ends with 8. We also want to make sure that it's going to be at least 8 characters long, because I could just do this and everything still works. So how can we do it? Well, let's look at the reference here. If I scroll down, let's see. We have exactly 3 of a kind, 3 or more. Okay, this might be useful. A, 3, comma, and these curly bracket matches at least 3 consecutive 8 characters. All right, so it shows you exactly what it does. I think this is useful. So we want to make sure our password checker is at least 8 characters long. So we're matching, instead of A, we're matching this whole string, and it has to be at least 8 characters long. So let's make it 8 characters long, and look at that. This is matching. Awesome. Now the next part is we want to make sure it ends with a number. So how can we do that? Again, let's check out here if there's anything special. Let's do number or digits. All right, look at that. Any digit. So let's say any digit. So this /d is going to match any decimal digit, equivalent to 0 to 9. All right, so if I do, let's say /d, all right, everything is still matching, but if I type anything else out here, yep, now it's failing. So there's our password checker right here. So I can just go to code generator, copy this, go to my REPL, and here let's just create a new one, say password, that will have the compiled pattern, R, and then paste this in. So this is going to be our password, and I'm going to check our password. Let's say B, or let's just say check equals pattern, or instead of pattern, let's do password. And then we'll do a full search. And in the full search, we'll give it the string. So the string that we're going to check will be the password. So let's just change this up. We'll say pattern here, 2. So this will be pattern 2, just so we name it properly. And then the password is going to be string, some password, some numbers, maybe some symbols here, and then ends with a number. So let's see if that works. If I do password here, and I do check, click run. Oh, it's not full search. It should be full match. If I click run, there you go. Everything is working. As soon as I type in a letter in here, I get none. If this is less than 8 characters, I get none again. Very, very cool. Hopefully you were able to get that. If not, like I said, I think out of this entire course, this is probably the least important section. I know I'm telling you this at the end, so you at least do it. But I wanted you to know that regular expression is a thing that you might encounter and you might use throughout your career. But like I said, it's one of those things that if I had to rank the importance of, it's probably at the very end. So hopefully your head doesn't hurt too much. I'll see you in the next video. Bye-bye. Hello, and let's talk about testing. Testing, you see, is an important concept in programming, not just Python. Although we start off writing simple script files with few lines of code, when we start getting into the real world, you start getting thousands and millions of lines of code. Hundreds of Python files worked on by many people from different divisions in a company, and most likely all of them starting at different time at the company. All the code changes happening over time at different times as people work on the project as the complexity of the code and the size of the code increases. It becomes harder and harder for someone to fix a bug that may arise. Let's say you come into a project that has been around for years. You may modify something that may modify another part of the app that you didn't even think of. And you start creating all these bugs with new features that you introduce into the app. The longer that the code stays in a project, the more likely it is to be touched by different developers. So you see the problem here, right? For companies, this is a huge problem because you're most likely always growing your product and adding more and more lines of code. That means that they're just going to keep making this giant monster that becomes harder and harder to tame and debug. And it costs companies a lot of money. Luckily for us, we have something called testing. And testing can help us solve this problem. As the name suggests, testing is a method in software development where individual units of source code, such as functions, are tested to see whether they work properly. Although it may not be a big part of a coding interview, a lot of companies usually don't think about testing when interviewing people. It becomes more and more important as you go through your career. For example, in my case, when I first started out as a programmer, I didn't know that much about testing before I got hired. But the importance of testing grew more and more as I progressed through my career, and it's one of those things that has made me a better developer. So if you want to become a senior programmer, and if you want to have a long-lasting career, you really need to master this skill. Because remember, every serious company is going to have tests, and they'll want you to write tests for your code. So let's explore this idea of testing a little bit more. You see, a test is simply another Python file. Now, in my case over here, I have a main.py and a test.py file on my desktop, right here. Usually you have a test file like this accompanying one of your files. So, for example, if you had 100 files of Python or modules, then each of those modules will have its own test file that you can run tests with. Now, this file that we're going to be writing never actually runs in production. It's a file that we run to make sure that before we release this main.py file to production, that everything is working properly. So this is only for development, but we would never actually, the customers will never see this file. Now, before we actually start writing some tests, I do want to remind you that we did learn a few ways to debug our code, right? We learned about things like pylinting that we installed in our Visual Studio Code to lint our code and check the syntax and small errors as we type our code. We also saw how the online REPL that we used another thing called pyflakes, which is just another linter. And then we also saw that PyCharm, our IDE, also had built-in linting. We also learned that we have something called AutoPep8, or PEP8, which is the standard style guide for Python. And this allows us to make sure that our code meets a style that the Python community has agreed on. These are the simple tools that allow our code to be checked for simple styling issues or simple mistakes, such as not declaring a variable. But these only get you so far. And testing is a higher level up, a way to, after you do linting, after you do something like PEP8, after you've met all those requirements and your file runs, testing is a way to actually check even more of your code. So how do we write these tests that I keep talking about and not coding? Well, let's find out. Luckily for us, there's a built-in module from the standard library that we can use. And it's called unit test. So in the next video, we're going to start writing some tests, writing some sample code, and show you exactly how they benefit us as programmers. I'll see you in the next one. Bye-bye. Welcome back. Let's write our first tests. Now, we're going to just have a simple function that we run in this program. We'll create in our main.py file let's make this a little bit bigger. We'll say that we have a function called do stuff. Yes, very descriptive function. Now, in here, we'll just say that we accept a number, and we'll just simply return num plus 5. A very, very simple function. So let's say this was our code that builds our app. So this is just one function, but hypothetically we have many functions that we want to test because these are actions that we're going to perform in our code. So the way unit test works is like this. We have our test file, and after we import our unit test, we want to import, well, the file that we want to test. In our case, it's main.py. So let's just import main, which is right here. Or we can just import the function as well if we want. But in our case, hypothetically, we have many functions here, so we can just import main and use all the functions available there. Now, the way unit test works is we create a class and then name it whatever we want. In here, we'll have all our tests. So let's just call it test main. And we inherit inside of this class what unit test gives us, which is a test case. So this is just a standard way to work with unit test. So we're inheriting whatever unit test case is, and now we have that functionality available in our test main class. Now in here, we can start testing and writing code to test. So how can we test main do stuff function? Well, we simply say, hey, let's write a function in here or a method because this is part of a class and say, hey, I want to test do stuff. And in here, it will receive self. Now in here, I can test my code. So I can say if number in here is equals to 10, I'm just giving it a random number, then I'm going to say result is going to equal main dot do stuff. So remember, do stuff comes from main, which is the function that we want to test. So I want to run the do stuff function, and in here, give the parameter num, which I've just given here. Or let's just call this test param. So this test param, we're going to run the code, and we're going to get a result. And this last line is the key part of unit test. Unit test allows us to say self.assert equal. And assert equal is something that we get when we inherit from unit test. And assert equal says, hey, assert or make sure that these two parameters are equal. In our case, I want to test that the result is equal to, well, in our case, 10 plus 5 should equal 15. All right. Now, finally, in here, we just run the unit test. And the way we run the unit test, because this is just one test that I did, I could have done multiple tests. All we need to say is unit test dot main, which will run the entire test file within the test main. Now, if I run this now, all I have to do is say Python 3 in my command line and say test.py. And I get, okay, ran one test in, well, super fast, in 0 seconds. That was nice and quick. Now, let's say I do something else where I assert equal that this equals 10. If I run this, look at that. I get a fail. What failed? Well, the test to do function failed. On line 8, so that is right here, we have an assertion error. We got 15, but we expected 10. How cool is that? So I now have one failure, so I need to fix my code. So something's not right here. Now, in my case, this is because I've asserted the answer to be 15. But what if we create another test in here and check, hey, what if we have test do stuff 2, and this time the test param is actually going to be a piece of string. So what do we want the function to do? Well, in our case, maybe it gives us a error, maybe a value error. So I'll just say value error, because this shouldn't work. If I run this now, let's clear this. If I run this now, all right, I have 2 tests, but I have 1 error. And I see here that I'm getting an error saying that, hey, I'm getting a type error. Can only concatenate string, not int. Now, in this case, what actually fails is the test file, because what we've just done actually fails our function. But right away, I see that, all right, well, this is something that we need to fix. So I can go back to main and say, hey, I want to make sure that we catch any errors, like type errors or value errors. So the first thing I can do is just say int number. And if I save that to make sure that we convert something to an integer and I run this, all right, now I get a value error, invalid literal. So int can't be run on this piece of string. Okay, so another thing we can do to improve our code is to wrap it in a try except block, right? And then we can catch, so let's say except, and in here, accept a value error. And let's say as error. And in here, we can do whatever we want. So we can return, if we want, the error, or we can even raise the error. In our case, let's just return the error. And I'll show you why in a second. Now, if I ran this, you see that my test fails, but now it's actually an assertion error. The assertion error is coming from our test file over here. And I'm asserting that, hey, I want to make sure that the result and the value error are equal. Now, you see over here that there's a bit of a mismatch. We have a value error over here doesn't equal the class value error. Now, this is a bit of a trick where because we're returning an error, it's actually an instance of the value error class. So we need to do something like this. We need to say, hey, is instance, and say, what is it an instance of? Well, is result an instance of value error, like this. But the problem here is that, let's make this a little bit bigger. The problem here is that assert equals is going to expect 2 parameters, 2 things that must be equal. But here, I just want to make sure that this returns true, that the result is an instance of value error. So how can I do that? Well, besides assert equal, we have a few other methods that unit test gives us. If I go to the unit test documentation here, on the first line it says the list of assert methods. So here I see that these are all the methods for asserting and testing our code. The one that we probably want is this one, assert true, to check if something is true. So if I do assert that this is true, and I ran my test, let's clear this, and run my test again. There you go. I ran 2 tests and everything seems to be okay. And again, to go over this, why is this? Well, I'm running my test file, and then I'm going to run the test, do stuff, which is going to be okay. Then I do the second part, where the test parameter is something that we don't really want, which is just a piece of string. The result is going to give us a value error because we've caught this error and we're now returning the error. And then finally, we run this piece of code. Hey, is this true? Is the result going to be a value error? So you see what we're doing here. What we're trying to do with our test is to improve our function by simply trying to break it. So we want to break our function and see, hey, can I trick this function into giving me an error? And then once you do that and a test fails, then you go back to the function and try to fix it, kind of like we did here, which is really, really cool. This is a common practice with testing where you try and break things until, well, the function becomes perfect. Now, I want you to take your time here and see if you can break this function and maybe add a couple more tests. In the next video, I'm going to add a few more to make this function even better. I'll see you in the next one. Bye-bye. Welcome back. Let's continue with our unit tests. Now, one thing I noticed here is that when looking at the documentation, we actually have an assert is instance. So we can actually, instead of saying assert true, just use the assert is instance, which we give A and B. Again, all these assert methods, there's no right one. You can use whichever one you want as a tool to improve your code. So in my case, let's just change this to assert is instance and fix this like this. So just a little cleaner. Let's see if this works. All right, everything is still good. Okay, let's try and break our code again. So everything is looking good, but what if we do something different? What if we do, let's say, add another test, and we'll say test do stuff 2. Usually you want to name these functions a lot better so they're more descriptive. But in our case, this is fine just so we can see how they work. This time around, let's do test param is going to equal, how about a none type. So now if I run this, let's run this code again. And by the way, you might notice here how I'm copying code in a test. And you might think, well, can we just make this simpler and not repeat ourselves? And you can totally do that and make things a lot easier. But when it comes to tests, because they don't go into production, and this is just for development purposes, you really want to have tests that are easy to read so that other people understand your tests. Because when it comes to testing, readability is really, really important. We don't care as much about not repeating ourselves and making our code efficient, nice and small. So I like writing tests that are really descriptive, really obvious. All right, in here, let's say self.assert equal, and what should this be? Well, in this case, I'm expecting a value error. So let's do this. I expect that the result will be a value error. I'm going to save and run my test. All right, I get an error. It says this is a type error. Int argument must be a string. And I'm giving it a non-type. All right, so this isn't handling it properly because it just doesn't work with the int. We get a type error. So how can we fix this? How can we adjust it in case we get a non-type in the parameter? Well, first off, let's give it a default parameter. Let's say the default parameter is 0. If I run this again, I still get the error. Okay, so we still haven't fixed it. The argument must be a string. A byte-like object or a number, not non-type. Okay, so we're still not checking for the non-type. So another thing we can do is say if number, so we're checking if we have the number value. Because remember, this is going to default to true if it has any sort of numbers or, well, any value. But if it's a non-type, it's going to turn into false. So in here, if number, we can say return this. Else, otherwise, we'll return please enter number. So I'm going to say this and now change this because now we should expect please enter number into my test. And I'm going to say assert equal that result is going to be please enter number. If I now run my test, let's clear this. Looks like I'm getting ran 2 tests in 0 seconds, but we have 3 tests, and that's because you see here that I named mine the same. Remember, if you name the thing the same, well, it's only going to run one of them. So make sure that all the test names are unique. So I'm going to run this. All right, ran 3 tests and everything is working fine. Very, very cool. So you can see here how we went from a very simple function and we started catching these errors and started realizing how our function was too simplistic, that if we received a wrong input, like a string or a non-type, well, as soon as we did that, our function failed. So by using tests and as testing and breaking things, I was able to improve this function so it's more durable, so that now it works a lot better in production, right? And this is the power of tests. It allows us to check for any mistakes that we may have made, because maybe we wouldn't have thought of doing something like this initially. But by writing tests alongside our code, we were able to improve the function. Now, one last thing I want to add. Let's just add another one over the tests and say that this do stuff for. What if the test parameter is just an empty string? We should get please enter a number. So if I ran this, all right, 4 tests are passing. So it looks like our code is working nicely. Now, to finish off here, I want to just point out a few things. I'm calling here unittest.main, but this has nothing to do with the actual file that we wrote, which is the main file. If, let's say, I rename this, so let's go to my desktop and say I want to change this to script.py. Let's now open this, in my case with Sublime Text. Let's go back here. So you see here that main.py is, well, doesn't exist anymore. It's asking me to save. So this is a completely different file now. If I do script here and simply change all the instances to script, if I save this and now run, this still works. Unittest.main simply says, hey, just run all the tests over here. Now, one thing, and this is a common practice that we've talked about before, is because you want to say, run this file if this is the main file being run, because we don't really want to import test main or anything like this into other files. These are individual files that should only be run when we run our tests. So I can just say if __ name equals __ main, then run this piece of code. So now if I save this and run, there you go. Everything is still working, but now I make sure that this is a test file and I'm only going to run this code if it's the file that's being run, if it's the main file being run. So this is a standard way that you would have your unit test done with the unit test module. Let's take a break and talk a little bit more about tests in the next video. Welcome back. Let's talk about a few more neat things that you can do with unit test. And remember, you can always go to the documentation on the Python website and learn more about some of the things that you can do. But notice here how at the end we added the if name main. Some of you may be wondering why this is useful, because so far we've just ran it from the command line as a single file, and that has been working. But usually you have more than one file and you have each module tested with different functions, right? So ideally you want to run all these tests in unison. And the way you do this is to write Python and then -m and then give it the unit test that you want to run. So now if I do this, you see that everything is working. Let's say I add a new file here. Let's say touch test2.py, which is a short command on Macs to just create a new file. So now on my desktop, let's just copy this test that we originally have, go to my desktop and open up this in Sublime Text. So now if I copy and paste this, the exact same thing, and I save this, go back to my code and run unit test, you see that I have 8 tests now that are being run. And because I've added this if name main, I'm able to run all these tests with just one simple command. Now another neat thing is that we can do something called -v, which stands for verbose. And that is when we do this, we actually get more information about the test that we ran. So it gives you a little bit more detail. You see which tests we've run and which ones are okay, which ones have failed. As a matter of fact, I can even add comments and doc strings to my tests. So let's say test do stuff. I can say single quote 3 times and simply say hi. If I run this again with the -v command, and this has to be on a single line, I believe. Let's save that again and run this. Look at that. I also get some comments. So maybe I wanted to add a few comments on my tests. I can add those as well. What other neat thing can I do? Another default method that we get with unit tests is something called setup. And setup allows us to run a piece of code that sets up before each call of the test. So for example, whatever I write in here, let's say I wanted to set up my test and just print about to test a function. Now, because I have this, if I run my code now, you see that before each method, I run the setup method first. So you see that I say, about to run a function, about to run a function, about to run a function, and about to run a function. And then we have our test2 file that we haven't done any setup for. So this is really, really useful if you need to set up something before each function. Let's say you have some default variables maybe that you need to set up. Well, in that case, this is a very useful method. Another one, just like setup, usually you add at the bottom of the file. And in here, this is called a tear down. And as the name suggests, we run it at the end of each method that we call. So in here, let's say cleaning up. And usually you do this to clean up some variables, maybe reset some variables. If I run this, you see that I have now about to test a function, and then we're cleaning up for each one of these methods. So these two are very, very useful when setting up and tearing down tests. Now, tear down you won't use as often. Usually you'd use it if you're testing something more complicated like a database, but we won't worry about that too much now. All right, there you have it for tests. As you can see, at the end of the day, tests are simply logical programs that we write, right? It's just a class, and then we set up all these methods to try and test our code as much as possible. In our case, we just had one simple function. But by using tests, we're able to notice small things that can go wrong with the function and thus improve our code. So that next time somebody comes, another developer comes and tries to modify this function, or maybe tries to call this function with something that is not right, well, our tests are going to fail and it's going to let the developer know, hey, you're doing something wrong. Somebody who wrote this function before you, somebody that wrote these tests before you, told you to use this function in a specific way. Very, very useful. In the next video, we're going to do a fun little exercise to make sure we understand testing. I'll see you in the next one. Bye-bye. Welcome back. Let's do a fun little exercise by revisiting a piece of code that we've written before. Remember the random number guessing game? Where we had to guess a number between 1 and 10? If I run this file, you see that it asked me to guess. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. And I finally get the number. You are a genius. The number was 9. So how can we test this code? Now, one thing you'll notice here is that we don't really have a function. And remember when I told you about functional programming and how it's good to break up our code into small bits of functions that do one thing and one thing really well, especially pure functions? Well, one of the big benefits with that mentality is that you create code that is really, really easy to test. Instead of having really complicated logic in our tests, we can simply give our functions an input and expect an output. And this is why we have unit test. And the idea of a unit test is that we're testing each piece of unit. These unit tests are small little pieces testing these simple functions. So my challenge to you is to use this code and try to break this up into simple functions. Now, in our case, I want us to just test this part of the code, which is the guessing part, where we receive an input, which will be the guess, and then test it against some random answer that we have, and we should expect some sort of output. So either we enter a number, has to be 1 to 10, and if we get it right, we have to get the string. But the key here is that we probably want to move this into a function that we can test. We can ignore the outside world and break this up into its own little function. So pause the video here, give it a go. You're going to have to get through some stumbling blocks, but it's going to really test your understanding of tests. Haha, funny. That was a pun. So pause the video, give it a go. Otherwise, I'm going to get going with the answer. The first thing I want to do is to set up my test. Again, I'm going to import unit test. And I'm going to create with the class test main. Or let's call it test script this time, or test game. I'm going to say unit test.test case. This is going to be our test case. And in here, I'll create, let's say, just a simple test. Let's say test game or test input. Receive the self. And for now, I'm just going to pass this because we're not really doing anything. Finally, I'll say if name equals to main, then run the unit test.main. So this is just our simple setup. So if we run this now, let's say Python 3 test.py, you see that we ran one test. All right, so this is our setup. Next, what I want to do is actually take this out so I can use it in my test file by extracting it into a function. So I'm just going to say at the top over here, I'm going to define our guess game, or let's call it run guess. That's going to receive a input, or let's say a guess, and then it's going to run this code. So let's do that. I'm going to take this piece of code like this and simply paste it in here. Now, the run guess is also going to need the answer variable, so I'm going to give it a second parameter, answer, like this, so that now I can just simply, inside of here, run this function with the guess and answer, just like that. So let's save it here and run this test, or let's just run the actual file to make sure that it's still working. Oh, and we get a bit of an indentation error, so we have to make sure that our indentation is correct, because remember, in Python, that means something. All right, now we have an issue. We have a break outside of loop because, well, we're using the break keyword and, well, we're outside of a loop right now. So one thing we can do is we can say return here. So let's run that again and keep guessing a name or a number. And there you go. This is still working. I'm able to use return here because this, well, is going to run and return, but now we're still inside of the game. So maybe we can just return true and say if run guess is true, we're going to break out of this. Again, let's start our game. I'm going to just clear this and run the game again. 1, 2, 3, 4. And there you go. I've entered a number. I'm a genius. We've just finished the game. Let's make this a little bit smaller just so you can see. So we have our run guess. I've modified the code a bit. But the key thing is that I've extracted out a unit of functionality so that I can test something like run guess. So it looks like I've modified our code, but the code is still working. So now let's start testing our run guess function. Let's go here and start importing our script. And in here, do a few things. First, I want the answer to, let's say, equal 5. And the guess is going to equal 5. So we want to make sure that if the guess and the answer match, that, well, the run guess goes through the if statement and prints out you are a genius. Or in our case, returns true. So let's say self.assert equal that script, or actually, first time around, let's actually run it. So let's have result equals to script dot, what was it? Run guess, and give it the answer and guess. And we expect the result to return true. So we can just say assert true that the result is true. If I now run this, we actually start up the game. So how can we fix this? Well, we can close this and actually add the if name main in here. So down here, we'll say, hey, only run this if this is the main file being run. Just like that. If I go back to test here and run this again. All right, now it's working, but I get an assertion error. Test game object has no attribute assert true because, well, I misspelled that. Let's try that again. All right, it looks like one test ran and everything is good. We also see that it printed out you are a genius. Very, very nice. By the way, I'm showing you this way of testing because this is how a real life scenario looks. You keep breaking things, you keep making mistakes, and then you try and fix them and correct your code. And you can see our code is already looking better and better just by running these tests. Okay, what else can we do? Let's say here that we're going to copy this. And just so things are shorter, I'm just going to directly enter the parameters in here. Just like that. Let's say test input, let's say incorrect. Or wrong guess. So let's say the answer is 5 and I guess 0. So we want to assert that this is going to equal false. So if I run this, 2 tests are passing. That's awesome. What else can we test here? All right, well, we want to test that if the guess is not between 0 and 10, or between 1 and 10, in that case, we want to have a print of, hey, bozo, I said 1 to 10. So once again, I can test that if my guess, wrong number, let's say the answer is 5, but I give 11, we want to assert, well, right now we're printing and not doing anything. So maybe we should return false, just to have some consistency here. Again, if I do that and I run, there you go. 3 tests are passing. That's great. And there's many, many more tests that we can write. Maybe let's do one more test, which is to test what if the input is a string. If I run this, and make sure that wrong type here, make sure the names are different, and I have 4 tests running, because this isn't going to pass and it's going to return false. Now, there's many more things that we can do here, but you can see the power of tests right now. If you have different tests than me, that's okay. Everybody's test cases are different. The whole point of testing is to just simply look at our code and see how we can improve it, how we can break our code, how we can simplify our code by breaking it into smaller units that can be tested, and fix some errors that perhaps we wouldn't have thought about. Now, there's many more things that we can do, but you noticed here how the idea was to work on small piece at a time, test it, and then maybe further on, we can look at this part of the code, or maybe the try and accept part of the code. And here's the thing. When you're working for a company, I argue that there are an infinite number of tests that you can do. You can have hundreds of lines here to test your code to bits. But just because you're testing as many times as possible doesn't really make your tests good. Like I said, there's an infinite number of tests that you can write. The idea is to write good quality tests that cover most of your cases, but eventually you'll have diminishing returns, where you have to have a trade-off between writing code and writing tests. And sometimes, depending on what the job requires, you might have to focus more on tests and focus less on code. Or sometimes maybe you need to move fast and you don't have time to write tests. And again, depending on the business needs, that might be the case too. But with this section, I hope you understand some of the principles following testing in software development. That is, bugs are always going to arise in our code. And we can use linting to help us with this, but one of the best ways to make sure that our code is working properly is tests. And the more tests that we have usually means the more stable our code. I'll see you in the next one. Bye-bye. Hey, you're still around. That's good news. Now, many of you might be wondering, if I become a Python developer, what can I do with my career? And you know what? Python, I think, besides maybe JavaScript, offers some of the best opportunities for employment and options for different ways that you can go in your career. For example, you might want to become a software engineer. A software engineer is a person that builds software, builds programs and code to solve real-world problems. If you want to work for a company like Google, Amazon, Facebook, Netflix, you might apply to become a software engineer and use Python in your coding interviews to solve coding problems and get in those big companies. Or you might want to apply for a job that's a Python developer. That's a very generic term, but a Python developer is essentially somebody that solves problems that a company has with Python. So it can be many different things. Or maybe you're a research analyst. And I have a friend who has a PhD in microbiology. And he uses Python because he analyzes data that his lab gets with Python. Or you might want to be a data analyst. That is similar to research analyst. They use whatever data that a company has and analyzes it to make business decisions. Again, we can use Python to analyze these things. Or you might want to become a data scientist. You can think of a data scientist as a level up from a data analyst. They can do what most data analysts do, but they also have really strong mathematical, statistical, programming backgrounds in order to create algorithms and study data in order to create perhaps new models. Or there's even a backend developer or a web developer that works on building, for example, API services. You can use tools like Django and Flask, things we'll talk about in this course, to build web applications. Or you might want to do testing and automation. Testing and automation can be as simple as testing a website or a web app, or it can be testing a mobile application and writing scripts to simulate user behaviors and test that a company's product works. And of course, a really popular one right now is machine learning. Creating machine learning models from lots and lots of data to create these models that can predict or perhaps create something useful for a company. The options are almost endless, and it can be overwhelming if you're just starting out. Luckily for you, in this course, we're actually going to touch on each one of these topics. And in our over 10 projects that we're going to build, we're going to experience what each one of these roles might do. So that at the end of the course, if you find something that piques your interest, well, you can pursue it further. But this way, we get to dip our toes in each one of these careers and see what you might like, what you might find interesting. But the beauty is that by learning Python, it opens up a whole world of possibilities. Possibilities of a really good career because it is a very valuable skill. All right, I hope you're excited. You're down a good path. I'll see you in the next video. Bye-bye. What do I do if I don't have enough experience? What if I'm underqualified for a job? Well, first of all, you should have this mentality in mind when applying to jobs, and apply to jobs that you feel you are underqualified for. If a job is asking you to do something that you already feel confident, then you should ask yourself, what am I going to learn in this job? Am I going to learn actually? Is this job going to put things on my resume that will make me get better and get a better position in the future? Or am I just going to do the same thing that I already know what to do or how to do it? Finally, you have to keep in mind that job postings are put in order to weed out the weak candidates. I have seen way too many of these created by non-technical people or just making jobs sound tougher than it really is to remove junior developers or engineers from applying. So ask yourself, is this job going to be tough? Good. Then that is what you want. That's what you should be doing. Do you feel confident you are very qualified for this job? Okay, then maybe you should push yourself and apply to a job that's more difficult than you think. Every application should be a long shot. If you're applying to something that you're 100% qualified for, where is your room to grow? So dream big. But in order to dream big, you might have a bit of a roadblock. What if you don't have enough experience? See, I don't love resumes, and I don't think a lot of people do either. But sometimes without a resume, you cannot get an interview. And in order to have a good resume, you need to have something to put on it, like great experience. Here's the catch though. How can you have good experience if you're just getting started? It's like you have no hope if you're a beginner or if you don't have enough work experience because you're just out of school or you're changing careers. Well, not quite. As with everything, there's the regular way of doing things, then there's the smart way. You see, experience doesn't come just from working at another company. There are many ways that you can demonstrate experience without a past job. And here you'll find my favorite ways to show and prove you can get the job done. You won't have to do every single one of them, but 2 out of 4 of these, or even better, 3 out of 4, will be great at showcasing on your resume and make you stand out. So let's go in order and see how we can do this. The first one is GitHub. GitHub is a great way to demonstrate that you actually code, that you've built projects. The number one thing you can do is to start making commits and making sure that you have a good history of things that you've done. And by the way, if you're wondering how I got this cat picture in here, I'll show you a little trick in the next exercise to make your contribution look a little bit nicer and busier in case you're just getting started and you don't have a good past history. Another way to improve your GitHub profile or to just add more experience is contributing and participating in open source projects. For example, I've created a Zero to Mastery organization where we have a ton of open source projects by the community that you can contribute to. And they're made specifically for you to mess up, make mistakes. Nobody's going to yell at you. These are just fun projects that are open source that you can contribute to. And you can do as much or as little as you want, but this will improve your experience in contributing to open source projects, and it's something you can add to your resumes. Now, contributing to open source projects, recruiters love seeing this because this demonstrates that you can work with others and also with something like GitHub and version control. All right, let's look at the next one. The next one is website. If you're especially a full stack or a front-end developer or even a designer, you should have your own website where you can showcase your skills. This, again, is something you can speak about in your interview and about how you built the website, or it gives you a good way to talk about your past projects. Now, you're asking yourself, Andre, am I going to have to build a whole new website and waste a bunch of time? Well, not really. Let me show you a couple of tricks. You see, you don't need to build your own website from scratch. There's a ton of free templates like Creative Tim here that just gives you a nice template for you to use and fill in with your information. We can also look at this one, and again, free templates that you can use. I especially like the mountain template, and you can see that, you can customize this to your own and make it look professional, and it's already designed nicely and also customized for different experiences, such as mobile, tablet, and in a day you can have your own website. And just to show you how you shouldn't really spend too much time on your own website, one of my favorite people to follow is Kevin Kelly. He is very, very popular among the tech community, and he's just a overall really smart thinker. And you can see his website over here. It's very simple. Nothing exaggerated, very, very clean but small, very basic layout. And this is to show you that you don't need some crazy animations, make it all flashy to stand out. As long as you have a personal website, it just shows that you actually spend time building it and doing something that most people wouldn't do. Another thing that I want to show you is, for example, the job board that we have for all of my students. And this is, again, another open source project that the community built. If we just search through, let's say, Toronto developers here, and we go to Christine Aki, I hope I'm saying the last name right, you can see how simple yet beautiful her portfolio is. If we go to About Me, just a nice little bio with links to her profile. If we go to projects, we see some of their projects. And this is something that she can put on her resume and immediately stand out from the crowd. And it also gives her an opportunity to list projects that she can talk about when she gets to an interview. All right, let's look at the next topic. 1 to 2 big projects. Now, you can't really fake experience. If you've never built anything beyond a to-do list or a Hello World app, you simply will not be able to get very good jobs. However, most people think having 100 projects is the way to go. So they do a project a day and build small projects, many small, tiny projects to have 30 of them. And they start building all these projects that are very, very simple. Now, that's not actually impressive. I mean, it shows that you're working hard and coding along. But if I'm a recruiter and you show me a project of maybe tic-tac-toe, well, I don't really care. That's something that anybody can build with a bit of coding experience in a day or two. Frankly, no recruiter or interviewer is going to check out all your 30 projects. Most of the time, we want to hear your most difficult or the hardest, biggest project you've worked on. Instead of spending your time on these small little projects, spend your time on 1 or 2 big projects. For example, in other courses that I teach, we built a face recognition app. And this app, well, it has a front end using React.js, a back end where we have a RESTful API server with Express. We've deployed it to Heroku. We've created session management with authenticated routes. We store user information such as username and also hashed passwords securely in our database on Postgres. We've deployed our app with Docker, and we've also used Redis for session management and caching. Now, all of that may not mean a lot to you, but having something like a one big project that you can talk about all these things will make you sound a lot more impressive than somebody that just builds a ton of tiny projects. So focus on that. Have 1 to 2 big projects that you can show off, makes you stand out, and it's also going to give you something to talk about during the interview. And put it up on your website or create its own website, and you immediately can put this as the first item on your resume. Because here's the thing. If you don't have work experience, if we go back to the resume we used in the exercise, remember this resume? Well, if you had no work experience, maybe for work experience, you can say something like JavaScript developer or web application developer and talk about how you build your project here. Because to a recruiter, it doesn't really matter if you worked at a certain company building an application or on your own. Or that could be a little bit vague too. They don't need to know that. They just need to know that you built things that are real, that are big and complicated, and you solved hard problems. So having 1 or 2 big projects that you can list on your experiences is a great way to add to your resume if you don't have enough past work experience at companies. And I have a few students who have actually used this technique to get interviews, even though they just learned how to code 6 months ago. And then finally, we have the blog post or blog. Let's have a look at what I mean by that. This is another thing you can include in your resume, especially if it's related to a technology you're using or the company is using. For example, I have here my Medium profile. And Medium.com allows anybody around the world to just post a blog post. And it's very popular with the tech community, so there's a lot of tech-related posts that you can write on Medium. And there's other platforms like this. What if you wrote a blog post about a specific technology that the company you're applying for is using? Or some sort of a technical problem that they're facing? By doing that and just adding a link to that blog post, it gives you, again, another leg up to most people. And the great thing about platforms like this is that, well, if we go to one of my articles here, you can post it to what we call publishers. And publishers allow your post to be discovered by others. And it's very simple to do. You can write a blog post on Medium in a day and submit it to a place like Hacker Noon, and lots of people see it. And as soon as you show this to a recruiter or an interviewer, again, it automatically shows that You know what you're talking about, or at least it makes you stand out from the rest. And you can do this with YouTube videos as well, but I prefer writing because it's a lot faster and it looks a lot more professional. So let's just review here. What happens if you don't have enough experience? Well, all of these 4 points allow you to gain that experience or show that you have experience without actually having traditional work experience. All you need to do is start something on your own and build something like a project or a portfolio or a blog post. This only shows initiative, but you can focus this project on solely getting your interviews, or you can participate in a hackathon or contribute to open source projects. By taking this initiative, you're doing more than most people that hope to just land an interview by sending a generic resume. You'll immediately stand out from the crowd and give you something to put on your resume that, again, is different than the average developer. Plus, you have the added benefit of something to talk about in your actual interview. Remember, nothing is given to you for free. And luck is for those who rather wait than go after what they want. So by simply building something just for fun, such as a side project, you're showing how self-motivated and ambitious you are. Experience doesn't mean on-the-job experience. Write about your portfolio projects. Maybe talk about your website and how you built it. Talk about your GitHub profile, maybe a hackathon you participated in or open source projects you've worked on. Write a blog post on a specific technology that the company you're applying to is using. All of them answer this question: do you have experience? Finally, there are many things that you can add that are not developer related, but can make you a great employee. For example, did you work as an instructor at a camp? Well, you can now add ability to manage people and communicate well with others. Any skill that is related to getting the job done can be included. Also, if you have only had 6 months of coding experience, don't show that on the resume. That doesn't mean to lie, but to hide that information. Because a recruiter only glances at your resume. They won't care if you're the best developer in the world if they just see 6 months experience. That's too risky for them. Your resume will most likely be discarded no matter how good of a developer you are. So remember, resumes are only good to get your foot in the door. By tweaking your resume to show that you have experience so that the recruiters thinks, oh, interviewing this person is low risk because they know what they're talking about, is a good way of doing it. Do you have past experience? Have you made good decisions in the past? And have you worked on a challenging problem and solved them? If you're able to answer yes to that, well then, a recruiter is most likely going to ask you for an interview. I'll see you in the next video. Bye-bye. Hey there, surprised to see you there. So we just finished an entire section on Python. We learned the Python language. We learned the syntax, and we can write Python now. That's awesome. But here's the thing. Do you feel ready for the real world? Do you know what to do with this newfound skill? You see, when you're first learning a language, a really hard jump is to learn the syntax and the rules of the language, and then understanding how you can use that in the real world to make your life better, to improve a product, to create value for a company that you work for. And a lot of developers have this crossroads that they encounter once they learn their first language. And that is, what now? What projects do I build? How is this useful? Where can I use Python? If you've gotten this far in the course, this slide should make sense to you by now. Because if I asked you the question, where can you write Python code and have it work? The answer should be pretty obvious, right? Because if we have a Python file or multiple files, that is modules, and we have a Python interpreter or a compiler, then by having these two things, we can run them anywhere that has a machine, that has a computer. We can run it on our own computers, our own laptops, like we have been throughout the course. We can even run Python code on mobile Again, as long as we have an interpreter and some Python scripts, we can run those on mobile. And if you Google running Python on mobile, you'll see just how to do that. You can run Python on servers. And servers at the end of the day are just computers. So any computer, any machine that understands ones and zeros is able to run Python code as long as we have these two pieces. And this is where the power comes in. The power is that we now are able to use Python to do the tasks that as humans maybe we're not as good as machines. That is, automating things, doing things that are really repetitive, doing them really fast. That's why machines are so powerful. Maybe they're not as creative as humans. Maybe they can't speak or write fictional novels. But what they're really, really good at are calculations, simple tasks that they can do thousands, millions, billions of times in a matter of seconds, something that humans can't do. And we use Python to help us as humans to be more productive, to create things so that our machines run our Python code and make our lives easier. And throughout the next couple of sections, we're going to try and answer that for you. That is, we're going to show you where you can apply Python, whether it is to your day-to-day life, whether it is to work for a company, or maybe you want to create your own startup. We're going to show you how you can apply the knowledge that you've just gained into different projects, your own personal projects, for example. Because this is where Python shines. Python is one of the most popular programming languages because it can be applied to lots of things. How many things? Well, we can do web development. We can do image processing. We can send emails with Python. We can even send texts with Python. We can do machine learning with Python. We can create our own Twitter bots. We can do data visualization and data analysis. We can do something called data scraping. We can just do any general scripting with Python. We can do automation, and we can process files like PDFs, Excel files, and many others. And we're actually going to show you and build projects around all of these topics in the upcoming sections. I know, very exciting, seems kind of overwhelming. But the goal is, now that we have the foundation of Python, I want to show you where we can apply the skill so that by the end, we have all the tools necessary for you to dominate the world as a Python programmer and have this tool that you can utilize in anything that you want. It's a bold statement, but it's very exciting, and I think you're going to really like these next sections. Let's get started. Let's talk about scripting. But what do I really mean by scripting? This is just a general term to say that, well, we're writing scripts using Python to do something for us, to use the power of the machines to help us be more productive, more efficient. So this section is all about making our lives easier, understanding what the power of Python is, what we've learned up until now, and how we can use it to make our lives easier. We're going to learn about processing images really efficiently. We're going to learn about working with files like PDFs. We're going to learn how to send emails with Python, even text messages. We're going to build a Twitter bot. We're also going to build projects along the way to show you all the cool things we can do with Python. My favorite project that we're going to build is a super secure password checker to see if our passwords have ever been hacked. It's a really, really neat project. But the idea here is that with Python, using all these libraries and modules that have been built by the Python community, we can do so much. So it's going to be a really exciting section, and it's going to open up a whole world of possibilities. I'm only going to scratch the surface, but I guarantee you, by the end of it, you're going to be really, really excited and truly understand the power of Python. Let's get started. Let's talk about image processing. This is something that happens a lot, and a lot of companies process images or videos. What do I mean? Well, Instagram here, for example, you may have used this service. What you do is you upload your pictures and Instagram displays it to all your friends. But if I click on one of these pictures here, this image isn't actually the image that I uploaded to Instagram, because the image that I uploaded to Instagram was very large. It was probably around 5 megabytes. What Instagram does is it processes this image. Maybe it adds some cool filters for me to make it look nice, but it also crops this image and makes it small. So it's only a couple of hundred of kilobytes. Now, why would they do this? They do this because A, they make pictures look nicer, but also to save themselves a bit of money. If they uploaded all the pictures that they have from all their users, and each picture was a couple of megabytes, that's a lot of storage space for them to have to hold on to these pictures, because each of these pictures are on their servers. So they save a lot of money by compressing these images. The same thing happens on Udemy as well. You may have watched a course on something like Udemy and thought, man, these videos are a little bit blurry. I wish they were a little clearer. Well, Udemy does the same thing. They host all of these videos. And if they hosted the original version of the videos, such as the ones that I record, in the full format, well, that's going to cost them a lot of money. So they're able to save money by compressing these videos so that they're smaller versions, but also help out other students that maybe might watch these videos, then don't have a good internet connection to watch them in HD. So this is a very common problem. So we're going to learn all about that. Now, what are we going to use? The key thing is that internet is your friend. As a Python developer, you should be able to find these libraries by just doing a simple Google search, such as image processing Python. And we see over here a bunch of resources, like 10 Python image manipulation tools, or things like OpenCV, which we'll talk about. But I'll save you the hassle and tell you what we're going to use. We're going to use something called Pillow, which is a pretty standard library to use with Python when manipulating images. What we're going to do is actually install this Pillow library. And there's a couple of warnings here that we're going to get to in the next video. But ideally, all you're going to do is, well, you can just pip install Pillow. So let's do that. I have a folder here and a project that we're going to be working on, so ignore the right side here. But in here, all I'm going to do is say pip, and I want to make sure I'm using pip3. Again, this is something we've talked about. It's up to you. Make sure that we're using the latest version of pip. And then say install Pillow. And in my case, it's already installed. For you, it may take a little bit longer to install this package. Now, in the next video, I'm going to talk a little bit about this warning, which actually leads us to a key developer fundamental. So I'll see you in that one. Let's talk about a key developer fundamentals. We haven't seen one in a while, so I hope you're excited to see another one. What is it? This one is pick the right library. What do I mean by this? Well, let's have a look at what we just installed in the previous video. We installed this library called Pillow, which allows us to manipulate images using Python. But I also mentioned that there's a couple of warnings here. It says, hey, Pillow and Pill cannot coexist in the same environment. Before installing Pillow, please uninstall Pill. We also have some version warnings as well. So what does this mean? Well, if I go back to the main page over here, we see that Pillow is the friendly Pill fork by this person, and Pill is the Python image library. What does this all mean? When you pick a library that you want to use, and trust me, you're going to do a lot of that in your career, you want to make sure that you pick either the latest, most modern library, but also the library that the most people use. And we've mentioned this before when using PyPy, right? We want to make sure that the library we use has a lot of community support, It's constantly being updated so that there's no security issues, or it's not a library that's not very well, because anybody can publish a library. When you look at Python image library, which is the original one that we used to have, and this is a Wikipedia article that I can link to. And again, this is something that you'll just have to learn to develop, the skill of finding the right library. So in here, we actually see that Python image library, so originally it was called PIL. And this library existed and was very popular. But when Python 3 came out, PIL didn't support this newer version of Python. So essentially what happened was it was forked. And forked simply means it was essentially copied because it was an open source library and developed into Pillow by another developer, which gives us Python 3 support. So that's what it means. It's a PIL fork that allows us to have Python 3 support. The key here being that, again, we want to make sure that we use libraries that are up to date, that work with Python 3, but also libraries like Pillow here that have a lot of community support. If I go to GitHub here, we see that it has 6,400 stars. It's been forked 1,200 times. And it's also used by 150,000 developers. That's a pretty good sign. We also see that the latest commit happened this year, which is awesome. Again, developing that skill to pick the right library is a sign of an experienced developer. So there you go. Another developer fundamentals. Let's get back to building some projects in the next video. All right, enough talk. Let's process some images and use our Python knowledge. Now, you might be thinking that image processing is something that you can do on your machine using something like Photoshop, even using a simple editing software. But where this tool really shines is when we have to process hundreds, thousands of images. You can do things really, really fast with Python. So let's get started with this. I've actually attached to this lesson a Pokédex for you. And this Pokédex has all these cute little Pokemons. We have Bulbasaur, we have Charmander, we have Pikachu, we have Squirtle. It's great. They're all extremely cute. And by the way, a little bonus just for taking this course. No other course is going to teach you this. Get ready for it. You ready? Bulbasaur, original name in Japanese is Fushigi Dane. Charmander? Well, Charmander is Hitokage. And then Pikachu, well, Pikachu is just Pikachu. And then Squirtle is Zenigame. There you go. Free Japanese lesson bonus for this Python course. Yes, this is that good of a course. All right, let's get back to some serious stuff. We have these images. Let's see what we can do with them. I'm going to have an image.py file, so you can just create this on your own. And I'm using Sublime Text here in my command prompt, but you can use whatever you want. And what I'm about to show you is something that, remember, you can always reference in the official documentation. When learning a library, there's nothing better than the official documentation, right? And we see over here that the first thing we need to do is to actually import the module just like this. So let's go back here and say from pil import image. So now we can do something pretty exciting. The first thing we can do is say image equals image that we've imported and just simply say open. Now in here, we just give it a file path that we want to open. In our case, let's open up pikachu.jpg. So I'm going to say /, which means current directory. And remember, we're in the image playground directory. And I want to go inside of the Pokédex folder. So I'm going to say Pokédex and say /Pikachu. Make sure I spell Pikachu right here. .jpg. And let's just print the image here to see what we get. I'm going to save and run this file. So I'm going to say Python 3 and run the image.py file. Images .py file, because that's the name. There you go. We get an object here. You see it's a pill object. It's a JPEG image plugin, JPEG image file, and it tells me exactly what it is. So we've converted or opened up this JPEG into an image object that Pillow gives us that we can now manipulate. So what can we do here? Well, first let's just see the image.format. And this property is going to say, hey, what is image format? Image format, it's a JPEG because, well, it's a JPEG. That's awesome. So we get different properties here. What about size? Can you tell us about the size? Well, yep, the size of the image is 640 by 640. Awesome. That's good. We get some information. What if we do mode here? What does mode do? Let's see. We see that the coloring is in RGB. So that's red, green, blue. All right, awesome. Let's clear the console here. There you go. Now remember, we're able to figure out what kind of functions, methods, properties, and attributes this image has by doing the dir command, right? So if I just remove this and do dir over the image, we get, well, all the things that this image has given to us. And again, this is something that we can check on the documentation websites as well. Okay, but let's do something even more exciting. You know what I want to do? I want to be able to maybe add some filters, maybe blur things in here. Well, Pillow gives us this image filter that we can now filter the image with. So how can we use it? Well, we can now have a filtered image, and this filter image is going to equal the image that we've grabbed, and we're going to say dot filter, and in here, give it the image filter with some options. So here we can do different things. Let's do blur here. So capital blur. So now it's going to apply a filter of blurring. So let's see what happens if I do this. I'm going to, instead of printing, I'm actually going to say image dot save. And this is going to save the filtered image. So let's do filtered image dot save. And give it, let's call it blur, comma, and then the extension that we want to save it in. Let's just do PNG here. We'll change it to a PNG file. Like this, and if I run this, look at that. We have a new file, blur.png here. If I click on it, Pikachu is all blurred up. You can see the original image right here, and then the blurred image. How cool is that? So let's do that again. Let's do something else. Let's do maybe smooth, which is another filter that we can do. If I run this again, all right, we see that the image is now, well, you can't really tell, but it's smoother. That's a filter that usually works better with landscape images. We can also do something like sharpen. And again, you can read the documentation to see different filterings that we can do. But let's check this one out as well. We got the original and then the sharpened one. There you go, there's a bit of a notice. Pikachu is looking very, very sharp. Now, the reason that I've converted this into a PNG is because PNG supports these image filters. So you might get an error if you actually keep it as a JPEG. And you know what? While we're at it, let me show you another thing that we can do. So instead of this filter image, we can actually do something called convert. And this converts the image to different formats. So one of the formats that we can actually do is something called grayscale, which is with a capital L. So when I do convert like this image, and let's rename it to gray.png. If I run this, my gray.png, Pikachu is in black and white. So you can also convert images to different formats. So remember we had the RGB, red, green, blue format. there's different formats that you can convert images to, but this one looks pretty cool. We've just grayed out Pikachu. Now, this is just one picture that we've worked with. But the power, and what I'm going to show you in the upcoming videos, is how we can apply, let's say, a function like this to hundreds and thousands and millions of images if we want, and process them really fast. But for now, I think this is enough. You can experiment and try different converts and try different image filters on your own. And we're going to learn some more in the next video. Bye-bye. Let's learn a few more neat things that we can do with images. Now, here we learned that we're able to save images, we can convert them, we can add image filters to them, and we also learned that we can actually use the save method to give a new name to a file, and then also give it an extension with the second parameter. So we can convert from, let's say, a JPEG to a PNG file like this. Another neat thing that we can do is also actually do something called show. And this is just going to show us the image. Let me show you. Haha, get that pun? Let me show you. All right, there you go. We see that it's now opening up the file and showing me the grayed out black and white 1920s Pikachu. Awesome. We can also rotate our images. So I can say filtered image. And this image, I want to rotate. Let's say 90 degrees. And I'm actually going to move this above the save so that we can see the effects. If I run this and go to gray.png, and let's just assign this to a crooked variable. And this crooked variable, which stores the new image, is where we're going to save. So let's just, let's save that and run this. And if we now go to gray.png, look at that. We got a crooked Pikachu. And we can, again, do different things. Let's do 180. So we have upside down Pikachu. And there we go. We have upside down Pikachu. So that's great. We can rotate images. We can also resize the images. So let's just say resize here. And this is going to be called resize. And instead of rotate, what we'll say is resize. And we can say that this image, remember, it was 640 by 640. I'm going to resize it to 300 by 300. So a nice little thumbnail. If I run this, and you see that I get an error here. And what I actually should have done here is the resize accepts a tuple. So I have to add brackets around here. So if I run this again, let me clear and run this again. And we go to gray.png. Look at that. Pikachu is a lot smaller than he used to be. Pikachu is tiny now. So we got tiny, grayed out Pikachu. So that's great. I can resize images, which is really, really useful. Now, let's say I wanted to crop my Pikachu image. What can we do? Well, instead of me telling you, let's just find out. We can go to the documentation website and simply search for crop. And if we keep scrolling down, well, let's just do .crop to see if there's an actual function that we have. And let's go over here, and we see that we have a crop over here. So cutting, pasting, and merging images. Okay, so let me just zoom in so you can see it a little bit. We see exactly how it can work. We can just pick the pixel location of the four corners and crop an image. So let's just copy that and try it out. So we have the region. So let's just say region, or let's just remove this and crop the filtered image with the box like this. And if we save this region image and run our code, let's go to Pikachu, and look at that, just the face of Pikachu. He's so cute. All right. Let's pretend that I didn't make that voice. Let's keep going. So there we have it. We can even crop images. I mean, this is pretty basic stuff, but you see the power of image processing. Whatever you want to do, you're not going to know at the top of your head. Instead, you're going to go to the documentation and say, hey, I want to have a blurry grayed out image. How can I do that? Well, you just search the documentation page and learn the commands, and you write your file. And that's the key, right? You're not going to know at the top of your head the entire library. When the need arises, you just read the documentation. That's what good developers do. All right, we've learned a lot, but we still have a few more things to learn. So let's take a break, and I'll see you in the next one. Bye-bye. Welcome back. I have a new problem for you. I'm using a website here called unsplash.com. It's an awesome website where you can actually download for free really good images. Maybe you want to have a new background for your website, maybe a new background for your desktop. Anyway, I found this spaceman image and I've downloaded it, and I'll link to this image as well. Or you can pick whatever image you want from unsplash.com. And you'll see here that this image is 3.8 megabytes. It's massive. And maybe I want to bring it down in size. Maybe do a 400 by 400 thumbnail that I can use for my profile picture so people know that I'm an astronaut. How can we do that? Well, let's go back to our code. We have this astro.jpg image, and you can see over here I'm scrolling through it. It's absolutely massive. Okay. So let's make this smaller. I'm going to, instead of Pokédex, say I want to grab the astro.jpg image. And we don't want to do any of this, so I'm going to remove that. And first of all, let's just print what the image size is, just so we're clear. So I'm going to run this, and we see that, yep, it's a pretty big image. So all I'm going to do is say new image is going to be image.resize. And again, a tuple that says 400 by 400. And we've seen this before, right? So now if I save this, let's say new image.save, and I'll call it thumbnail.jpg. If I save this and run this, all right, look at that. We have a thumbnail.jpg. That's actually great. Look at that. It's tiny compared to the massive one we had. But one thing that I don't know if you can notice is that because the image did not have the same width and height, what happened was it is actually a little bit compressed. So it lost its aspect ratio. The image looks kind of squished in. So how can we fix that? And this is a common problem with images, right? If we make things smaller and smaller, or we change the aspect ratio, let's say 400 by 200. So if I save this and go to the image, well, yeah, look at that. The image is all squished up. How can we fix it? Well, in this case, we can actually use a useful thumbnail method. So instead of saying resize, if you want to keep the aspect ratio, we can say thumbnail. And this thumbnail will be 400 by 200. So if I save and run this again, we'll get an error. A non-type object has no attribute save. And that is because thumbnail actually doesn't return a new image, it just modifies the current one. So in here, we can just say image.thumbnail, and then we'll say image.save. So if I run this, and we go back to thumbnail, look at that. We have a thumbnail, but it keeps the aspect ratio. So even though I said 400 by 200, it's going to try and do its best to keep that aspect ratio and maybe not give the exact output that I want. So let's just bring it back to 400 by 400, run it again, and there you go. We have our thumbnail and the astronaut is not squished. Very, very useful. So the thumbnail one is really, really useful. Maybe if you want to create a profile picture for Facebook or Instagram or any other social media platform that you might have. And it just gives a tuple of width and height, and this is the maximum value. So it's never going to go over 400 and 400, but thumbnail is going to automatically do anything within the range up to 400, but keeping the aspect ratio. So if I actually do here print image.size and I run this, you'll see that that's exactly what happens. It's intelligently deciding what the best size for the image is. All right, let's take a break, and in the next video, we're going to do a fun little exercise. I'll see you in that one. Bye-bye. Welcome back. It's time to apply what we just learned and do an exercise and build our own project. Now, what is this project? This project is going to be a JPEG to PNG converter. You remember our Pokédex, right? Our Pokédex are all these cute little Pokemons, but they're all in JPEG format. Now, JPEG image file format, you can read up on it, but I prefer PNG. There's some benefits that PNG files have, especially for these type of images. So for example, if you're a web developer, these types of images with not a lot of color or just a few colors, you can see over here, blue, brown, white, they're actually better when you develop websites to use PNG. Again, that's beyond the scope of the course. You can read up on this on your own. But a JPEG to PNG converter is really, really useful. So how can we build it based on what we've learned? I'm going to get you started, and the rest I'm going to try and see if you can figure out on your own. So what I'm going to do first is create a new file in here. And I'm going to use the command line. I can use touch here because I'm using a Mac. If you're using Windows, this command is different. And that's something that we've already talked about before. You can also just manually on your computer, just say new file. So you can just right click and say new file, whatever you want. Well, I already did this, so instead of doing touch, I'll just create a new file. And what we'll call it is, I'm going to call it JPEG to PNG converter.py. There we go. Now, what do we want this to do? Well, we want a Python script that I can run that works like this. I want to be able to say Python 3 and then say JPEG to PNG converter.py and then give it 2 arguments. The first argument is I wanted to give the folder name. So I'm going to say Pokédex. And we're going to add a slash here to show that this is a folder. So I want you to open the Pokédex folder. And then the second parameter is the new folder that I want to create. So let's just call it new. So this new folder doesn't exist, but I want to be able to create it. And by the way, if you're on a Windows, this slash will be the other one. It'll be the backslash, like this. But essentially what I want to do is run this command. It's going to look through all the images here and convert them into a JPEG and put them in a new folder called new. So let's build that script. And I'm going to get you started with a little hint. What we need to do is we need to be able to grab these arguments and also grab all these files. And from the previous sections, we should know how to do that. What I'm going to do is import the sys module and import the os module. And of course, from the pillow library, I'm going to import pill from image. It's import here. There you go. Now, the first step is to actually, using the sys module, grab the first and second argument. So remember, that's the Pokédex and the new folder. So that's the first thing we want to do. The second thing is to, well, based on whether this exists or not, to check if new exists, or this folder exists, and if not, create it, right? So if this doesn't exist, we have to create the folder so we can put the images in. And then finally, what we want to do here, and this is the tough part, we want to loop through this entire folder. So loop through Pokédex, and then we want to convert images to PNG. And then finally, we want to save them to the new folder. This is a tough one. It combines a lot of the things that we've learned up until now. You might not get it right away because it is a little tricky, so don't worry. In the next video, I'm going to show you how to solve this problem. But what you might want to learn is how to Google, first of all, how to use sys to grab the first and second argument, how to use the OS module to grab the path so that you can say, hey, I want these files in Pokédex and I want to write to this new file. So we're going to use the OS module for that. And then obviously we're going to use the pillow module to convert the images to PNG, something that we've seen before. This exercise is going to require a bit of Googling on your case, which is a good skill to develop. So in the next video, I'm going to show you how to do this. I'll see you in that one. Good luck. Bye-bye. Welcome back. How was it? Was it tough? I hope you don't hate me for making it a little bit tough, but it's going to be a good thing. And remember, if you didn't get it right away, that's not a big deal. This is how we learn. So let's make this a little bit bigger. There you go. And start off with our first step, which is to grab these two arguments that we're going to have to use. So how can we do this? Well, first thing we're going to do is, let's say, path, which is the first path of our images. Or let's just call it image folder. And this image folder is going to use sys.argv, which is the arguments. And remember, the argv is, this is the first one, which is the Python file. This is the second, and this is the third. The way programming works, we start with 0, then 1, then 2. So all we're going to say is argv1 here. And then for the second one, which is the output folder, it's going to be sys.argv2. So I always like testing what we've done because we want to make sure that our assumptions are correct. So let's just print image folder and output folder. And let's just run this file. All right, look at that. We get Pokédex and new. It looks like this is working. Awesome. So we did the first task. What about the second one? The second one is to check if this new folder exists. If not, we need to create it so we can use it in here to put images. So again, this sounds like an if statement. So I'm going to say if, and then check if the folder exists. So the way we can do that is using the OS module. Now there's also the pathlib module that you can use. It's completely up to you. Now with the OS, what we can do is say os.path.exists. And this is just going to check, hey, does this exist? So I'm going to say output folder, does this exist? So let's just see what the output of this is. So before I even do the if statement, again, I like testing my code. So I'm going to say if OS path exists. Or sorry, instead of if, we want print. Let's run this. And we get false. Why is it false? Because it doesn't exist. So in order for our if statement to work, we actually have to do this. We have to say if not, because we want to get the opposite, right? So if this doesn't exist, then we want to convert this to true so that we can do something within this block, which is to create the folder. So how can we do that? Once again, we use the OS module, and we use the make dirs or make directory method, and we just give it the directory output folder. So again, let's test our code. And if I run this, look at that. We have the new folder. Awesome. And this way, if I run this code again, we see that we don't create another folder because, well, we're just checking this. And because this folder exists now, we're not going to duplicate and make another folder. Awesome. So step by step, we're making headway. And again, you may be asking yourself, hold on, Andre, I never learned about make dirs. How do I do that? And again, this is something that you just have to practice, where you look up what the module does and you Google around, and this is how you figure things out. Nobody has things memorized as a programmer. Don't hate me. I'm just helping you practice that muscle. All right, last part. Last part is to loop through the Pokédex, grab each image and convert it and save it to the new folder. So how can we do that? Well, we do a for loop, and we'll say file name in, and then again, we'll use the os.list directory. And this is going to be the items in the directory. So with list dir, what we can do is just give it the image folder. And in here, we now have each of these file paths. Now in here, I can say image equals image.open. And what should we do here? Because remember, we're going to open this every time, right? And this file, JPEG to PNG, is outside of these folders. So we somehow need to open these images at the Pokédex. But remember, we want to use whatever the input is, because folder Pokédex might not be always the same. So instead of grabbing the Pokédex folder, we'll just simply use an F string. And within this F string, I'm going to say we want the image folder, which is going to give us the Pokédex slash. And the slash here, because we assume that the user is going to enter the slash, we don't have to include it in here. And then give another string, which will be the file name, which we grab from here. So we now open these images, each one of them, and then we can just convert them, right? So let's convert them by saying image.save. And once again, we're going to use an F string and do the same thing, but this time for the output folder. So I'm going to say output folder, give it the file name, and then comma, and then convert it to PNG. And just for fun, let's just say print all done to let us know that every time an image gets processed, we print all done. Now, we're going to try and run this code. There's actually a bug in this code that we're going to have to fix, but let's just see what happens. So I'm going to run this. And there we go. We have all done, all done, all done, all done. 4 images. And it looks like it worked, right? Let's have a look. If I go to the new folder here, it looks like these are still in JPEGs. That's strange. Why would that be? I thought we should be converting these, right? Well, what if within here the save will do a .png? So again, let's make this a little bit smaller. So we'll say save as .png in file format PNG. If I run this, all right, look at that. We now have the images, but we have .jpeg.png. What's going on here? Well, we have to clean our name, right? So what we need to do is when we grab the image open, we need to remove the .jpeg from that image so we can save it as a PNG. So how can we do that? And that's something that you may have had to Google, because there's actually a useful tool that we can use with the OS module that allows us to do this. So what we can do is we can say clean name, and we'll say os.path.split text. And what this is going to do is it's going to split the text for us. So let me show you. I'm going to say file name. And in here, I'm not going to save anything. I'm going to comment this out. And I just want to print clean name. So let's just see what split text does. I'm going to clear this and run again. Oh, and I have an extra T in here. It should be split text. So let's save that again. And look at that. It gives me a tuple that splits the text between the name and the extension. That's extremely useful. So we just need to keep this first part, and we don't care about this part. So we can just access the clean name by saying 0. So the first item in the tuple. So now, if I go back to this, and instead of file name, we use the clean name to save the image, this should work. So let me remove some of the comments here. And another thing I want to do is I want to remove all these images because we don't need them anymore. We ideally have just PNG images. So I'm going to actually remove this new folder. So let's say delete. Okay, you can delete it. There you go. I'm going to save. And let's see if this works now. Let's run our command. All done. If we go back, hey, check that out. All our images are now PNG. And you saw how fast that was. We just created our first JPEG to PNG converter. This file can now convert, as long as you give it a folder with, you can give it hundreds of images, thousands of images of JPEG, and it's going to convert them to PNG. If you want, you can even resize them. You can even add image filters to them. And we're able to do that all with a few lines of code of Python and some useful libraries. Very, very cool. Now we're just scratching the surface here, but you're starting to see the power of Python. We have a problem, and this problem can be solved with Python and its libraries. And by just doing a bit of Googling, a little trial and error, and debugging our code, we just made something that could potentially save us a lot of time instead of doing this manually. Good job if you've gotten this far. This is our first image processing project. I hope you're excited. There's still lots more to cover, but give yourself a pat on the back, and I'll see you in the next video. Bye-bye. You've just learned about image processing. And image processing is similar to video processing. They're both essentially analyzing a frame of an image and doing something with that data. So where do you go from here? Well, we can use libraries like Pillow, which are really great for simple images, or you can use something like OpenCV. And OpenCV is a very powerful library. As a matter of fact, OpenCV is used with machine learning, like self-driving car. You can see over here, somebody built an OpenCV Python neural network autonomous RC car. Yes, what we learned, although is just scratching the surface, leads us to learn about autonomous driving and machine learning. Now, we have a section on machine learning in this course, so we're going to dive deeper into that. But with this newfound knowledge, you can even explore libraries like OpenCV if you're interested in this topic to learn how to analyze images and how to maybe use machine learning to do exciting things in the field of AI. This I'm leaving up to you to explore on your own. Again, the beauty with Python is that you can go in so many directions throughout your career. But for now, we still have lots more to learn, so I'll see you in the next one. Bye-bye. Let's talk about PDFs. How do we process them? I mean, we've learned about working with files in our previous section with Python. And you can imagine that we can work with any files. We've learned about image processing, but we've also learned that we can just manipulate any text file, any PDF file, any CSV or Excel file. These are all just file types that we can process and work with in Python. In this section, we're going to talk about PDF and how this might work. And this knowledge of PDF will transfer to different file formats. Now, we're going to talk about Excel files and CSV files later on in the course when we get into machine learning. But for now, let's work with PDFs and see how we can use Python to make our lives easier. Now, I'm going to link to some PDF files that we have here that we're going to use in this section. We have a simple dummy PDF file. We have another PDF file that actually has 2 pages. And then we have a watermark PDF, which we're going to save for our final project in this section. But let's go back here. From what we've learned so far, what do you think our first step is? Well, our first step is to find a library that we can use with Python to process PDF files. And get ready. For this section, I have a really impressive website. Probably the best website you've seen, probably the cleanest, most modern website when it comes to the package that we're installing. We're installing something called pip3 install pypdf2. Now, there's a lot of packages that we can install when it comes to PDFs. This is the one that I recommend for the course. Now, while this is installing, in my case, it's already installed. Let me show you what their website documentation looks like. Get ready. It's pretty. Here it is. Wow, right? I don't know why, but for some reason, Python documentation websites are not the prettiest. I mean, this is all subjective, right? Some people like this, but it just doesn't get you excited about working with PDFs. This website does it. Anyway, you can see over here that it's actually not that big of a library. And you can click on the documentation and again, read through everything. But let's just learn the basics. So the first thing I'm going to do is import pypdf2. And what we're going to do is work with the first one, the dummy.pdf, which is just this PDF file that is one single page that says dummy PDF file. Nothing too exciting. Now, how can we open this file? We know this from previous lessons, right? We can use the with open command and we'll say dummy.pdf. And I can say it like this because we're in the same folder. I have a pdf.py file that I've created. So I'm just saying, hey, grab the dummy PDF from the same directory. And in here, let's for now just do read because I want to read the file. And then just say as file. And for now, print file to see what we get. I'm going to run this file by saying python3 pdf.py. Let's see what happens. All right, I get a text IO wrapper, name, dummy PDF. All right, it looks like it's working. Let's just explore this a little bit more to see that it is indeed working. What we can do is actually use the pypdf to read the file. So let's do this. We can say reader equals pypdf and use the method PDF file reader. Again, it allows us to read this Python file. So let's just give it file in here. And then we'll just print reader and we can ask for a number of pages. Again, this comes with the library. So let's run this and see what happens. All right, we get an error. It says PDF read warning. PDF file reader stream file object is not in binary mode. What does that mean? Well, remember, binary is ones and zeros, right? If I click on dummies, dummy.pdf, this is not the PDF we thought. This is how a PDF should look, but you see, depending on the program that you're running, it might not be able to read the PDF file. So what we need to do, and this is just a standard that you have to remember, is that we want to read the binary. So it's read and then binary. So what happens here is that this creates a file stream object. So it's going to convert the file object to binary mode so that the PyPDF2 file reader can read this binary file object. So now if I run this again, look at that. It's able to read it and it tells me that this has 1 page. If I do 2page.pdf and run this, we get 2 pages. Awesome. Let's clear this and go back to our dummy.pdf. I feel bad for naming this PDF dummy. I shouldn't be mean to this PDF. I'll work on my naming conventions next time. So just like we saw in the image processing, with PyPDF, we can do a lot of things to process this image. For example, I can do get page here. And if I do get page, let's say the first page, and I run this, we get the page object over here. Now it looks like gibberish here because, well, this is a special object that PyPDF creates. But if I do something like page 1, which will be the page 2 in this case, I get an error, an index error, saying list index out of range because the dummy PDF only has 1 page. We can also do different things like, let's, for example, rotate this image, and we'll rotate it 180 degrees. If I run this, this doesn't work. Now, why is this? It's because PyPDF2 uses the reader object, but it needs to know what to rotate. In our case, we actually have to get the page of the reader to rotate it. So we have to do something like reader.getPage, get the first page of our dummy PDF, and assign this to the page variable. So that now that we have the page object, remember, a page object and a reader object. If I now run this, well, I get page object has no attribute rotate. And I may have tricked you a little bit to prove a point here. Now, this rotate object sounds like something that it should have, but it's actually not the right name that we want. So how can we solve this? And this gets back to us reading the documentation. If I go back to the file reader and let's search rotate, or let's go back here, we see that we have the page object class, which we have, right? We have the page object. If I click over here, let's find rotate. And we have a few things. We have merge rotate page. We keep going. And all right, we have rotate clockwise, rotate counterclockwise, and the angle. So it looks like this is what we need. We don't actually have a rotate method. But you see here, this is how we figure out what the library does. We also have scale to, scale by if we wanted to. So let's just copy rotate clockwise, or let's do rotate counterclockwise. And we'll just do 90. If I save this and run, all right, we get back an object here. But this object is actually in memory. If I go back to my dummy, nothing has changed because we haven't really saved anything. This is all in my computer's memory. When this program stops running, well, it gets trashed. So let's update our dummy.pdf to actually write and rotate counterclockwise. How can we do that? Well, with another with keyword. So inside of with open, we're going to say with open, and we'll call this, let's say, crooked. I don't know if this is how you spell crooked, so let's go with tilt.pdf. And we're going to open this file, and we're going to write to this file in binary format. And we're going to say as file. And in here, we're going to write the file to this new file. But how can we do this? This library gives us something called a writer object. So we can create a writer variable. And this writer variable will use the pyPDF.pdf. Instead of file reader, we have a file writer. And this allows us to write the object in memory so that now I can say writer.write. And just to make the naming convention appropriate, let's say this is going to be the new file. So we'll say new file. So let's see if this works. I'm going to clear and let's run this. All right, we have tilt.pdf. But we actually forgot to do one thing because we've just opened a writer object, but we're not actually writing any PDFs into it. Ideally, we get the rotated page and write inside of it, right? So what we can do is remove the print here. We've rotated the page. And with the writer object that we have now, we can say writer.addPage and give it the page that we've rotated. So now, if I run this one more time and go to tilt, well, again, we see gibberish here. But if we open this, look at that. Our PDF is rotated, just like that. Very, very cool. So that's great, but kind of useless, right? Who really rotates PDFs? That's really hard to read. But at least this shows you the ability for us to process PDFs. Let's work on something more exciting. In the next video, I want us to do something a little bit more useful than this. So let's take a break and I'll see you in the next one. Welcome back. It's time for us to do something more useful. And what I want to do is actually combine PDFs. So I have this dummy PDF, and then I also have this 2-page PDF. And maybe we have a scenario where we want to combine PDFs to form just one super PDF. How can we do that? Well, let's create a Python program. What I want to do is I want to be able to call Python 3PDF and then give it some arguments. Maybe to be able to say dummy.pdf and then combining it with 2page.pdf. And you know what? Let's combine tilt.pdf as well. And we can just keep adding and adding and adding different PDFs and combining them. Wouldn't that be cool? Well, let's do that. The first thing I'm going to do is import the sys module so that we can get the arguments. So I'm going to say inputs is going to equal sys.argv. And I'm going to do a little trick here. I'm going to say 1 and then colon. And remember, this is going to grab all the arguments besides the first one, which is our Python file. But it's going to grab all of these into a list called inputs. So we can include as many PDFs as we want. From here, let's create a function just to have our code be clean. So I'm going to remove this and call a function PDF combiner. And this PDF combiner is going to take a PDF list, which is going to be our inputs. And what should we do here? The first thing I want to do is just make sure my code works. So I'm going to do a for loop and say PDF in PDF list. And we're just going to print the PDF. So again, just to test our code, let's see if this works. I'm going to run this code. Well, and we have to call our function. So let's say PDF combiner and just give it the inputs. So I'm going to run this. And there we go, our 3 PDFs. That's great. But we want to actually combine these. So the way to do this is we actually have a merger object with pyPDF. So this merger object, we can say pyPDF dot PDF file merger. So that gives us a merger object. And the cool thing is that this is going to be really simple. All we have to do here is within our loop, say merger dot append PDF. So this just tells us, hey, merge everything into this merger object the PDFs that we're going to loop through. And at the end of the loop, this merger is going to have all these 3 PDFs. And all we need to do is say merger dot write, and just write the new PDF as, well, let's call it super.pdf. So let's see if this works. I'm going to run. And did you see that? We now have a super PDF. If I open this, all right, we have the dummy PDF, and we see over here we have 4 pages. We have dummy PDF, we have the simple PDF file that has 2 pages, and we have our rotated dummy PDF file. How cool is that? And notice here that we didn't have to even do the with open as file and then actually write. We can just use the merger.write method to write our file. So we have a PDF combiner. If we're working on a book, for example, and maybe we have different people working on different chapters, I can just run it through this function now and combine my entire PDF into one. Very, very cool. Or at least I think it's cool. I hope you find this interesting as well. But you know what? Let's go even higher. In the next video, I want to do something that's actually, I think, quite useful. So let's take a break and I'll see you in the next one. Welcome back. In this video, we're going to try a little exercise. And I actually want you to try this yourself. And in the next video, I'll show you the solution. Now, I've attached here a watermark PDF. You can see over here that it says draft, and it's just 1 page like this. Now, you'll find this in your resources, but I want to build a tool that's quite useful that watermarks all my files. So remember the super.pdf file we made in the last video that had 4 pages? Well, I want to watermark this, all of them. So instead of me doing manually, let's say we had thousands of pages. I want a program that can watermark my PDFs. Now, why would this be useful? Well, in Hollywood, this is actually a useful thing to be able to do. Let's say you're working on a TV show. Let's call it Lost. And you want to give the script, which is super secret because you don't want the audience to find out what happens in the show, to your cast members. And all these actors are going to get a draft of the script. But we don't want them to leak the script to the press so that everybody finds out about it, right? So usually big companies in Hollywood watermark their script with usually an actor's name. So if that actor leaks the script, well, they'll know that that person has their name on the script and they're the ones that leaked it. So this is actually a useful thing to know. So how can we do this? Well, this is your challenge, right? What we want to do is ideally use the water.pdf that I'll provide for you. I want to write this water.pdf on all the pages of super.pdf that we combined in the previous lesson. Or you can have your own PDF file. So using what we've learned up until now and the PyPDF2 library, let's see if we can give that a go. And in the next video, I'll show you how I did it. I'll see you in the next one. Bye-bye. All right, how was that? Hopefully you were able to figure it out. If not, don't worry, here's the solution. What I'm going to do here is just keep the PyPDF import and start from scratch. The first thing I want to do is I want to grab this super.pdf that we're going to process. So again, I'll just call it the template. And this template will be the PyPDF. We'll use the PDF file reader object. And I'll actually show you a little shortcut instead of just opening it the way we have been before. We can just inside of here say open and then say super.pdf, which is what we're going to open, and then open it with the second parameter being read binary. Just like this. We're going to create a file reader. Now you can do it this way or the way that I've shown you before. This is just a cleaner syntax that I like using. Next, I also want to open up the watermark PDF. So I'm going to call it watermark. And again, we're going to use the same thing. So I'm going to say file reader. And instead of opening the super PDF, I'll open the watermark PDF. And then finally, I want to be able to write my output and combine these two. So I'm going to say output equals, and we'll say py_pdf.pdf file writer to create our write object in memory. Now, from here, this is the tricky part. Ideally, we loop through the pages here of the template and add the watermark to it. Now, we are not going to know how many pages super.pdf has. I mean, we might want to change this program so that we use the command line here to give it a file. But ideally, we want to make a program that is flexible, and no matter how many pages the given PDF has, we can process it. So what I'm going to do is use a for loop here. And we can also create a function if we want. But for now, because this is going to be just one block of code, we can just keep it without a function. And I'm going to say for I in range, because we don't know how big this file is going to be. And what I'm going to say is template.get num pages. Get num pages is going to tell me how many pages the template has. Remember, we've also seen the way of saying num pages in a previous lesson. But we can just use get num pages, just to show you something different. So now it's going to get the number of pages, it's going to create a range object out of it, and we're going to loop through it. So if we have 5 pages, it's going to loop 5 times. Now in here, what we can do is have a page object. So we're going to say template get page at the index that we're at. So this is going to go through each time, and it's going to get the first page the first time around, the second page, the third page, the fourth page, so that we go through everything. And that's going to be our page object. Next, what we're going to do is say page.merge page. And this merge page is simply going to get the watermark.get page at index of 0. Because the watermark PDF only has that one page that has the watermark. So I'm going to merge onto that page the watermark. Now notice here that I didn't use the PDF file merger. And I'll show you why merge page works the way it does when we finish the project. But you can use either one. The key here with merge page is that I like the PDF file merger, which combines the files one after another. Merge page actually, merges the page like we want with the watermark. Now, this is something that you would have had to read through the documentation if you tried the exercise on your own. Again, one of those things that you just have to practice that muscle. Finally, now that we have the page, we can say output, which is the PDF writer that we're going to have. Our output will be the add page, and we're going to add this page that we've merged. And now finally, what we can do in here is say with open, and we'll call this new PDF, let's call it watermarked output.pdf. We're going to say write binary. And we're going to call it as file. So that now if we do output.write and write this file, let's see what happens. I'm going to run my program. And there you go. No errors. Let's see if it worked. We see that we have a watermarked output now. Again, this is gibberish, but if we open this, check that out. We have our dummy PDF file. We have the draft over here on the second page, third page, and even the fourth page with the rotation. How cool is that? We just created a PDF watermarker. That was quite simple, right? Again, if this is confusing and you're saying, hey, Andre, I didn't get this. Am I a bad programmer? No, you're not. This is very library specific, right? You're never going to get asked this exact syntax in an interview. Instead, you read the documentation. You want to merge pages. So you Google something like merge page on the official documentation of a library, and you figure out, hey, merge page is right here. I can read what merge page does, and we see, oh yeah, merges the content streams of two pages into one. All right, that's what we need. So that's what we use. And you experiment, go back and forth until you have a working project. There you have it. You can now work in Hollywood. Congratulations. I'll see you in the next video. Bye-bye. It's time for another project. And this time, we're going to use Python to send emails. That's right, we can send emails with Python. Now, we'll explore why this might be useful later on, but I want to give you a heads up. Python has a built-in email module. And this module actually got updated with Python 3.6, so I'm going to show you the latest version. When you Google how to send emails with Python, you might see a lot of outdated ways to send emails. So just a heads up that you might see something different than what I'm about to show you. But as of recording this video, this is the latest way to send emails. Okay, so why might this be useful? Well, imagine you have a list of emails that you've collected and you want to launch a new startup. You want people to know about your startup, right? So we can create a program that sends emails to maybe hundreds, thousands of people at the same time, maybe a customized email with their name to promote our product. Now, we'll get into spamming and things like that later on, but you might be thinking to yourself, why do we need Python for this? For example, there are tools like MailChimp. That is a software subscription-based product that allows us to do this. We can collect emails and also send customized emails. And you're right, companies like MailChimp or MailerLite, or there's hundreds of them, allow us to send lots of emails to potential customers, to sale leads, in order to try and grow our business. But I want to show you how to do it with Python, because there are times that it might come in useful. So let's get to it. And I'm going to use this project as an occasion for us to learn a few built-in packages in Python. Now, the first one we're going to use is the SMTP lib. So SMTP lib module. And we're also going to say from email.messages import email message. And this should be email message. Again, this is the email module that comes built in to Python. And actually, I'll link over here where it shows you some of the legacy API. So that is the outdated way to use things. We're going to do the emails.messages way of sending emails. Now, the other one is SMTP. Now, SMTP is going to allow us to create what we call an SMTP server. Anytime you send emails to anybody, it needs to have a server that communicates the language of the email. And this is what SMTP is used for. For example, on websites, you might see HTTP or HTTPS as the protocol of communication between a browser and a server. In the same way, emails have their own protocol for communicating, and that's through SMTP. As a matter of fact, the acronym stands for Simple Mail Transfer Protocol. It's a protocol or a standard for emails to be sent from computer to computer. Gmail uses this. Hotmail uses this. Pretty much most email clients. I'm going to link to some resource if you want to read more about SMTP. But the key thing is, if we want to send an email, we need SMTP server. Now, from here, we're going to dive into how to send our first email. Before we get into that, in the next video, I want you to go ahead and create an email account if you don't have one. I'm going to use a dummy email account, a Gmail account that I just created, because what we're going to do is we're going to have to log into this using a password, our username, and actually send an email from this email account without actually using this browser. So go ahead and create a dummy Gmail account, or you can use your regular one if you want, but I like to keep my passwords just away from everything, and I don't really want to share my personal email password with you, so I'm going to use this one. All right, let's take a break and send our first email in the next video. Let's send our first email. Now, this requires a lot of configuration that, again, you'll just have to get used to. So if it looks overwhelming, don't worry. Once you have this basic setup, you can send any type of email you want. So the first thing we're going to do is I'm going to say email is going to equal this email message that I just imported, this email message class. And this is going to be our email object. From here, we can add to this object the from key, which will be, hey, who's this email from? This email is going to be from myself, from Andre Nagwe. Next is, who is this email going to be to? Well, this email is going to be to, well, let's say Andre at 02mastery.io. So we want to send the email to this email address. And then the email subject line will say, what should we say? Let's create the worst spammy email possible. I think this will be funny. Let's say you won $1 million. There you go. That's a spammy subject line, that's for sure. So that's our subject. The next thing we're going to do is say email.setContent method, which essentially says what's the content of the email. In our case, let's just say I am a Python master. Now in here, we can actually set any type of content we want. We can do text, we can do HTML, we can do images. We're going to get to that a little bit later on. But for now, this is fine. There you go. That's our email object with the from, to, subject, and content. We have our email, but we need to send it, right? So what we need to do is to use this SMTP server to log in to our Gmail client and then send that email from there. So all we're going to do is say with smtplib.smtp, and in here, we're going to say what is going to be our SMTP server. And the reason I got you to create a Gmail account is just so you can follow along, because this is going to be custom to whatever email client you're using. In our case, we want our host to be Gmail. So I'm going to say smtp.gmail.com. This is going to be our host. And then this SMTP is going to be running on port 587. Again, you don't have to know this exactly. If we go back to SMTP, you see over here that typically submit outgoing email to the mail server on port 587. Remember, SMTP is a protocol. It's a standard for machines to communicate with each other. By using port 587, it's just a standard way for SMTP server to be run. Like I said, this is one of those things that you can usually just Google around and copy and paste because it's going to be the same. If you have a different client than Gmail, then again, you can Google and see what type of host you need. In our case, let's continue here. We're going to say with this host as SMTP because we're going to use this now. Let's make this a little bit bigger so you can see. And in here, this is the part that's going to look confusing, but again, it's just you do it once, and once you do it, you have an email server that you can use. I'm going to say smtp.ehlo. Kind of looks like hello, but it's not hello. This is actually part of the protocol of the SMTP, again, the agreement. It starts with a little hello message that, well, it's typed like this. You can actually Google why this method is like this and not actually says hello. It's actually a pretty funny story. So we have SMTP hello. So that's the initial, hey, this is a server, I'm awake, hello message. Next, we do the smtp.start TLS. And TLS is an encryption mechanism. So we want to connect securely to the server. And now this is the critical part. Up until this point, you might be confused as to what we're actually doing here. We're essentially, with this next line, we're going to connect to this email account, this Gmail account that I created, so that instead of me opening this page, hitting compose, and writing that email that we already wrote, I can do it from code. So what am I going to do? I'm going to say smtp.login, and I'm going to log in with my credentials. So the first one is going to be this dummy email that I created, which is 0tomastery1@gmail.com. And next is going to be the password that I used for this login. Again, this is something that, because I've created a dummy account, I don't mind sharing it with you. The password is hello ZTM, my old friend 1. So this way I'm able to log in to this server. And guess what we're doing next? Well, next we're going to say send message. And we're going to send, what are we going to send? This whole email that we've created. So let's do email. And just for fun at the end, we'll say print all good boss. There we go. Now, if we didn't make any errors, this should actually work. Let's give it a go. I'm going to say Python 3 and then run our email sender.py. I want to give you a warning here. If you've named your Py file email.py, this actually might give you an error. So make sure you name it something other than email.py. Let's give it a go. There's a bit of a pause, and we have all good boss. There was a pause here because we had to connect to our server, log in to our account, and then send the email, and then all good boss. So it looks like this code worked. So let's test it out. I logged into this dummy account, and I sent an email to andre@zerotomastery.io. Let's check that email account. And look at that. You won $1 million. I am a Python master from the email address of our dummy account. Now, I actually had to pull this out of the spam folder because it was marked as spam because, well, it definitely looks like spammy email. So that's awesome. We're just able to send an email through Python. How cool is that? In the next video, we're going to explore this a little bit more and make this a little bit more dynamic so we can customize it to each individual that we send email to. I'll see you in the next one. Bye-bye. Welcome back. We want to improve our program so that instead of just sending a generic email like this, I want to customize it to each individual. Imagine if we have a database of all these users, all their emails, as well as their first name. Ideally, we're able to customize the email to each specific person. So how can we do that? Well, we're going to use an HTML-based email. So we can send text emails, which just have text, like we've seen, or we can send something more dynamic, like HTML. Now, this isn't an HTML course, and it's something that we'll go into a little bit more in depth when we talk about web development. But in here, I have a very, very basic HTML document. And this HTML document just has a body where we want the content of our email to be. Now, in here, I wrote, "You just won so much money." And then with a $name. You can write whatever you want in here, but I want you to pay attention to the $, because we're going to do something neat here. We're going to actually update this to reflect a variable, a Python variable that we can substitute and customize dynamically. Now, how are we going to do that? Well, if we go back to our email, I want to introduce you to two new packages, built-in packages in Python that we can use. One is called the template or string template. So from the string module, we can import template. And what this template does, if we go to the documentation, right here, we have a string.template class. And what we're allowed to do is, as you can see here, using the $, we can substitute variables inside of text. You can see over here, if we zoom in a little bit, we have a template object with who likes what, and we can substitute these $, D with who. So who equals to Tim. We can do template who likes what equals to S, and then substitute who with Tim and what with Kang Pao. So this is going to be very, very useful. And this is what we're doing with index.html. We have a $name, and ideally we're able to update this. But we have a problem here. This is it's an HTML file. It's an index.html file. So how can we read this, convert it to a template, and substitute it? Well, we have another module that we're going to import. And this is going to be called pathlib from path. Import path. So this pathlib and this path that we import is actually very similar to something we've seen before, which is os.path. So we could have also imported the operating system OS module and used the path method, because what it allows us to do is to access this index.html file. So this is what it's going to look like. We can have an HTML variable that equals path and then give it index.html because we're in the same folder. And this path now gives us access to index.html, and we can use the read text method on it to read it as a text, as a string. Now, I'm going to leave a resource as to why we want to use pathlib instead of os.path, mainly because we have this read text method. But there's a great article here, why you should be using pathlib versus the OS path module, that I'll link to and you can read on your own. At the end of the day, though, both of these libraries will be useful, and there's no right or wrong, just pros and cons. So we have this string, but now we want to update so that the name variable will be something custom. So what we're going to do is wrap this in template. So it becomes a template object. That's it. So we have this HTML that is a template. And if you remember, once we have this template string, we can use the dot substitute to give it, well, what we want to substitute it with. So instead of setting content like this, instead, I'm going to change this and say, I want HTML dot substitute to equal name, which is, remember, the variable over here, to have it equal Let's go with Tintin. And by the way, this substitute can have multiple parameters. So we can do it with keyword arguments, or we can even do it as a dictionary like this. So we can say name will be Tintin, and then we can add multiple variables if this HTML file had multiple variables. Multiple, maybe name, age, maybe a greeting, whatever we want. So let's leave it like that. Let's save here and see if this works. I'm going to send once again. And this time around, I want to actually send it to my Gmail account. So we'll actually blur this out so you don't see my personal email address. All right. All good, boss. It looks like we didn't get any errors. Now let's check my Gmail account. Hey, look at that. Under important and unread, mind you, for you, you might get it in your spam folder. I have an email for myself saying, hey, I just won $1,000. Oh, and the last thing we need to do when we substitute is we have to tell it, hey, this set content is going to be HTML. So the way we do that is in the second parameter, we say this is going to be HTML. So it's not text like it was before. It's going to be HTML, so parse it accordingly and set content accordingly. So if I save this and we run, looks like we didn't get any errors. That's good. And if we go back to the Gmail client, hey, looks like I have a message that I've won $1 million. That's really great. Mind you, for yourself, you might find this in your spam folder. So again, make sure you check your email. Otherwise, if I click on this, look at that. You just won so much money, Tintin. How cool is that? So just like that, we're able to programmatically send emails, customized emails. Now, there's many applications of this. Maybe anytime a customer buys a product from your company, you want to send them a personal email, a greeting, saying, hey, thanks for buying our product. Or maybe you want to get yourself a reminder where every morning you send yourself an email saying, hey, get up and tidy your bed. There are so many applications. This is the cool part about Python, right? You can do anything you want. The world is your oyster. So hopefully this was exciting because we have a lot more in the next video. Bye-bye. Hello! I'm super excited because this is my favorite project of the entire course. As a matter of fact, I wish I could just do this over and over. I'm telling you, this project is going to wow you. Now, it's one of these projects that initially it doesn't sound that exciting, but I've included it in our course because I guarantee you, you talk about this project to an employer and they're going to be impressed with your knowledge. It's an actual tool that I use day to day for security reasons. And I'm really excited for us to build this together. By the end of it, I promise you, you're going to be extremely happy with it. Okay, maybe I'm a little bit overly excited about this kind of stuff, but hey, who knows? Maybe you will too. What we're going to build is a password checker. But not just any silly, dumb password checker. This is legitimately going to be the most secure way for you to check if your password has ever been hacked. That's right. So what's going to happen is we're going to be able to type in our terminal Python 3, and then we'll have a check my pass.py file that we're going to write from scratch. And in here, when we run this program, we're going to be able to input any password that we have and check if it's ever been hacked. Now, we'll get into how this works and how we know a password has been hacked in the next video. But just to show you how this works, if I say, let's say hello as a password, let's say if hello has ever been hacked, maybe password 123, and then a super tough password like this. So it's going to be able to check as many passwords as we list here. And if I hit enter, it's actually going to check these passwords. And we can see that hello was actually found, what is this? 253,581 times. So it's been hacked that many times. So you definitely shouldn't use this password. Password 123, as we can guess, yeah, you shouldn't use that password. What about this one, this gibberish password? This password has actually never been found. So you should carry on and use this password. Over the next couple of videos, we're going to build this tool, a tool that you can actually use in real life to check if your password is secure. Now, how does this work? Let's explore that in the next video. Welcome back. How are we going to build this tool? How are we going to know what passwords have been hacked? And what does it really mean anyway? Well, passwords get leaked all the time. We've heard about data breaches, right? Facebook has been hacked with data breaches. Equifax, LinkedIn, Yahoo, all these big companies sometimes get their databases leaked. And essentially what happens sometimes is our usernames and passwords get leaked to the public. And hackers, what they do is they compile these lists of leaked usernames and passwords and essentially try to log into different services. So there are databases, or you can think of them as massive Excel files, of all emails and passwords that have ever been leaked throughout history. And there's actually a website created by somebody called Troy Hunt, who's a very famous security researcher. And it's called Have I Been Pawned? And what you can do here is you can actually enter your email address and say, let's go andy@gmail.com. Has this ever been leaked? Oh no, it looks like it's been pawned. So it looks like it's been pawned on 88 breached sites and found 27 pastes. What this means essentially is that this email has been part of a data breach. So maybe I used this email as my Facebook login. Well, when Facebook got hacked and some users maybe stole user information, well, this email was part of it. As a matter of fact, for 88 breaches. And if I go to passwords here, you can actually do the same thing about passwords. I can check my password, and you can see over here that it doesn't show, and I can click over here to see if it's been pawned. Now, I just entered some gibberish here, and it looks like, nope, no pawnage found. But why does this matter? Why do we care that emails and passwords have been leaked? Hackers use something called dictionary attacks. And a dictionary attack, well, kind of like a Python dictionary, uses a massive dictionary with the key and value of, let's say, a username and password, and just tries to log into websites using these massive lists of information. And if your username and password has ever been leaked, well, a hacker simply runs what's called a brute force attack, where it just loops through all these leaked usernames and passwords and tries to log in. So maybe going into Facebook and just looping through this massive list, eventually they're going to hit something and be able to log in. Now, here's the thing. This isn't a web development course. I mean, this course is about Python. And although we have a section on web development, what I can tell you is that most of the time, even though I trust this website, it uses something called HTTPS, which is encrypted, I or you should never really trust a website with your password. Yes, maybe a big website like Facebook, maybe Google, we trust. But ideally, you don't want to send your password like this over the internet. Because what's happening here, as soon as I click this, is that it's being transferred to a server somewhere in the world. It's traveling through the internet wires, and somebody could intercept it. So there's actually a more secure way of doing this. And this is where we're going to build. This website actually gives us a password API for us to do this and check our passwords, but in a more secured way. Because sure, we might trust this website, but the best security is to trust no one, right? Now, what I'm about to show you and what we're going to do is actually a technique used by legitimate password managers like Keeper, 1Password, you might have heard of, Blur, Sticky Password. These are expensive password managers that keep your passwords secure, but we're going to build that ourselves because we're programmers. So in the next video, we're actually going to start coding a bit and learning about this passwords API. I'll see you in the next one. Bye-bye. All right, let's get to our first step of building our secure password checker. Now in here, I have a checkmypass.py file. You can do the same, and then I have my terminal right over here. What we want to do is initially import the requests module. If you haven't, well, then you can install the requests module. The request module is going to allow us to make a request. So remember, it's kind of like having a browser without, well, the actual browser. We can just manually request something as if we have a browser and we get some data back. So the way we can actually use the request module with the password API is that we can have the password API URL, which I'll just tell you what it is. It's https://api.pwnedpasswords.com. And then we give it a range / and in here, this is where we give it the password. So we can just do plus, and let's just for now do password 123. So that's the URL that we're going to use. Let's make this a little bit smaller, like that. Now in here, we're going to get a response by doing the requests.get, and let's just type this in and see what happens. If I save and run this program, and remember, we don't have the ability to type in the passwords yet, so let's just run the file. All right, so we get something, but it looks like an error. And that's because I did HTTPS. Silly me. But again, I want to show you that, yeah, right here, I'm able to read the errors, and it looks like it's an invalid schema, no connection adapter for, well, HTTPS. So if we run that again, all right, it looks like it worked, no errors, but let's print this out to see what we get. So print response, and I'm going to run this, and we got response 400. Now, a response or 400 is not good. Usually that means unauthorized or something's not right with the API. Now, these response codes are something we'll get into in the web development section of the course, but it just means that 400 is not good. We want a response of 200. 200 means okay. And the reason this happens is because this is not how the API actually works. You see here, we just gave it a password. But the way that this API works is it uses something called hashing. Now, what does that mean? I'm going to include a bonus lesson after this one so that you can learn a little bit more about hashing. But I have here this website that I'm going to link to, and let's make this a little bit bigger. Hopefully you can see. It's a SHA-1 hash generator. Now, hashing a password is something that you should always do. Let's say you're saving a user's password to a database. You should never store a user's password in what we call plain text. That is exactly what the password is. Instead, we want to do something called hash it. That is, run it through a hashing algorithm to make it gibberish. So when I do password 123 here and I click generate and I scroll down, this is the hashed password. Notice here that as I change this password, this changes as well. But the key here, and this is something that we'll talk about in that bonus video, is that hashing is a one-way function. So there's many different hashing algorithms. There's MD5s, there's SHA-256. We're using SHA-1 because this is what this API is using. And SHA-1 essentially just hashes. It's an algorithm that is a function that does this gibberish output of password 123. But no matter how many times we generate password 123, it's always going to be the same hash. So this way we can actually check if somebody types a password and we already have the hashed version of a password in, let's say, a database, we can actually compare the hashed version of this password to the database hashed password. Again, don't get too confused here. Hopefully in that bonus video, we'll cover this a little bit more. But the key thing is that this API, because we want to be as secure as possible, is, well, we don't want to send over the wire our real password. Instead, we want to send this hashed version of our password. So if I copy this and put it over here, this is what we should be sending to the API. But here's the problem. This is still not super secure because anybody can come now and type in and keep guessing, and eventually hit on password 123 and see, oh, this hash is the exact same one as this hash. So they will know that this is our password. So this API uses a technique called k-anonymity. And this is actually a modern technique that big companies like Google, Facebook, Netflix, Amazon all use. K-anonymity allows somebody to receive information about us, yet still not know who we are. How does this work? By the way, this is actually a technique that is used a lot, especially now where using personal data for companies, it's frowned upon. So ideally, you don't want to give your personal information to companies. So some companies that care about security and privacy use this k-anonymity to track you, but still not know who you are. Now, the way this works is that we only give the first 5 characters of our hash password. So 1, 2, 3, 4, 5. So if I remove this, what this API is going to do is it has a list of all the passwords that have been leaked. However, all these passwords are hashed with the SHA-1 algorithm. So it's going to look in its database of all these passwords and pick all the hashed passwords that have the first 5 characters that match this. So this way, with a response, we're going to get all the passwords that are hashed that have this. So that on our end, when we receive that response, we can check the rest of the hash function. This way, this API is never going to know our full hash, and therefore never ever be able to guess our password. They'll just know that we have this tiny bit of a hash function that could match any hundreds of passwords. How cool is that? So if I actually save this and run, I get a response of 200. Awesome. All right, let's take a break, learn a little bit more about hashing, and see you in the next video. Bye-bye. What is a hash function? It's something that's used all across computer science. A hash function is simply a function that generates a value of fixed length for each input that it gets. All right, what does that mean? Well, I have here a MD5 hash generator. MD5 is the type of hash function, and there's many types. You might have heard of SHA-1, SHA-256, and many others. Using this hash function, let's see what happens if I do hello. You see that right away, MD5 hashes this string and turns it into this gibberish. That's what a hash function does. We give it an input, and the function generates some random pattern. Now, there's some key aspects of hash functions. First is that it's one way, in the sense that if I give somebody this, they have no idea what the input was. And it's practically impossible for me to have any clue as to what the input is. The second is that no matter how many times I put hello in there, it's going to be the same. But as soon as I change one thing, it's going to completely change the output. If I go back to hello and watch me just change to capital H, even a capital letter. So it starts with 5D4. If I do capital H, it's completely different again. And looking at this, we can at least say that, I don't know what this is useful for, but the one thing that I know is that no matter what, if I give it the same input, it's going to give me the same result, but I have no idea how to convert this back into hello. This is what we call idempotent or idempotent. There's different pronunciations. I'm not really sure which one's which, but it is a fancy way of saying that a function, given an input, always outputs the same output. Now, the one benefit and why we would want to use this in a data structure is that we get really fast data access. Because all I have to do to find grapes, or basket.grapes, is to pass grapes into something like an MD5 hash. It generates this number for me, and I immediately know where it is in my memory on our computer. But this doesn't look like an address, does it? Technically, a hash function that we use for hash tables is going to take grapes, generate some sort of gibberish, and then convert it to an index space or an address space that it has based on this number. You see, unlike arrays where we just had ordered indexes, with hash tables, all we need to do is give it a key and we know exactly where that item is in our memory. But you might be wondering, this black box hash function, doesn't it slow things down? Because every time we want to add a property and a value, grapes and 10,000, to a hash table, we have to run it through the hash function so we can decide where to put it in memory. And if you've noticed that, good job. That is a big factor. You don't want this to take a very long time because, well, every time you add a property to memory or retrieve a property to memory, because again, both times we're sending the key grapes into the hash function to find where to get it from. We need this to be really, really fast. And underneath the hood, remember, because hash tables exist in all languages, they're implemented with an optimum hashing function that's really, really fast. As a side note, hash functions like SHA-256 take a really long time to generate a hash. And it is an overly complex hashing function that is used a lot in places like cryptography, where you want this to take longer, but that is outside the scope of this course. If you're interested, I do recommend that you check out the differences between these two. To review, we have a key that is grapes. We send it through a hash function that is going to hash something really, really fast and then map whatever the hash came out to be into a memory address where we want to store our data, our grapes 10,000. And when it comes to hashing functions, you typically leave this to whatever framework or language you're using. And we usually assume a time complexity or big O notation of O1 because this happens really fast. All right, now that we understand what this black box does, let's talk a little bit more about hash tables, why they're useful, and why, in some cases, are better than arrays. Welcome back. We just learned about the password API and how this API allows us to trust no one. That is, we only trust ourselves, and we're only going to give the bits of information that we feel comfortable to the API so that it gives us a response with some data that we can then calculate on our own machines that are hypothetically more secure. So what we did here is that instead of giving the entire hash of our password, we just give a little bit of it, the first 5 characters. Now, they have close to 600 million passwords in their database. And the website now maybe just knows that we're part of several hundred people that have a similar starting hash, but they're never going to know our password. But with this response data, we can now check our full hash to see if the password has ever been pwned or has ever been hacked. So let's start writing our program. Because ideally, in this response, I now have maybe several hundred lists of these hashes that I can check against. Let's think about what we want to do. So ideally, we have, let's say, a function. And this function will be the request API data, which is what we've done here. So we'll move that down here once we're ready. And here, we'll give it the query characters. So that is, we're going to give it this hashed version of our password. So this is going to be a function that for now we'll just pass, but this is going to request our data and give us a response. Next, with this response, we actually want to check. So we can say that we want to check the pwned API check, and in here we'll give our password. That is our actual password. In our case, it'll be password123. And in here, we want to do some sort of a check. We want to say check password if it exists in API response from up here. So for now, we'll just pass that. So let's work on the first one. That is request API data. We've already done some of this over here, right? I'm actually going to move this code up here. Make sure we have the padding. Now in here, instead of this string, I'll actually give the query character that we'll call the function with so that it's dynamic. And again, we'll request a URL, we'll have the response, and in here we'll do a check. We'll say if response.status, because remember, we can check our response. If the status is 200, or in this case, let's say if the status is not equal to 200, in that case, let's just raise an error. So I'll say raise, we'll do a runtime error, and we'll say, well, let's use an F string, and we'll say error fetching, and then we'll give it the status code. So that is response.status. Oh, and actually this is status code. So let's just do status code here. And then we'll just say check the API and try again. All right, so this should be our error if we make a mistake. Let's just test that out. I'm going to just, let's do an API that doesn't exist. So I just written some gibberish here. If I save and run this, well, I have to actually run this piece of code. So let's just do request API data, and the query character is going to be 123. And you know what? This is going to error out whether I do that or not. So let's just do this because it's not the hash version. And I actually get a Python error of type error. Can only concatenate string, not int. So we can just convert this to a string because remember, we're adding it to the URL here. Again, if we run this, all right, look at that. We've raised a runtime error. We have a runtime error, error fetching 400. Check the API and try again. All right, so this part is working. But in this case, if we don't have that error, let's just say that we will return the response. Again, we're just writing small, simple functions. In this case, we just want to request API data. So now we can use it throughout our code. Awesome. Now, this next part is a little tricky because we have to run our password through the SHA-1 algorithm. Luckily, Python has a built-in module for us to do this. So we can actually do import hash lib. As you can see, it's a built-in module. So you can read up more on it if you want. In our case, we're able to do SHA-1 hashing like we did on that website with this library. In here, what we're going to do is, first of all, I want to be able to hash my password. So let's remove the pass here and say SHA-1 password. And we can use the hash lib like this, hashlib.sha1, which is the hashing algorithm we want to use. And this is going to be a little tricky, but you can just read the documentation. I'll just show you how to do it. In our case, we can do password, and we want to encode in UTF-8, which is pretty standard. Actually, you know what? Let me show you what this does. So I'm going to say print, and I'll just do password encode UTF-8. So let's just do that for now. For now, I'm going to comment that out. So I'm going to call pwned API check, and we'll do 1, 2, 3. Let's clear this. I'm going to save and run this piece of code. All right, it's encoded. You see this little B over here in UTF-8. I'll actually show you what happens when we remove the encode after this. Next, when we use the hash lib SHA-1, so let me just copy this. If I just run this, I get a SHA-1 hash object. Now, after this, we can call .hex digest, like so. And if I run this, well, how can we check this? Well, we can go to hashlib and just simply search for hex digest. So in here, at any point, you can ask it for the digest of the concatenation of the data, blah, 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 hex digest. So that doesn't really explain anything for us. Let's just go to the next part and the next part, and there you go, hex digest. It returns a string object of double length containing only hexadecimal digits. This is just something that we need to do in order to convert this object into this hexadecimal string. The next part, in order to agree with the API, is to convert all of this to uppercase. So if I do upper here, and I save and run this again, everything is in uppercase, just like we saw when we looked at SHA-1. So this is just something that, again, you don't really need to know. You just have to, you can Google around and see how to actually use this. Now, let me show you what happens when we don't use UTF-8 encode. So if I just do it like this, and I run this, you see that I get an error. The Unicode objects must be encoded before hashing. So it actually gives you a nice error, and we can just encode it using UTF-8 like that. So this is just the standard. Again, nothing too crazy. You can read up on encoding and UTF-8 if you want on your own. The key here is that by the end of it, we have a SHA-1 password that we can send. So let me just copy all of this. Going to remove the print. And in here, we'll have our SHA-1 password. Awesome. So for now, let's just return this SHA-1 password. And if I run this, well, looks like our code is working. We're not printing anything, but hopefully we are getting this SHA-1 password. Now in the next video, I actually want to try and send this to our API and see what kind of response we get. Let's do that. Take a break. I'll see you in the next one. Welcome back. Let's continue building our awesome tool. We have our pwned API check that only converts our password to SHA-1. But we need to send this to the API, the password API. So what can we do here? The first thing we want to do is remember we only need the first 5 characters of our password, or the hashed password. So we can do something fun here. We can say first 5 characters, and also have what we call the tail. So we're going to store the first 5 characters in the first variable, and in the second variable, we're going to store the remaining, because we're going to need both of these later on. So in here, we can just use the nifty little thing that, well, Python allows us, which is this nice little syntax to just grab the start up to the 5th character, and then for the second part, the remaining characters. So starting from the 5th index all the way till the end. Nice and easy. And this is something that we've learned about before. So now we have the first 5 characters and the tail. And here we can now add this to our request API data. So I can now call my request API data, and in here give it, well, the first 5 characters. And let's just store the response in here, like so. Now let's see what type of response we get. So I'm actually going to return response here. And just so we make sure that we're doing everything right, let's print out the first 5 characters and the tail as well to make sure that everything is working. If I run this, right, it looks like I'm getting the first 5 characters. There's a space here and then the remaining, and we don't get any error. It looks like the response is working. So let's also print the response. And make sure that that is working as well. Looks like we get a response of 200, but we're still not sure exactly what type of data we receive. What can we do here? Well, I want to learn more about this data that we return. So let's create another function here. And for now, we'll just call it read response. And we're going to just give it the response that we get. And in here, let's just try to read this response. We can actually do print response.text here, because it's an API response, so ideally we can just read the text. Let's see if that does anything. So this return response will just have read response, like so. If I run this, hey, look at that. This is our response. As you can see, it's a ton of hashed passwords. There's a lot of them. It looks like a couple of hundred. So this is what we get from our response. By using response.text, we get all the hashes that match the beginning of our hashed password. Very cool. What we can actually do, you see over here how we get 24, 3, 1, and so on. This shows you actually how many times these passwords have been hacked. That's pretty cool. So ideally, we're able to grab the count, see if any of it matches with our tail, because now we can just check the tail and also print out the count. So instead of having a read response function, let's have a get password leaks count function that receives the hashes or the response and the actual hash to check, which is our own password hash that we need to check against. So we're going to check this hash to check and loop through all the hashes. So we can do something, again, nifty with Python here. We can say hashes equals, and we can use a tuple here. And we can actually do a tuple comprehension, which we've seen before. I can say line.split. So we're going to split everything in the line, which is by these columns over here that you can see. So that's the tail of the hash and the number of times it's been hacked. So we're going to split it by the colon. And then we're going to loop and say for line, so that's where the line comes from, for line in hashes dot text. Now, if I leave it like this actually won't work. And I'll show you why in a second. Actually, let's just do that now. So let's see what print hashes will give us. Instead of read response, we'll run this one now. So get password leaks count. And if I run, let's clear this. I get an error. Well, I get an error because we have to add the hash to check as well. So what should the hash to check be? Well, it's the tail, right? The tail of our actual password. So I'm going to add the tail to the second parameter, save and run again. All right, I get a response 200 and I get a generator object. This generator object we can actually loop through, right? So let's see what happens. If I do for, remember we have the hash and the count. So let's do hash, H for hash, and count in hashes. Because remember, we've converted to a tuple that has the hash and then the count. Because we're splitting, remember. So if we do this, let's just print H and count. If I run this, I get an error, value error. Not enough values to unpack. Expected to got 1. Why is that? Let's just print H and see what happens. And remove count for now. Let's clear this and run this again. It looks like we didn't split properly. Every item is its own list. So we actually have to use something called split lines here on our string. And as you can see, it returns a list of the lines in the string. And it breaks at the line boundaries. So when we actually do a for loop over the hash text, if we scroll up, let's see if we can see it. Nope, it's not there anymore. But if we scroll up, we just got a massive list of text. Ideally, on each line, we split this so that this line is, well, instead of each individual element, the actual hash and count. So we just need to do dot split lines, like this. If I save this and run once again, that's a lot better. So now we have what we want. We can once again go back to what we had before, which is count. And if we print H and count, let's save, run this again, and that's a lot better. We have each item separated. Let's take a break and continue this in the next video. We're getting so close I can almost see the finish line, so hang in there. We now have the hash and the count. So we can finalize this function of get password leaks count. In here, as we're looping through each item, what do we want to check? Well, we want to check that if the hash, that is the tail of the hash here, is equal to hash to check. Remember, hash to check is the tail end of our hashed password that we never send to anybody. That is on our own machine, so it's nice and secure. And we're going to check this because the API returned us a list of these tailed hashes. So if that matches, well, in that case, I want you to return the count. So I want to return how many times this password has been leaked. Otherwise, just return 0. Again, I can do this because it's going to exit out of this loop whenever it sees the return keyword. Now, in my pwned API check, I'm going to run this function, which in tail is going to grab all this information and return the count of the times that the hashed password has been leaked. So we have one last thing to do. That is the ability to actually print out the result of all these calculations. So let's remove this for now and create a main function. And this main function is going to receive the arguments that we give it right in here in our command line. So we're going to import, as you might have seen before, the sys module. And in here, we're going to have a main function that receives the arguments, which is the passwords that we want to check. And for now, we'll just pass here. But at the bottom, we're going to call the main function with the sys.argv and accept any number of arguments after we do the Python 3, check my pass.py, and then we give it all the arguments that we want, which are the passwords. So we're going to run the function like this. This main function, all it's going to do is we're going to say for password in the arguments, because we can give it multiple passwords. We're going to loop through that, and we're going to have a SHA-1 and a count, or we'll just do the count because we're going to receive the count from the get password leaks count. So we can do that by just doing pwned API check, and we'll pass it the password that we're checking. And all we're going to do is actually inside of this block say if count exists. In that case, I want you to print an f string, and this f string is going to say the password that we're looping through was found, the count of how many times, and then we'll say you should probably change your password. Otherwise, if that means there's no count, that is, there were no matches, then you're all good. We can say f-string password was not found. Carry on. So that's a good password. You should carry on. You're all good. And then finally, just for fun, let's return out of this function, return done. Just like that. If I save this, let's see what this gives us. I'm going to say Python 3, check my pass, and let's just check hello. I get hello was not found. Carry on. But we know that hello was found before, right? I mean, that's a simple password. We should actually get something good here. Now, I also want to remove this response of print since we don't need it anymore. Can you spot the error? Again, this is a bit of a tricky part with Python, right? It's the indentation and something that we've seen before. So you want to get good at debugging your own code and figuring out what happens. In this case, we can go step by step through the code, but we can think, we actually never tested this count function. And if we look over here, our indentation is a little bit off, right? We have the if check, but then we always return 0. This return should be like this. After the for loop. After we've checked everything, nothing has been matched, then we should return 0. So if I save and run this again, all right, now it's working. You notice that one simple slight error can give you completely different results. So it's always good to go step by step and try out something with something that you already know works. And it's also important to use your debugging skills that you'll develop throughout the course to try and figure things out. Now, no programmer is going to write a perfect program right out of the bat. Most of the time, you're trying to figure out why you're getting this error, why this is happening. And this is just something that you become better and better at as you code. So the only cure to this is to just keep coding. Hopefully, throughout the course, you've seen some of the errors that I make and how I debug them so that you start to adopt these patterns as well. Anyway, this is awesome. This is finally working. let's try a couple more things. Let's say bye and then some gibberish. All right, looks like this is working as well. This is awesome. Our password checker is working. Now I want to do one more thing here to finish out this project, so let's do that in the next video. We've just built our password checker. It's pretty cool, right? I guarantee you this is something that if you start talking about it during an interview, the interviewer is going to be pretty impressed because it does have some pretty advanced topics. But hopefully this whole process made sense and you now have a tool that works and that you can even check your passwords to make sure that you're being secure online. Now, a bit of a caution here that I want to note is that right now we're entering the passwords in the command line. I'm using something called a fish shell. You may have different shells or programs running here that sometimes actually save these commands. If you remember, if I press an up arrow here, you see that I get my passwords back. So somewhere on my computer, this is being saved. Maybe that's not super secure because somebody might have or acquire access to it. So a good way to perhaps for you to improve this program is to read these passwords from a text file instead of a command line argument. But I'll leave that up to you because by now you should know how to do that. The final thing I want to do is just add over here at the bottom, since this should be our main module, to just say if __ name equals main. So only run this file if it's the main file being run from the command line and not if it's being imported. So in here, if I run this, this still works, but we make sure that this file is only going to be run if it's the main file being run. Now, another neat thing that you can do as well is you can also do sys.exit to exit the process in case for some reason this doesn't exit, just to make sure that the system call actually exit and brings us back to the command line. So again, if I save this, there you go. Everything is still working. The only difference that you'll see here is that we have the done being returned versus over here where it wasn't, because we're exiting out of this file. So this entire check my pass Python file was run. And at the end of it all, what does this entire function, this main function return? Well, it returns done. So we exit the entire process and we get the return value of done. There we go, ladies and gentlemen. We've completed our check my pass project. Now, I've told you this is my favorite project. That doesn't mean that the rest of the projects are going to suck throughout the course. I don't think they do. I'm just saying this is a pretty cool one. But I get excited about things like this. Anyway, share your work, show this off to your parents, your friends, your family, your employer, and I'll see you for the next one. Bye-bye. It's time for another project. And in this project, I'm going to show you how to create a Twitter bot. And this Twitter bot is going to do a bunch of interesting things that, might help us with Twitter. Maybe following back people, maybe retweeting something or liking a tweet based on a keyword. It's going to be a lot of fun. Now, this section requires us to work with what we call the Twitter API. If you remember with our discussion of APIs, there are APIs that websites provide that gives us data. There's also ways for us to grab data from a website that doesn't have an API using something like scraping. And that's something that we talk about in the scraping section of the course. But then there's also permissive APIs. That is, Twitter gives us access to its data, but we have to get permission from Twitter to access that data. Not just anybody can get it. So if I go to Twitter API and I click on the link here, I actually already have set up an account. But if you don't have an account, your page is going to, look like this. And you're going to have to click on Apply to apply for access. Now, the Twitter API is completely free. The reason you need to apply is because Well, they don't want people to do bad things, such as create a bot that just posts sensitive information, maybe does something illegal, does some spamming. So they just want to make sure that, hey, this is legitimately for a good use. What you can do when you apply is just say this is a personal developer use account. Make sure you read the agreement and policy. Essentially, don't be a jerk. And as long as you're nice and you're just experimenting like we are now, and we don't abuse the API, they'll give us access. Now, you can do that, or you can just watch me code a Twitter bot. Like I said, it doesn't take long, so you can do this on your own. And I do recommend you signing up for the API because it is kind of fun and cool to build a Twitter bot. Now, once you've created an account, you'll have something like this. And they've actually recently changed their UI, so it looks a lot more confusing than it needs to be. But all you need to do is to just click on Get Started. They have really, really good documentation here that you can actually go to Docs, Documentation, and read up on how you can use the API. But in my case, I want to just create an app. Now in here, I've already created a ZTM bot, but you can just click on Create an App here. You can add an app name, some description of what the application does, so you can say for developer use. You'll have to provide some sort of a website URL, and you just have to fill out some of this information. Now, I wasn't going to just record me entering this information because that wouldn't be exciting to you, so I've created one ahead of time. Now, what we're going to do with this bot is write our own Python script and interact with this API. In order for us to do that, we're going to use something called Tweepy, which, as you can see, is an easy-to-use Python library for accessing the Twitter API. So using the Tweepy library, we're going to be able to interact with this API and, well, write Python scripts. It's going to be a ton of fun. So in the next video, we're going to get started. I'm going to show you how to build your first Twitter bot. I have a folder here called the ZTM bot with my tweet.py file. So get ready and let's start coding in the next video. Welcome back. Let's build our Twitter bot. The first thing we want to do is import Tweepy library. And obviously this isn't a built-in module in Python, so we'll have to install it by saying pip3 install Tweepy. And this is going to install the Tweepy library. Awesome. Now, this library has really good documentation. So when we go to read the docs, it'll actually show you, hey, how to get started and give you some quick startup and setup that we need to do. In my case, I'm just going to copy the hello Tweepy code that they provided for us and just paste it in here. Now, there's a few things happening here. Obviously, we don't need the double imports. What we can see here is that we need to authenticate. That is, we use the Tweepy OAuth handler, and we have to give it something called a consumer key and a consumer secret. And then we also have to set access token with the access token and access token secret. Now, what this is what the Twitter API uses to verify our account. You remember how we had to create an account here and get authenticated because not just anybody can use the Twitter API? Well, this is what they're asking for. They're saying, hey, I want you to verify that this is you. If you're accessing the Twitter API, I want to know who's accessing that data. So in your case, after you've created an app, you just click on Details. And you see here that we have keys and tokens. These keys, I'm actually going to regenerate after this because you don't want to share these with anybody. But I'll at least show you how these work so that for yourself, you'll have different keys and API keys and secrets that you have that you'll have to copy and paste. Luckily, it tells us exactly what they are. We have the API key, which is the consumer key. We'll post it in here as a string. And then we have the API secret key, which is the consumer secret, which we'll paste it in there. Let's make this a little bit bigger so you can see. And then we have the access token and the access token secret. Again, we copy the access token, paste it in here, and the secret. So again, these are the keys that Twitter API is going to be able to use to identify you, but you don't want to share these with anybody. Even though I'm showing it to everybody, like I said, after this video, I'm just going to regenerate so that, well, you won't be able to use my keys. After we've set up this auth object, we then use the tweepy.api to authenticate, and we now have access to the API. So let's check this out. I have my public tweets, and I can grab those by saying api.hometimeline, and then I'm going to loop over these tweets, the public tweets, and just print tweet.text. So let's try this out. Things never work the first time around, so we'll see. I'm going to run Python 3 and say tweet.py. All right, look at that. We've actually, no errors, gotten the tweets from the home timeline. And specifically from my Twitter home timeline. So we see it here, we have, let's see what we have. We have a retweet, an overview of the best newsletters that I know of for front-end developers, including general front-end, JavaScript, CSS. I hope this person included my newsletter. By the way, I have a newsletter, in case you're wondering, every month. But let's check this. If I go to my home, hey, look at that. An overview of the best newsletters that I know of for front-end developers. Brian Rinaldi, I hope my newsletter is included. But there you go. That's our timeline right there. And we're able to access the Twitter API. That was pretty easy, right? Not bad. Again, I keep saying this. I know I'm repetitive, but this is the power of Python. There are just so many libraries, such a large community, and it's so easy to create things. Already, just by looking at this Tweepy library, you probably can think of different things that you can do with Twitter. Like I said, the world is your oyster. That's why Python is such a popular language. Let's get back to this. So we have some tweets, but let's do something exciting here. What else does the Twitter API give us? Well, let's remove these public tweets for now and just print out, let's say, api.me. And this is actually going to give the information about myself. So let's actually give this a variable saying user. And I'm going to say api.me. And this is going to give information about the user. In my case, let's just do user.name. And again, this is something that you can check for yourself on their documentation. And if I run this, there you go. That's my name. That's my Twitter username. Okay, what else do we have? We have, well, the actual screen name, which will be my Twitter handle. Right here, Andre Nagoye with no spaces. And then let's just do, what else can we do? We can also do followers count. Again, these are all on the Tweepy API that you can check for yourself. If I do this, hey, look at that. It's actually pretty crazy that I have 10,000 followers. Not trying to show off or anything, but it's crazy. I barely tweet and somehow 10,000. So thank you for the follow. Not sure how useful my tweets are, but I appreciate the follows. That's pretty cool. But you know what? I want to start building something useful with my Twitter bot. So in the next video, we're going to do just that. I'll see you in that one. Bye-bye. Welcome back. It's time to do something, well, actually productive with our Twitter bot. So what can we do here? Well, I want to create a bot. This bot is going to be, well, you want to be really nice to your followers and you want to follow back people. If you actually look, I'm pretty horrible. I only have 6 people that I'm following. But if I had to go through all my followers and follow every single one of them, that's over 10,000 clicks. That's a pretty manual task. Can we do that with our bot? Well, yeah, you can. So let's do a super generous bot. So this generous bot is always going to follow back. How can we build this? Well, we simply loop and say for follower in, and then here Tweepy gives us something called a cursor. Now, what is this cursor? If we go to the documentation here and I type in cursor, we'll get, well, an actual cursor tutorial. If we read here, we see that we use pagination in a lot of Twitter API. So whether we're going through timelines or user lists or messages, we have to click through different pages, right? Usually there's a lot of followers or a lot of timeline information. So the cursor allows us to, well, essentially in an easy way, go through everything on Twitter, whether it's through an entire timeline or through an entire followers list. And they even give you a nice tutorial of how to use it. You can see over here, for example, let's make this a little bit bigger. We see that we can use the tweepy.cursor to do API user timeline.items to grab all the items on the timeline. So with the Tweepy cursor, we can actually do API.followers to grab all the followers. And then we simply do .items so that we can loop through all the followers. Now, with this followers, well, let's just print them out. Now I'm going to print followers, or follower in this case, because we're looping through here, and then just say .name. Now, the problem here is that when we do something like this, when let's say we're looping through a lot of things, we're going to be hitting the API over and over and over. And Twitter is not going to like that. I mean, this is a simple example, but when we constantly hit the Twitter API, that's hitting the Twitter servers, which Twitter has to pay for. And if everybody in the world hit the Twitter API over and over and over fast with, let's say, Python, that, as we know, on machines runs really fast, well, it's going to overload the servers and it's going to cost them a lot of money or crash the servers. So they actually implement something called a rate limit, where I'm only allowed to request the Twitter API, let's say every couple of milliseconds, so that it doesn't crash the server. And Tweepy actually allows us to work with this Twitter rate limit. So if I type in here, rate limiter, there's actually an error. You can see over here the rate limit error, which is raised when the API method fails due to hitting the Twitter's rate limit. Tweepy over here allows us to use the rate limit error to say, hey, if we hit this error, let's do something. So I'm going to create a little helper function. I'm going to say define limit handle. So we're going to handle here the limit, and we're going to pass it the cursor, which is, again, the cursor that's going to paginate or go through the entire data of API followers. And we're going to do a while loop that says, while this is true, just keep yielding cursor dot next, because cursor is a generator. However, whenever we keep calling next here, which by the way, internally, this is what the cursor is doing, is just constantly calling next and just keeps going until we finish our followers. However, if this is not the case, well, in that case, I'm going to say except, and we're going to wrap this in a try block actually. So I'm going to say try here so we can catch this error. So try while true, and then except if we get a tweepy.rate limit error. Well, in that case, I want to pause and not hit the Twitter API so that we don't get in trouble and come back to it when we have finally gave it a bit of time. So we can actually do that with a built-in module in Python called time. And time allows us to do something really useful here. I can do something called sleep, which essentially says, hey, just pause this whatever it's happening, just stay on this line for a few milliseconds. So if we do 1000, that's 1000 milliseconds or 1 second. So now we have a limit handle, or we can call it limit handler. And if we wrap the limit handler, which receives a cursor, so that is, we just wrap this entire thing, like so. Let's make this a little bit bigger. There we go. We now are able to not abuse and make sure that if we hit the rate limit, we take a bit of a pause instead of just getting errors. So let's see if that worked. I'm going to save and run our piece of code. Let's clear here and run this. All right. Do you see how it's pausing right now? So as soon as we hit the rate limit, it pauses and it just keeps going. And there you go. It's printing out all the followers that I have. That's pretty cool, right? Now, I'm actually going to stop this because, well, it's still going through it. But what we can do now is we can actually follow back each of these individual people. Now, in my case, I'm not on Twitter that much, so let's just follow somebody here at random. Let's follow this user right here. I'm going to copy this user's name like this, and I'm going to do something fun here. I'm going to say if follower.name is equal to this person, well then, in that case, I want to follow this person. So I'm going to say follower.follow, which allows me to follow the user. If I save this and run my code, it's running. Like I say, it takes a bit of time because it has to go through the entire list. But I'm going to pause the video, and when this is done, we're going to see if this worked. All right, I'm back. That took a lot longer than I expected, so I changed my sleep time to 300. And for some reason, while I was running the script, that user decided to unfollow me. So we had to select a different user, which was a JS Smith. And I also added a break statement in here so that it didn't keep looping. Again, it was taking forever, so I just did a little shortcut here. Now, hopefully, I have followed back. Let's have a look. All right, looks like I have an extra. And yep, look at that. I have this person. I've just followed her back. So you can see how this might be useful. You might just follow everybody and remove this if statement. Maybe you're a little pretentious and you only want to follow back people based on their follow counts. So you might want to do something like if followers count is, let's say, higher than 100, then you follow back. So there's a lot of things that you can do here, but that's pretty cool. We created our first bot, the generous bot. In the next video, I want to do another little fun tool, what we call a narcissist bot. So let's see how that works in the next video. So we've created this generous bot that follows back, but what about a narcissist bot? Maybe a bot that loves your own tweets or loves a tweet based on some certain words. How can we build that? Well, let's remove this generous bot for now, or at least comment it out and leave it at the bottom. What we want to do is, let's say we want to search the keywords Python. For now, let's just search through number of tweets, and we'll set it at 2. We'll get to what these mean in a second. What we're going to do here is I'm going to say for tweet in the tweetb.cursor. Again, this time around, instead of going through followers, I want to go through tweets. So in here, I can do something called api.search. If we go to the documentation here, and we go to the API reference, we see we have api.search. that returns tweets that match a specified query. Again, if I go back, I can just say API.search to search the tweets, and we just search based on the term, which is right here, search. Let's rename this just so we know it's different, search string. Let's make this a little bit smaller. So this is going to be search string. So we're going to search the tweets with the search string of Python. So we're going to try and find all the tweets that contain the word Python. And I'm also going to do items in here so we can loop through them. But within the items, I can give it how many items we want to loop through. In this case, we just want to find the 2 tweets. So number of items, it's going to be 2. And in here, we're going to have another try block. And this try block is just going to say tweet.favorite to favorite the tweet. That includes Python. And we'll just print to make sure that it worked. I liked that tweet. Finally here, we can also add the limit handler to this cursor. But because we're only going through 2 items, I think we should be fine. Although it's always a good idea to wrap the limit handler with a tweepy cursor like we did before, but I just want to keep this clean so you can see what's going on. Now in here, we've printed this. We'll do an except block here that will say tweepy.tweepy error. So this is if the tweepy errors, we'll just say as E. And in here, we'll just print the reason for the error. And then finally, if we get any stop iteration errors, in that case, we can just break out of the loop. So let's save this and see if this works. I'm going to open up my console and run our file. All right, we get an error. We have tweepy has no attribute tweepy error. And that's because it should be tweep error. Again, let's run this. And oh boy, we have another error here. This time around, there's no tweet.favorite. But if I go to the API and I do, let's say, favorite, I don't get any results. And this is because I'm Canadian. And fun fact, if you're Canadian, this is how you spell favorite. But in the States, you spell favorite like this, with an O. There you go. We have a favorite method here. So again, fun fact, I'm Canadian, but also Romanian, and that was my spelling error because, well, tweepy was obviously written by person speaking American English. All right, so let's give it a go. And it looks like we have twice. I like that tweet. Let's go back to check if this worked. If I go back to, let's say, profile and look at likes. Hey, look at that. I've liked a tweet that happened 1 hour ago that had the word Python. And another tweet that I have no idea what's saying, but looks like there's Python in here. Yeah, look, there's Python right over there. Hopefully none of these say anything bad, but look at that. You can see here that I've liked these tweets. I'm going to remove that just because I don't know if I should be liking these. There you go. How cool is that? So now our narcissistic tweet can potentially just tweet anything that says our own name or like our own name. If there's ever a tweet that has my own name, well, let's do that. Let's like the 5 tweets that have my own name, and my narcissistic bot will hopefully work. And look at that. This is kind of embarrassing, but it looks like I've already liked 2 of those tweets. You have already favorited this status. But let's go back. If I refresh here now, all right, look at that. I've favorited all the tweets that include my names. And looks like these ones I've already liked before. Very, very cool. There's my narcissistic bot. And you can do different things here. For example, I can retweet as well if I wanted to instead of favorite. So now you know how on Twitter you always have those bots that somehow always retweet something? Well, this is what they do. They look for a keyword like JavaScript or Python or whatever, and they automatically retweet it. Very, very cool. As you can see, this Tweepy library is very useful, and combined with the Twitter API, you can do some really interesting things. But again, you want to be responsible here because there's a lot of ways that you can abuse and just spam people with Twitter. But hopefully, now you see some use cases. For example, if you want to follow back all your followers, instead of clicking through every single profile, you now have a programmer's way of solving that problem with good old Python. I'll see you in the next one. Bye-bye. Hey, we have another project that we need to work on. Now, this project is a little unique because it's going to be a simple project, but I'm going to attempt to do this with no rehearsal. I haven't really tried this before. I want to show you exactly what my process is when I'm exploring an idea. Let's say I want to send myself a text message. That's right. Using Python, I want to receive a text message on my phone. And there's some interesting use cases, right? You can perhaps create a Python script that checks the stock price of, let's say, Apple, and maybe sends you a text that this is now a good time to buy Apple when the ticker symbol gets to a certain price. Or maybe when we create our portfolio in the web development section of this course, and we'll have a contact form for our clients to contact us. Maybe when that happens, we want to send ourselves a text message as well. So this is a very, very useful thing to know. But how can we do that? Well, luckily, it's all about APIs. And Twilio is the go-to when it comes to anything related to communications. Whether it's text, voice, or audio, Twilio is a great API for you to use. Now, if I click on Twilio here, again, we see that some big companies are using it, but we're also going to have to sign up to the service. Now, I'm going to save you the trouble of me going through the sign up process. Instead, I'm going to fast forward and I'll show you once I'm logged in. All right, once you're logged in, you're going to get to the dashboard over here and you're going to want to create a project. So you see over here that there's a couple of templates that you can actually just create for yourself. You can do phone verification, SMS chatbots, two-factor authentication. There's even a game, Learn and Explore, which allows you to explore the API. In my case, I don't want to use a template. I want to just create a product, and I want to do a programmable SMS, that is texting. So let's continue. And by the way, websites like these always change their UI and the visual. So it might look different for you depending on when you watch the video, but all the functionality should be the same. I'm going to give my project the name Zero to Mastery Texter. And let's click continue. Nope, I don't have any friends. This is just me, so I won't invite a teammate. And there we go. We have our dashboard. In the next video, I'm going to try and attempt to send myself a text message. Now, I haven't really practiced this, so we'll see how it goes. We'll do a bit of trial and error. I'll see you in the next one. Bye-bye. So again, I haven't really done this much before, but let's see if I can send myself a text message. I'm going to say get started with programmable SMS. All right, and I'm building my application. Looks like I can just click on just exploring. Let's see how I can do this really, really fast. Oh, first I have to get a Twilio phone number. So in order to send a message, I need a phone number. And this is my Twilio phone number. All right, so we'll choose this number. That's great. All right, I'm going to copy this number in case I need it. Let's click done. And by the way, a job of a programmer is to, well, most of the time, read documentation, Google around, and just figure out how things work in general. You're just a problem solver. All right, so we have send a message here. we have my phone number that I just received. And let's see over here in the right, request, it looks like, oh yeah, look at that. I can click on Python and it shows me exactly, how cool is this? Exactly what code I need to send my message. All right, and it gives me even the auth token and the SID. And it looks like the auth token I'll have to grab. All right, in the next video, we're going to copy this code and try to send myself a text message. Let's see if it works. Welcome back. So I've just found exactly the code that I need to send myself a text message. Let's give that a go. I'm going to copy and paste into my sms.py file that I just created in my TextMe folder. And all right, that looks like it's the code that I need. Now, before I do this, it looks like this gives me a nice dashboard to test out my code before I actually run it myself. So I'm going to here in this to field actually put my phone number down. Now I'm going to blur this out. I don't want people texting me because I'm already bad at answering texts as it is. And the body over here will say, hey, or you know what, let's go, hello. There we go. And we see over here that it actually updates right over here. So let's make the request and see what happens. So I get a 400 bad request. The to number is not a valid phone number, and that's because I forgot the prefix. Let's do a make request again. All right, and I get an error. The number is unverified. Trial accounts cannot send messages to unverified numbers. So I have to verify my number that they gave me. That's kind of annoying, but all right, let's do that. All right, so after a bit of searching, I saw over here that we can go to phone numbers, and in the verified caller IDs, I have to verify my number. So I actually have to enter my real phone number so that they can verify it. I guess this is so that people can't just spam random phone numbers, which makes sense. So let's see, where's Canada here? And I'm gonna hide my number again. And I guess, or we can, I don't want you to call me, so let's do text instead. Oh, I have to enter it again. All right, text me. Yep, I got a verification code. Submit, that's kind of cool. I got a text on my phone. All right, so I have my verified number. Let's go back to, where were we? We were doing our project. Get started. All right, and we have to do hello, and we'll use Python again. Okay, let's make the request and see what happens. Hey, 201 created. The request was successful. And holy moly, I'm gonna post this on the screen, but I just got a text from Twilio. It says hello. Now, mind you, it says that it's sent from a Twilio trial account. So obviously, when I have a fully paid non-trial account, it wouldn't say this, but this is awesome. I just received a text. All right, so I didn't even have to open anything really. I can just copy and paste this into my project file. I just need to copy the auth token, which in here they automatically include, but I assume that I can get the auth token somehow from here. Let's see how we can grab it. Let's do settings. I'll search auth token. Let's do authorized app search. Nope, not there. Where could it be? Let's go to user settings. Nope, that's not it. Oh, that's silly. Look at that. In the dashboard auth token, I can just click view. Definitely gonna hide that after this. So now auth token, I can just paste it in here. And I can change the body to whatever I want. So I'll say, I can't believe this works. Now, the other thing is we have to download the Twilio library. So let's just say pip3 install Twilio. All right, and this is now installed. And let's run this file. I'm going to say python3 sms.py. All right. Looks like it may have worked. Let's see. Oh boy, I'm taking a screenshot of this. That definitely worked. I just received a text message. How cool is that? Now, the reason I showed you this text tutorial is not because you really learn anything from it. I just wanted to show you my thought process when I work through things that maybe I haven't encountered before. It's a lot of trial and error, knowing where to look. For example, I knew that Twilio was a popular tool for text messaging, but even Googling, you're most likely going to come across Twilio. And then it's all about reading about their API and what you can do. And most of them, like Twilio, if they're big enough, have really good documentation where you basically don't even have to code. Now, the beauty here is that in a couple of minutes, I was able to send myself a text message. And now there's so many use cases that you can think of. Again, we want to start thinking like programmers. How can we use this? Maybe when we receive an email from an important person. Maybe when we get a specific tweet that we're interested in. Maybe we can receive a text using the Twilio API. Maybe you have a portfolio website and you want to get a text anytime somebody completes your contact form, or maybe orders your product from your startup landing page. The possibilities are endless. But with that, you've just learned how to send yourself a text message. That was a lot of fun, but I think we deserve a break now. So I'll see you in the next video. Let's talk about web scraping. One of the things we can do with Python. What is web scraping? Well, web scraping simply means programmatically, using Python or any language, grabbing data from a website. So for example, I can grab data from Amazon, from Airbnb, from maybe a recipe website. Any website can be scraped. So essentially, when we talk about web scraping, we mean downloading a web page, grabbing the data from that web page, cleaning it up somehow so that it's useful for us, and then using that data. You see, this is how websites work. We have a browser that we use, like a Chrome, and we have a server. A server is simply a computer somewhere in the world that has 3 files that are needed to display a web page. We have an HTML file, which is the content of the website. You can think of that as text and images of a website. We have CSS, which gives us the colors and pretty styling that websites have. And then we have JavaScript, which allows us to have different behaviors in our website, like submitting forms or having drop-down menus. And all a browser does, like Chrome, is say, hey, if Andre visits this website, let's say FIFA.com, browser is going to know when I type in FIFA.com that says, hey, server, can you give me the FIFA.com HTML, CSS, and JavaScript files? And the server says, yep, no problem, here they are. And then the page gets displayed onto our browser. So these 3 files, well, the data in them is accessible to us, right? It gets displayed on a web page. So these files are now something that we can actually check out. For example, if we go to the FIFA.com website, you see over here that, well, we have a pretty page with a lot of information. That's great. And if I right-click here and do View Page Source, this is the HTML page of the FIFA website. As you can see, it's pretty long, but it has all the data that we see in this page. Now, the CSS and JavaScript files are linked to it But the main data, that is the text, maybe the images, are all here. So, for example, we have latest news, we have top 10 goals from the Women's World Cup. Well, let's find out. Let's say top 10 goals from the Women's World Cup. You see, that's what we have. We have the text right here. And web scraping is simply this, grabbing this data and then removing all the parts that we don't care about and just keeping the parts that we care about. And web scraping works because this information is public. In order for a website to get displayed, it has to be public. Maybe you're still wondering why web scraping might be useful. Well, there are many cases for it. For example, I'll link to this resource where it talks about some of the big uses for web scraping. Why would we want to scrape a website? And you can see here there's many reasons. Maybe you want to get sale leads. That is, you want to collect all the emails that are on a web page, maybe a contact form. Maybe you have a yoga office software product. Maybe go to every single yoga studio's webpage and find the contact information, scrape that data so you don't have to manually do it. Maybe you want to find all the jobs and open positions on a website. And instead of manually clicking through different pages, you can scrape that data. And there's many use cases. In our project that we're going to build for this section, we're actually going to scrape Hacker News, a very popular website for many programmers, and we're going to turn this into something even more useful for us to read, analyze, and stay current with our industry. But we'll get to that in a bit. Let's take a break here and learn a little bit more about web scraping in the next video. Let me ask you this. If you were a website owner, would you want people to scrape your website? Would you want people to access your data? Maybe you're Airbnb and you worked really hard to list these products, different information on here. Is it fair that anybody can come and just grab this information and maybe make a copy of your website? Well, not really, right? I mean, it depends. Most of the time, you don't really want people scraping your websites. Although HTML and the data of a website is available to all of us, it's just how our internet works so that people can see different web pages. Most websites don't really want you scraping their data. Now, there's actually a way that websites tell you what you can and can't scrape. It's called robots.txt. We simply say at the end of a URL /robots.txt. If I click enter, look at that. Airbnb has a robots.txt. Robots.txt simply says, hey, if you're a robot, if you're a web scraper or a spider, this is what you're allowed and not allowed to do. Does it mean that they'll prevent us if we break the rules? No, they can't really prevent us. But this is a gray area where you want to be ethical here and only scrape the data that a website allows you. So if we look at robots.txt, you see here that Airbnb has created a text file that tells us what you can and can't scrape. For example, we look at the user agent here, which says the Googlebot. Airbnb is telling, hey, Googlebot, you're allowed to scrape this information, but we don't allow you to scrape account, alumni, calendar, and you see that there's a lot of things that's disallowed. What about Bing SearchBot? Well, Bing, you're allowed to do this, but you can't scrape any of this data. We have YandexBot. What else do we have? We have Baidu Spider. And then we also have user agent star. That means anybody else. Anybody else, you're allowed to scrape this, but none of this information. All right, let's go to another one. Let's go to udemy.com. Here we see that anybody, we don't want you to scrape or crawl through any of this information, but we do allow you to access this API 2.0 course landing components, All right, so that's too bad. It looks like Udemy doesn't really allow us to do anything other than this API 2.0 thing, which we'll come back to. What about Hacker News? We're going to build a project around Hacker News. So let's see if Hacker News allows us to scrape it. All right, so this list is a little bit smaller. We see that for all users, we're disallowed to use these endpoints. So it's saying as long as you don't use these ones, these URLs, we're good to go. That is, if we wanted to scrape just the homepage, which is right here, that's fine. If we're trying to, let's say, go to comments, that's fine too, because this one wasn't in robots.txt. Again, if you remember, if we go to robots.txt, that's fine. The only thing that they ask is that we have a crawl delay of 30. That is, if we're going to crawl their website, we should have a pause so that we don't constantly use programs to hit their website because, well, this is going to overload their servers and maybe slow down their website. So what did we just learn? We learned that there's ethical and unethical ways of scraping websites. Yes, you can scrape any website you want. And as a matter of fact, there's Chrome plugins. If you Google Chrome plugin web scraper, there's a ton of web scrapers that you can use that allow you to scrape websites without even writing a single line of code. It's a good thing to practice ethical programming. And that means checking a website's terms and conditions before you scrape it, checking the robots.txt to see what you can and can't scrape. Because usually the data you scrape from a website should not be used for commercial purposes because you're using somebody else's hard work to, well, perhaps make money. And this is why when we went to Hacker News, it asked for a crawl delay of 30 seconds, right? If you're requesting data from a website too aggressively with your program, that's essentially spamming because this may break Hacker News. Now, before we get into web scraping, I want to note one other thing, and that is this idea of an API. If you remember, when we accessed Udemy's robots.txt, they did tell us that there is some allowed areas that we can scrape or endpoints that we can use. You see, some websites actually allow you to access data. For example, Udemy gives us an instructor API. That is, if you're an instructor on Udemy, you can actually use their API. You can see it right here so that you can get different data. Maybe you can get a course review list, maybe a course questions list. But if I go here and I enter this in my URL, I'll get an invalid missing token. That is because right now I'm not an instructor, or at least I haven't verified that I'm an instructor on Udemy. It's going to say, hey, this data is only for valid instructors. So I need to pass it a token to prove that I'm an instructor on Udemy. And a lot of websites give you what we call API, or Application Programming Interface, access in a form like this called JSON to, well, give you the data that you need. And some websites only allow you to do this if you're a valid user. For example, one of the most popular APIs is this GitHub API, where you can access different information from GitHub. But in order for us to use it, we have to, well, create a user account and validate so that we are who we say we are. But then there's also websites like the Star Wars API that gives us free access. That is, anybody can use it. We don't need to verify that we're a user. We don't have to give a token when making a request. Instead, we can just request data. So for example, if I do the Swappy API and type in people and I hit enter, look at that. I get all this data for free. So that this, well, I can create an app around the Star Wars, which is what Swappy stands for. It stands for the Star Wars API. And we can grab all this information that we want. We also have things like the JSON placeholder, which I really like to use when building simple projects where we can get different information like photos. You can see here that this is an API that gives us information with different photos that we can use. Maybe we have different posts that we can use. And again, these are what we call in JSON format, which isn't HTML, but just a cleaned up version of data so people can use it. The easiest way to get data from a website is usually using an API. Sometimes websites allow us to just access it easily. Or they might have an API, but it's only restricted to certain users. Maybe you have to register with their service. Maybe you have to pay for their API. Well, in that case, we have this. But then there's also web scraping, which is maybe a website doesn't give you access to an API. Maybe you want to just have that information. For example, Hacker News doesn't offer an API as far as I know. So instead, we might want to just scrape the HTML of the website and see what we can use. So how can we scrape a website using Python? Let's find out in the next video. Hey there, I want to add a quick note about what we just saw with Airbnb and how search websites like Bing, Baidu, and Google actually work. Now, you may have noticed that the user agent Googlebot is, well, what Google uses to index websites. What does that mean? Well, Google, the way it works, remember, is a search engine. What it does is it tries to figure out all the websites on the web and index them. That is, create essentially a database of all these web pages so that when I Google soup recipes, Google gives me a website that has soup recipes. Now, how does it know what websites have soup recipes? Well, it uses this Googlebot. And this is how Google got started. What they did was they had a crawler, that is a program that crawled websites and read websites, kind of like we're about to do with web scraping, to understand what the website is about. If the website mentioned the word soup recipes or had different text related to soup recipes, well, Googlebot is going to say this website is about soup recipes. So when Andre searches soup recipes, I know that these websites are the ones that we want to show him. And this is what Google and Bing and Baidu all do. They have their own bots and they're constantly crawling websites to see what is the most relevant website to give to a user. So Airbnb here is saying, hey, Googlebot, when you come crawl my website, don't crawl any of these things because I don't want you to. But anything else that's not here, you can crawl. Now, if you actually look through here, this is not everything on Airbnb because Airbnb wants Google to crawl their website, right? If I search for vacation homes in Costa Rica, Airbnb is interested for Google to post an Airbnb link to the top of the search. So what they disallow here is mostly user-specific thing that Google shouldn't have access to, like maybe reservations or payments. But there's a lot of other endpoints that are actually allowed for Googlebot to search. For example, Googlebot is most likely allowed to look at all the houses available in Costa Rica and actually rank them so that when I type in Costa Rica house rental, well, Googlebot is going to say, hey, Airbnb has a link to Costa Rica houses. We'll give that to this user. So anything that's not in this list, well, we're allowed to use. One tricky thing is that we see this allow here. What this allow means, it says, hey, calendar here is actually a disallowed endpoint. However, we allow inside of the calendar this iCal folder. You can access that one only. But if it's not mentioned here, so if anything in here on this list is not mentioned, that is allowed. So for example, Airbnb./ that's allowed because that wasn't on the list. If I maybe click on experiences, This is allowed because this -s/s/experiences was not on the list. So a website either has a robots.txt file because maybe it doesn't want specific things scrolled, or if it doesn't have a robots.txt file or just leaves it empty, it means, hey, I don't care. Google, you can rank my website, you can crawl my website, that's good too. And that's why Airbnb had different information here. We had specifically for Googlebot, for Bingbot, for all these search engines, but also for everybody else. Maybe programmers like us that want to scrape the website. There you go. We secretly learned how Google and other search engines work. Pretty cool, right? All right, let's get back to the topic at hand. Welcome back. In order to learn about web scraping, let's actually build a useful project that we can actually use and maybe even add to our portfolio. What I want to build is a nicer version of Hacker News. You see, every morning as a programmer, I wake up and I usually read Hacker News because it's a great way for myself to stay up to date with the industry and just learn about general programming news. They have some really, really nice articles here, and a lot of programmers use Hacker News as a way to stay up to date with the industry. This page has a ton of information. As a matter of fact, every time you refresh, it's a new topic, new thing. If I go to the New tab here, for example, you see that these stories, as I refresh, new stories get added constantly. So it's a very fast-paced website because a lot of people post news links here to get traction because there's so many readers here. Now, in order for me not to get overwhelmed, I usually only like reading or checking out the stories that have over 100 points. That is, they've been upvoted by users. So let's build a tool using web scraping that when I wake up in the morning, instead of having to scroll through and find out all the stories that have over 100 points, because those are the most popular ones, maybe the most important ones, let's scrape this data and then remove all the stories that, well, have less than 100 points so that I can only focus on the important news articles. Sounds pretty exciting, right? That's a great use of Python to make our life easier. Now, after we're done with this project, there are many ways to apply this knowledge. For example, one of the things that Hacker News has is every month they have a Who's Hiring, where companies post job opportunities for programmers. So a good project might be to actually scrape this data of companies posting different job opportunities and maybe try and figure out what the trends are. What type of programmers are the most in demand? Hey, are Python programmers the most in demand? Maybe by scraping and finding how many times the word Python gets mentioned. Or maybe is Java or JavaScript programmers the most common? And maybe you can create a website that tracks the trends of different posts to see, well, what skill you should be learning to stay up to date and make sure that it's the most in-demand skill. Just an idea. But let's focus on this for now. In order for us to scrape this website, we want to use a tool called Beautiful Soup. And Beautiful Soup is what we can use in Python. It's a library that we can use in Python to scrape websites. They have a very old school website here, but it's a very useful tool that most web scraping projects use. So in the next video, we're going to get our hands dirty. We're going to learn about Beautiful Soup and start creating our web scraping project with Hacker News. Let's get started. All right, it's time to get started with our Hacker News project. Now, the first thing we're going to do is we're going to set up our environment. In my case, for this project, I'm going to use Sublime Text, but again, use whatever text editor you want. I also have my terminal or command prompt here, and I've created a scrape.py file. Now, the very first thing we need to do in order to scrape using Python is, well, we need to download Beautiful Soup. This is what allows us to scrape websites. So all I'm going to do is say pip3, and I want to install Beautiful Soup 4. This is the latest version. I'll click enter, and there you go. Awesome. We have Beautiful Soup installed. The other thing that we need is the requests library. Now, we're going to use the requests library a lot in this course. If you don't have it on your computer already, again, we just use it using requests. It essentially allows us to grab HTML files like Hacker News. So what we're going to do is say pip3 install requests. So once we have that, what we're going to do, and I'm going to show you why we had to download both. First thing we're going to do is to actually import request or requests. And the other thing is the Beautiful Soup. Now, the way we use Beautiful Soup is we say from BS4, we want to import Beautiful Soup. I know it's kind of weird because we installed Beautiful Soup 4, but this is how we import it once we've installed it. So from BS4, import Beautiful Soup. Now, why do we need these two things? Well, Beautiful Soup actually allows us to use the HTML and grab different data. So it allows us to use that data that we've gathered to do whatever we want to it, to scrape it. But the requests module is actually what allows us to download initially that HTML. So let me show you what I mean. The first thing we're going to do is create a new response variable. And this response will be the requests and the URL that we want to grab the data from. So you can think of this as a web browser that we're using without the actual window. Because this is what Google Chrome is doing underneath the hood. It's trying to grab the information of that website from a server. So let's go back here and let's go to Hacker News again. We're going to copy this link and I'm going to paste it in here. There you go. Let's make this a little bit bigger like that. And what we actually need to do here is to say .get. So we want to get the information here. So we're doing a get request to grab this page. So that now if let's say print response, I save this and I run by saying Python 3 scrape.py. All right, I get a response, a 200 response, but well, what does that mean? What we're essentially doing here is if I open up View, Developer, and do Developer Tools, I click on Network here. Let's make this a little bit bigger. There we go. And I refresh this page. I get a lot of information, but the main thing that we care about is this, the first document, news here. If I click over here, you see that this is what we get. We get an HTML with all the data, but we also saw here that the response was 200. That means everything's okay. The server responded with 200 and it gave us a document. This is what we just got. So in here, we can actually say response.text that we got. So let me run this again and look at that. We have our entire HTML file that displays the text in here. Because we don't care about styling, right? We don't really care about styling. Maybe we don't even care about images. All we care about is the text. And for our purposes, we care about the actual link as well as the votes that the story has. So we grab this data, and now what we can do is use Beautiful Soup to clean up this data. Right now, this is a lot of information. We don't really need this, do we? Or at least we want to remove all the information that we don't need, such as stories that have less than 100 points. For example, this one over here with 176 points, we definitely care about. So let's take a break and see how we can use Beautiful Soup next. Welcome back. So we just received all the data from Hacker News, at least on the page that we requested. And we saw here that we received all this HTML information, which is great. This is just a string that we received. What Beautiful Soup allows us to do is to do something called parse. That is, we can use Beautiful Soup to convert this from a string to an actual object that we can manipulate and use, using Python to modify this data to what we want. Let me show you what I mean. So we can now use Beautiful Soup. I'm going to remove the text here. And we can say Beautiful Soup. And then in here, I can give it the string that we want with all the data, that is response.text, like we saw, which is the one on the left here. And then we parse it. That is, we tell it, hey, this data needs to be modified into HTML that we can actually use. So the way we do that with Beautiful Soup is we simply say HTML.parser. And this tells Beautiful Soup that, hey, this is HTML and I want you to parse it. So convert it from a string to something that we can actually use. And this creates what we call a soup object. So I'm going to assign it to a soup variable, but I can call it whatever I want. Now, some of you might be asking what this really is. And the reason that we have to do this is that Beautiful Soup also parses another data called XML. And again, if we go to the documentation website, let's go to Beautiful Soup documentation, and let's just search for HTML.parser. You see over here that we can have different parsers, such as the HTML parser, which comes built in, but there's also the XML parser and other parsers that we can install. So again, anytime you have a question, always refer to the documentation and just Control F and you'll find any extra information you need. 99% of the time, you're just using the HTML parser as the default. But what does that mean? What did this just do for us? Well, let's have a look. If I print here the soup object that we just created, and let's go all the way down here. Let's clear this for now and run our Python code again, scrape.py. All right, we see here that we got the soup object. It's actually a little bit cleaner. It's no longer a string. You see here that it's in full HTML. We have the title, we have the head, we have the body tag. So we can actually manipulate this as if it's, well, a Python object. So for example, I can do soup.body to grab just the body. So if I save and I run the script again, there you go. We now just received the body. Let me clear this so we can see it. I'm going to run it again. You see that now we have just the body. I can even do something like .contents. And if I run this, let's clear this again. I get the entire content, but you see here in a list form. Awesome. Now, using this soup object, we can do some really neat things. For example, let's say I want to find, using the find all method, all the divs that we have in this soup object. So if I save, let's clear this and run our script. How cool is that? We get all the div objects in a list form that's contained on that page. What about all the links? Maybe we want to get all the A tags, which are the links of the site. Well, once again, let's clear this for now and run our script. And look at that. We have all the A tags. That is all the links on the page. And you can imagine there's different uses that we can do here. We can say title. If I run title here, we get the title tag of our soup object. If I do something like A here, which is the A tag, and I run the script again, I'll get the first A tag that comes up. Another one that we can do is something called find. So instead of find all, find finds the first thing. So again, if I do find A and I click run here, you see that I get the same thing. It finds the first item. Now, why is this useful? Because if we go to our Hacker News website, and what I want to do is, let's say, go to the first link here, right click it, and then do inspect. This gives us, well, this HTML DOM object that gives us all the information on the page, right? So looking at this, I know that for sure I'm going to want this A tag that has the link and the title. But I'm also probably going to want the votes, right? So if I keep going down here to this part, you see here that right here is the score. And I'm probably going to be interested in how many points this is as well. For example, I can use the ID attribute here. So let's copy this score. I can even do something like find and give it an ID that equals this value. If I now, let's clear all and run the file, you see that I get that exact same tag with the ID of this score. So by allowing us to grab these different elements throughout the page, we can selectively pick what data we want. Let's take a break here and learn more in the next video. Now, one of the best ways, in my opinion, to actually use this soup object is to use the select method on it. And select allows us to grab a piece of data from the soup that we just downloaded and created using what we call a CSS selector. Now, this is a Python course, so we're not going to focus too much on CSS selectors. I will link to a resource so you can learn more about them. But a CSS selector allows us to access this data using, well, CSS selectors. So if I Google here CSS selectors, you see here that, well, it's a list of different ways to grab elements on an HTML page. We can use the class, the ID, the actual element. So let me show you how to do that. I can say, for example, select A. And what is this going to do? Well, if I run this script, it's going to select all the A tags. Okay, that's nothing new. We've seen that before. We can do that for div as well if we wanted to. But we can go beyond just an element and say we want to select, let's say, the class score. So this class score can be accessed by using the dot notation. So dot score is going to grab all the scores on the page. So watch this. If I clear this and run here, look at that. I grabbed all the span tags that have scores on them. So you see over here that this is just a list of all the spans because the span has a class of score. This span has a class of score. And we can do the same thing with IDs. So if we wanted to grab this ID, we simply say, instead of a dot, which stands for a class, we do pound and then the ID. So if I run this, we get this one span because this is the only one with this specific ID. Now, I'll link to a resource where you can learn about more CSS selectors. They become really, really powerful when you start selecting different complicated nested elements. Let me show you. Let's start to plan out what we want to do. Now, in here, I'm going to close this for now. I want to grab the link over here. So that is the title and the link of a story that has more than 100 points votes. And everything else that doesn't have 100 points, like this one, I just don't care about. So I'm just filtering it out. So what we want to do is, first of all, grab this link and grab this votes. So we also list out how many votes the story has. So the way I'm going to do this is I'm going to right click, click inspect. What we know is that we want to grab this link that has a class of story link. Okay, so just to double check, if I go to this one over here and inspect, you see that here, this one has a class of story link as well. So let's just grab all the elements that have class StoryLink and see what happens. I'm going to say dot StoryLink because dot means it's a class. And let's see what we get. I'm going to run the file. And all right, we get a ton of lists, but it looks like they're all A tags. So these are all links that we can use. It looks like this is a list, so we can probably grab it using the square bracket 0 to grab the first element. Let's see if this works. I'm going to clear here and run this again. All right, look at that. Visual Information Theory 2015. That's the first item in here. So it looks like StoryLink grabs us the A tags, the links for each one of these items. Okay, what about votes? Let's grab the votes as well. I'm going to right click, say inspect. And what do we have here? We see that we have class of score. So let's just grab all the classes. So I'm going to say that this is going to be links. And that is, well, just instead of grabbing the first item, I'm going to grab all the links. And I'm also going to grab all the votes. And all the votes is going to be soup.select. And then grab, what was it again? It was the score class. So I'm going to say grab all the elements that have the score class. And just to make sure that this works, let's just say print votes and grab the first item. So I'm going to run this. And look at that. I have 180 points because the first story, let's refresh the page because this may have changed. Yeah, it looks like, see, this website is constantly changing. It now has 182 votes. So if I refresh here, there you go, 182 points. Awesome. So we now have grabbed the two pieces of information that we really care about, the links and the votes. And luckily they're all in order because each link, the first link and the first vote is together. The second link and the second vote is together. So that's useful for us. Now, just as a side note, with Beautiful Soup, we can keep chaining these, right? For example, I can now say votes.get and get, for example, an attribute name. So for example, I can grab a score over here and say, hey, grab the score from here. So that if I do print here and I run this, well, votes is a list, so we actually have to grab the first element. So let's just grab the first element, run this again, and we get none because, well, this is the value. The attribute is ID. So if I do get ID, for example, and I run this, I now get the actual ID value. So with Beautiful Soup, we can keep chaining these. We can keep selecting. So I can say dot select here if I want, if we have even more information. But in our case, we have the information that we need. It's time for us to go to the next step, which is to try and combine these and make it more useful. So let's do that in the next video. Welcome back. We have our data, but it's still kind of dirty. I mean, we haven't really filtered. I only care about the stories with over 100 votes. And we also want a pretty way to display them. So let's work on that. I want to create a function, and we'll call it create custom hacker news. And this create custom hacker news is going to receive links and votes, which we have above over here. Now in here, what we're going to do is we're going to create a new hacker news list that is empty to start off with. And for now, all I want to do is return the hacker news list. But within this list, I only want to add the text and none of the HTML. So for example, for the links, we only care about the title. So how can we do that? We want to loop through some things. What we're going to do is say for, and we'll use enumerate here. So we're going to have an index and then an item. And in here, we're going to enumerate. Remember, we've seen the enumerate before, which gives us an index as well. And we're going to enumerate the links. And I'll show you why we want to enumerate in a second. So in here, I want to grab the title of each link by simply doing this. We're going to say link of index, or let's change this to IDX. That's a little nicer. So we're going to grab the index of each link, and we can use something in Beautiful Soup called get text. And this is going to get the text inside of the tag. And just to get us started on this, I'm going to just simply say hackernews.append and add to the list the title. So let's see what happens when I call this. I'm going to say create custom Hacker News, and we're going to pass it the links and the votes. So let's save, run this. Oh, and it looks like I cannot spell enumerate here, so let's fix that. It should be enumerate with E. Let's try that again. All right, no errors, but we want to ideally print this. So let's just say print and see what we get. I'm going to run this. All right, look at that. We have all of the texts, the titles of our links. That's great. Okay, but these titles are useless without a link, right? And if you remember, a link in an HTML is defined with what we call an href. This href attribute is the link that we can click to go to the next page or to the page of this title. So we can also grab that and we can call it href, and this is going to equal links index. And this time around, we don't want to get the text. We want to get the attribute, right? So we can actually say dot get and then grab the href. And just in case there are no hrefs or maybe the link is broken, we can give a default in the second parameter, and I'll just say none. So that now this Hacker News append, if we just append, let's say this time the href, and I run this, look at that. We have all the links on the page. That's awesome. But how can we combine the title and href now? Well, this should be fairly simple, right? We can use a dictionary. So in our list, we can append a dictionary that has the title, which will be the title that we have here. And then also have the link that will be the href right over here. So here, now we'll have a dictionary with title and link. So if I save and run this again, look at that. We have a dictionary that has a link and also a title. Awesome. So we grab the information that we need. We grab the link and the text. None of the other stuff matters to us, but we still have the votes. So how can we do that? The votes, well, we can create a variable. Or instead of votes, just to distinguish it from this, let's just say points. And points is going to be, well, what are we going to do? We're going to grab the votes index. Remember, we're looping through this. And we're simply going to say get text. Now, let's see what we get initially when we do get text. So in here, I'm just going to print points and see what we get. And I'm going to remove the print from here just so we can focus on the points for now. So I'm going to save and run. All right, we get an error. We get all these points, but it looks like I get an error saying list index out of range. And this is a little gotcha that you're going to have to sometimes debug when scraping websites. But essentially what happened here is there's a story, and this is a special one that actually doesn't have any votes, which is very rare on the front page of Hacker News. But this one over here doesn't have any votes. So essentially what it's saying is, I never grabbed the scores, the points of this. So we have technically more links than we have votes. So by the time we get to the last link here, well, the list of votes is one less. So it's going to say, hey, I'm trying to grab the votes at the very end, but there's no more votes. This list is shorter than the links list. So we can just do a quick check here to make sure that when we grab these things, that we only care about stories with votes. And luckily for us, this is why we want to check if a story is more than 100 points. The way we're going to do that, we're going to add an if statement right here. Now, before we add the if statement, we actually want to convert this into a number. So we can say, hey, if a story has more than 100 points, then we want to keep it and append it to our new Hacker News. So the first thing we want to do is to simply say that we want to convert this into an int, but we also want to replace the points here, the space points, into, well, nothing. So we can use the .replace method and simply say, hey, anytime you see space points, which is what we see over here, I want you to replace that with just an empty string. So this is going to return for us a string that is a number, and then convert it into an integer. So let's test it out. Let's close the bracket here, hit save, and run our script. And there you go. We have our numbers. That's great. But again, we still have this error. So what can we do here? So in order to fix this, we have to change our strategy. Instead of grabbing the points, we should grab what we call the subtext. And the subtext is, well, what comes underneath the title, because every single title has these subtext. And underneath it, we have the score. Now, in our case, the top one over here doesn't actually have the score. You see here that we have the subtext, but there is no score. So what we can do is do a little extra check. If we go back to our code, we can now change this a little bit so that instead of having the votes here, what we can do is grab the subtext. And this is going to be the subtext class that we're going to grab to make sure that all links are going to have the subtext. So let's select subtext. And in here, we're going to change our strategy to say that, hey, the votes that I want, or in our case, the vote, because we're looping through here, is going to equal the subtext at the place that we're looping through. And we're going to select the class of scores. So remember, if we scroll down, class of score is what we want. And that's going to be our vote. Now remember, there are some cases where the vote won't be there. So what we can do now is say, hey, if vote has no length, because remember, we're going to get an array. If this length is 0, that's going to evaluate to false. But if it's not 0, then I want you to do all of this. So now, our vote, instead of doing index here, we can just say vote, get text, and replace the points. But it's only going to run if the vote list exists. So let's test this out. I'm going to run. Oh, and we have to change our parameters from votes here to subtext. So let's do that. Let's say subtext, subtext. If I save and run this again, We get list object has no attribute get text because, again, we get an array here, so we have to grab the first element in the array. Remember, because we're grabbing the subtext. So if I run this again, all right, it looks like we finally have our points and no errors. That's awesome. So you see here, when you're web scraping, you're testing out your assumptions and maybe you make some mistakes, so you want to adjust and fix them based on what the website does. Now in here, the last thing I want to do is to actually add the vote into our Hacker News append here. So let's remove the print here. And I'm going to add the votes as the points that we get here. Let's make this a little smaller just so you can see. Perfect. So we have this Hacker News append. So let's test it out. Now, before I show you, I want to show you something when it comes to enumerate. Why did we use enumerate? Well, it's because in here, we have two lists, the links and the subtext. And we're only enumerating over the links list. And subtext, well, is not being enumerated. So what happens here is we need the index so that we can access this subtext within our loop. Because otherwise, well, if we didn't enumerate, there's no way to grab both links and subtext items. So for example, in here, my links can just be converted to item and item, but subtext will just have to use the index that we have here. Hopefully that makes sense. Now let's print this and see what it looks like. I'm going to print, hit save, and let's run our script. Oh, and we have a little mistake here. We got to make sure that the curly brackets are outside. If I run this, all right, we see that we get our data, and let's just check. We have title about security issues on VLC, which has a vote of 307. Let's just check that on the page. If I scroll down, about the security issue on VLC, which has 307 votes. Awesome. So this seems to be working. Our script is working. Wonderful. Now, the last thing I want to add here is this whole printing is a little ugly. And ideally, we can print things nicely to the terminal. Well, we have a module, a built-in module that we can use in Python called PrettyPrint. And we can just import it like this, pprint. Now, check this out. If instead of print here, I do pprint.pprint, let's see if we notice a difference. All right, it's a little neater now. We have a little bit more spacing and, well, it's a lot cleaner than it was before. That's really nice. Now, the other thing is, as we mentioned, we only care about the votes that have over 100. So let's add another if statement here. Let's make this a little bit bigger. And within the points here, we'll just say if points are higher than 99, then we'll append to our updated Hacker News. Let's save, give this a go. All right, it looks like we only have stories that have over 100 points. So it's nice and clean, a lot smaller now. Awesome. Now, there's a few more things I want to add to this. Ideally, these votes are ranked. So we have the highest vote at the top and at the bottom, the lowest vote. This way, it's easier for me to decide what story I should read first. Let's explore that in the next video. Bye-bye. Welcome back. Let's add another layer to our app, which is to sort the list of our links from top to bottom. And we can do that fairly easily. Let's here, instead of returning Hacker News that we have here, we'll create a new function called sort stories by votes. And we'll give it the Hacker News list. And we'll create this function up here. We'll say define sort stories by votes. And this will receive the parameter Hacker News list. And we're going to do just a simple sort algorithm here. So we're going to use the sort function that we have. We're going to give it the Hacker News list, and let's see what happens. I'm going to run this. Oh, and I have to do sorted here. That's the method. Let's run this again. We get an error here. And if we read the error, it says type error. Not supported between instances of dict and dict. What does that mean? Well, we're trying to sort items in a list, but they're all dictionaries. So Python is saying, hey, I don't understand. How do you want me to sort it? Do you want me to sort it by title, by link, by votes? You got to tell me. And this is a common pattern with sorted that you'll just have to get used to. We're going to use a lambda function. Our second parameter is simply going to be the key that we want to sort by. And that key that we want to sort by is, well, votes, right? So all we're going to do is say lambda and say key. And this key that we're going to sort by is going to be votes. So that if I save this and run this again, look at that. I have everything sorted by votes, as you can see. Now, if this is overwhelming to you with the lambda, you can go visit the section of the course where we talk about lambdas here. But this is just a common pattern that you can remember with sorting. Whenever you're sorting dictionaries, we use keys. And we can give it this syntax with a lambda and pass it the key that you want to sort by. In our case, it's the votes. The last thing we want to do is we want to actually have the reverse order. So the top item in the list should be, or the first item in the list should have the highest number of votes. So we can simply do that with the third parameter by saying reverse equals true, just like that. Now if I save and run our code, we see that we have a list of all the top links with the very highest one of 309 votes right here. Very, very cool. Now the exciting part is that you don't even have to visit Hacker News website anymore. You can be a complete programmer and do cool things like just read the titles here. And we can read about, Facebook's $5 billion penalty due to privacy reasons by just selecting this link. And let's say you're using terminal, you can just say open selection as URL. And look at that. We can read the story directly like that. Very, very cool. So now you have a cleaned up, more efficient version of Hacker News that you can read every day. And all you need to do is just run this script in the morning and get your reading done. Now, there's many ways that you can expand this project. You can maybe display this on your own index.html file so that you can actually click on these links. You can do this with other websites. But my challenge and exercise to you is this. How can we expand this list so that it includes more than just the first page of Hacker News? That is, if we go back to Hacker News, so far we've only scraped these 30 links. But what if I click more here and I want to go to this second page and I want to scrape the first 2 pages of Hacker News? How would I go about doing this? In the next video, I'm going to give you the solution, but I challenge you to figure this out on your own and see how you might do it. If you get stuck, well, I'll see you in the next video. Bye-bye. Welcome back. This was probably an exercise that sounded a lot more complicated than it actually was. So hopefully most of you were able to solve it. If you didn't, by the time you watch this video, you're going to say to yourself, oh wow, that was so simple, I should have figured it out. So don't worry, we'll get there. Let's see how we can do that. Well, if we go to Hacker News, you might notice something when you click on More. When you click on More, you actually get a new URL here with, well, you see the query string, which is a question mark here that says P2. So if I do P equals 3 here, we go to page 3, we go to page 4, and so on and so forth. So all we actually need is just this link. And all we need to do is go all the way up to our code. Let's minimize this for now. And simply just duplicate what we've just done. We grab a second response. And this response will be request.get. And this link with page 2. From here, we simply grab this soup and recreate it as soup2, and it's going to be from the response2.txt. Again, what we'll do here is we'll duplicate this code, and again, if you notice that this could be more efficient, maybe we can extract this into a function. That's good, you're starting to notice these things. So here we're just going to do links2, subtext2, which we'll grab from our soup2 and, well, soup2. And we can now just combine these two things by simply calling, let's call it mega links, which will combine the links with the second links. So we're combining the two pages. And we'll do the same for mega subtext, which will be subtext plus subtext 2. And because we've written our code in nice functions, all we need to do now is replace our parameters, right? All we need to do at the bottom here is say mega links and mega subtext. If I save this, this should now work. Let's have a look. Oh, and classic me made a bit of a spelling error. If we go over here, it's not mega subtext, it's mega subtext. Let's run this again. You'll see here that it takes a little bit longer, again, because we're going to 2 pages. But look at that. We have our Hacker News using 2 pages. You can see that it's clearly longer, and we have a story here with 951 votes. I should definitely read that. How to access quality of garments. Sounds very important. And there you have it. You have now just covered the basics of scraping. As you can see, it's very specific to a website that you want to scrape. Remember, you want to check to make sure that A, you're able to scrape the websites by checking the terms and conditions of that website and robots.txt, and try to use the data in, well, not nefarious ways. Be nice, be ethical. In the next video, we're going to talk a little bit about how to expand on this and what you might want to try if you want to get more and more involved with web scraping. I'll see you in that one. Bye-bye. You have just learned the basics of web scraping. It's pretty exciting, isn't it? A lot of power at your hands, at your fingertips. But let's say you want to go further, learn more, maybe become a professional web scraper. I don't know, maybe that's what you want to do. What are some things that I would recommend? Well, get more familiar with beautiful soup. But keep in mind what I said at the beginning of this section. Ideally, you don't even have to web scrape. Ideally, you can use an API. Maybe the website that you want to get data from actually gives you an API. For example, if I go to Airbnb API, you can see that Airbnb has announced an official API. So we can actually perhaps read about what data Airbnb just gives us access to. And that should be your first stop. Maybe if you don't have that, then you'll look at beautiful soup. The next thing you might want to look at is this framework called Scrappy. Think of it as beautiful soup, but with a lot more features. A framework is essentially an entire kitchen, an entire tool belt that you can use to scrape websites. And you use things like Scrappy when you want to scrape massive websites, massive amounts of data. A framework versus a library is that a framework almost teaches a new language in itself. It gives you all the tools necessary to do everything that you want when it comes to scraping data. Beautiful Soup, on the other hand, is smaller. It's a library, so it gives you a few nifty tools to do small things like what we've done here. Scrappy, the framework, well, is an entire thing in itself. You can go through their documentation and tutorial. It takes a bit of time to get used to, but if you want to do this maybe full time, Scrappy is something that you should take a look at. Finally, what do you do with all this data? Eventually, you might want to do something. Maybe store it in a text file, in a CSV file, something that we've talked about and we'll talk about in the course. But as you collect more and more data, maybe using something like Scrappy, you might want to start looking into using what we call databases. And databases allow us to store massive amounts of data and save it somewhere so that we can access it whenever we want. And there's a ton of databases, something that is beyond the goal of this course. But you may have heard of things like MongoDB, Redis, MySQL, Postgres. These are all ways to store data, store massive amount of data and access it. So you might want to learn about how to use a framework like Scrappy and collect that data and store it somewhere on a database so that other people on your team can maybe access it. The possibilities are endless. But if there's one thing that you're going to take away from this is, please be nice, be ethical, and don't do anything illegal because, well, I don't want to get in trouble. And I'm sure you don't as well. I'll see you in the next one. Bye-bye. Oh boy, we have an extra exciting section for you. This is a section that I absolutely love. I got into programming because of web development. And in this section, we're going to explore how we can use Python in web development. And actually, the way we use Python in web development will also work with mobile development. And this is a really exciting field because, well, as you're aware, there's lots of web applications. There's lots of mobile applications. And using Python, we can actually help build these applications. In this section, I'm going to give you a general overview of web development, what that involves, how websites actually work, how browsers work. We're also going to use Python to build our own server, our own portfolio webpage, where people can view our portfolios and actually submit maybe a request to work with you or send you a message and actually store it in places like a database. So by the end of this section, you're going to have your own portfolio website that is live and in production. It's going to be a very, very fun one. But in order for us to learn how we can use Python, we need to first understand how the web works. So in the next video, let's learn how the web works. I'll see you in that one. Bye-bye. So how do websites work? Now, I have an entire web development course, so because this is a Python course, we're not going to go super deep into this topic. Instead, we're going to focus on the Python side of things. But I do want to help you understand what we're building and how everything works, because hopefully by the end of this course, you're able to actually change your portfolio, update your portfolio to your own liking, and showcase the projects that we've built throughout the course. So I have a website for you here. We have XKCD, which is just a little funny comic website. If I click refresh here or enter this URL, I'm taken to this website. But how does this actually work? How is my browser, in this case Google Chrome, able to display this web page for me? I need to be connected to the internet, right? So there's some sort of data that's being transferred for me to be able to see this. So let's explore how this works. And look at that. I created a nice little diagram for you. And in this diagram, I'm going to attempt to just tell you exactly how it works. It's quite simple. We have our browser right here, which can be Google Chrome, it could be Safari, it could be Firefox. It doesn't matter. This browser, we're able to type into it a website or maybe Google for a website and then click on a website. When we click on a website, what happens is that through internet, the browser makes a request all the way to another machine. And this machine, which we call a server, is located anywhere in the world. It doesn't really matter. Because through our internet network, the browser is going to say, hey, this website, who owns that website? Or which machine can serve me the files for that website? And using some complex logic, it's going to find this server, which at the end of the day is just a computer, and we're actually going to show you and deploy our own server. Well, it simply says, hey, give me some data, because without data, I'm not able to display anything on a web page. And the server, well, first of all, they communicate over something called HTTP and HTTPS. Because the browser and the server are two different machines, right? The browser is on my laptop right now. And the machine, which is a server, it can be anywhere in the world, they need to communicate some way. And we need a rule to say, we don't want all these machines talking to each other with no rules in place. For example, we can agree that when we communicate between you and I'm going to speak in English. In the same way, HTTP and HTTPS, which is a secured, encrypted version of communication, allows me to say, hey, can you give me the data? And the server to understand, oh, this website or this browser needs the data that I have. If I go back to this website over here, you see that I'm using HTTPS. And it's saying, I want to use the HTTPS protocol, that is the language, to communicate that I want to go to this website. So as soon as I hit enter, it's going to make that request all the way to a server somewhere. And then the server is going to respond with this data. Let's continue with our diagram. So the request has just been made. This server just happens to have 3 files that we need. One is an HTML file, and this file is the text or content of the website. The other one is the CSS file, and this contains all the styling of the website. So that is colors, maybe some fonts, maybe the position of the elements, anything to do with style so it doesn't look like a boring piece of text. And then we have JavaScript. JavaScript is what gives websites behavior. When I log into Facebook or maybe tweet something on Twitter, JavaScript is allowing me to perform those actions. Because with just HTML and CSS, we just have text and some pretty styling. With JavaScript, we're able to take actions. But we don't need to focus on that too much. All we need to know is that the server, because it's a computer, on its files has these 3 files for us. And these 3 files, what happen, get sent to the browser. Because the browser was really, really kind and asked, hey, can you give me data? And the server says, sure, here it is, and sends us these 3 files. And these 3 files, when they get sent back, the browser understands them. And because it understands them, even though to us it may look like gibberish, it's able to display that website for us. But let me ask you a question. Up until now, I haven't really talked about Python. I thought this was a Python course, Andre. Why are you telling me all this stuff that I don't care about? Well, because in here, there's one piece that can actually be written in Python. Can you guess what that is? If you guessed the server, congratulations. You get 5,000 points. You see, the browser is something that, well, it's an application we download on our computer, right? But up until now, the server was kind of a mystery box, a machine, a computer somewhere. But Python programmers can actually write the logic and the rules that servers can act upon. So all this communication of, hey, can you give me data, can be interpreted in Python and then send this data to the browser using Python. And we're going to build our own server over the next couple of videos, but also touch upon these HTML, CSS, and JavaScript files so we can actually display something like a website. Now, I want to finish off this video with one question. Do you think that this server has to be written in Python? What do you think? No, it doesn't, right? The browser doesn't care what this machine is like. All it cares about is these 3 files. And because we're speaking in this HTTPS protocol, the browser says, hey, I don't care what language you speak, I don't care anything, I'm just going to tell you through this HTTPS, just give me the data that I want. And we can do whatever logic we want in here. I can send emails from here if I want. I can send text messages. I can do math operations. I can play a game on this computer if I want. It doesn't really matter. As long as I am able to send these files back to the browser. So we can do that with Python, but we can do that with other languages like Node, like PHP, like Java. So we can write a server in any type of language. The only thing we can't really do is on the browser side. On the browser side, we have to use these 3 files because, well, at least in general terms, it can only understand JavaScript, which is another programming language. All right, let's explore this topic a little bit more in the next video. In the previous video, we learned that a browser simply sends a request to a server somewhere in the world over internet using the HTTPS protocol, and then it receives those JavaScript, HTML, and CSS files so that it's able to display a website. Now, how can we actually check this? Well, I can actually go to View, Developer, and this is using Google Chrome. So I recommend for this part to use Google Chrome so you can follow what I'm doing. If I go to Developer Tools here, it's going to open up a little box here with some information for me. Now, what I want to focus on is this Network tab. And this Network tab is going to tell us what type of information we receive from the server. If I refresh here, you'll notice that I get some data here. Now, you want to make sure that there's no filter involved. So we want to say over here that we want everything. So there's no filter, everything, there's no searching going on. And we can refresh again. And all right, we see a lot more files. But this looks intimidating. Let's think about what we just learned. We learned that we first get an HTML file, which happens to be this one. It says over here, type document. And if I click over here, this is an HTML document. So the response from the server, when I hit refresh, remember, it communicated to a server somewhere in the world that had these files on that computer. And here we have our HTML file. If I'll scroll down, look at that. We can see over here the webcomic of romance, sarcasm, math, and language, which is right over here. Remember how I said HTML is the text that gets displayed on a website? Well, this is our HTML here that the server responded with. And the browser knows how to read this and display the text. What about the CSS? Well, I can actually click on this CSS tab here, and it'll show me all the CSS files that came from the server. And you see over here that this, again, looks a little bit different. It's in a different syntax than an HTML, but all it does here is it gives me the styles that I want. You can see over here, we can pick background color, We can pick different position, width, left position. And this gives us the styling that we want on a website. And then if we go to JavaScript, we actually see the JavaScript files that this website uses. Now, we don't have to worry about JavaScript here. JavaScript allows us to do some interactivity on this website that, for now, we probably don't need to worry about. Now, I do want to point out that there's a few other things in here, like image and media. And as you can see, images, we definitely have some images in here that we are using. If I click on preview, we can see the images. But at the end of the day, the concept is the same. We have an HTML file, which in our case is right over here. You see how the HTML file is displayed without CSS, which is just the textual data. We have the CSS, which is the styling of our page, and then some JavaScript to make our page interactive, and maybe some images. But at the end of the day, all these things are actually just textual data that we receive from the server. So that means that in order for us to be able to build our website, we need to create these three things: an HTML file, a CSS file, and a JavaScript file. Actually, we don't even need a JavaScript file if we don't want any interactivity. We don't even need a CSS file if we don't want any styling. We can even just use an HTML file. So in the next video, we're going to build our first website. I'll see you in that one. Bye-bye. Welcome back. Let's build our first website. Now, I've already created a folder called Web Server because this is going to be our web server for now. And inside of this web server, we have an index.html file, which will be the extension for creating an HTML file. We have script.js, which is the extension for writing JavaScript, just like we have .py for writing Python. And then we have style.css for writing CSS styles. Now, in this section, I'm going to be using Sublime Text and my iTerm terminal, but you can use whatever developer tool that you want. I like using these ones just for the screen recordings. They help because, well, it's nice and clean. It doesn't give me too many hints so that I can also make errors and show you along as I make errors how I fix them. But again, you can use Visual Studio Code, whatever you prefer. Now, you see over here that all these files are empty. But remember, a web server simply gives these three files to a browser so that the browser can display the page. So let's start off with HTML. How do we write HTML? Well, Sublime Text actually lets me do something interesting here. If I type in HTML and then hit Tab, it autofills it for me. All right, I kind of cheated, but hey, I don't want to bore you to death. So this is a standard HTML file. Because I have the .html extension, if I have this type of syntax, I can write HTML. And it's not that difficult. We have opening tags and closing tags with the backslash here. So we have the head of the website with the title. So this is what appears on the tab. So let's say my website. Very creative. So that's the head, and then the body. This is what gets displayed on a website. So in here, I can say, I am a webmaster. Just like that. And we've created our HTML file. Now, check this out. If I now open index.html, if I right click here and let's say, open in new window. Or you can even just go and double click this file. So if I double click this, look at that. I am a webmaster. Just simple text, nothing too crazy, but I've just created my first website. Let's continue with CSS. CSS has a different syntax than HTML. CSS syntax goes something like this. We can give it what HTML element we want to add some styling to. In our case, let's say body. And I can say body, then curly brackets. And in here, I want to have background, let's say color, And we'll go with, let's go with green. If I save this and I refresh the page, nothing happened. And this is a little small detail that, again, this isn't a web development course, so we don't need to worry too much about. But essentially, the very first thing that happens is that the HTML file gets sent, and the HTML file is actually the only thing that gets read by the browser. So within the HTML file, I have to say, hey, HTML, by the way, we also have a CSS file. Can you also use that in the website? So we can do that in the head tag by using something called a link tag. So a link tag, we can actually remove some of this. We simply have to say, hey, it's a type of text CSS, and it has something called href. Href simply says, hey, where is this file located? In our case, because it's in the same folder as our index.html, we can simply say it's style.css because, well, just look for style.css and that's where the style file is. And now, if you remember, we also had the relationship style sheet that we need to include. I just removed it so that we can see what we're writing over here. So if we do style sheet, and this is just something, a syntax that you have to get used to if you want to include a CSS file. If I save this and go back and refresh, hey, look at that. My ugly website, let's make it a little bit bigger. My ugly website with a green background color now has some style. If I open up the developer tools once again, and I hit refresh, look at that. I get an HTML file and a CSS file. Awesome. So I just created my own web server, right? We could even write JavaScript here, but again, this isn't a JavaScript course, so we don't need to worry about it. In this case, here you go. I just wrote some JavaScript, which this is kind of like writing print in Python. If I refresh the page one more time, again, JavaScript file doesn't get displayed because, well, we have to, again, tell index.html that we need a JavaScript file. And usually, JavaScript files are contained in a script tag, usually at the bottom of the body. So let's close that. And then in here, instead of using the href, we just have to say src for source. And then once again, where's the JavaScript file? It's at script.js. So if I save this and I refresh the page, look at that. We're now loading the script.js file. And all it's doing is if we click on the console tab is, there you go. It printed something in the console, and console is something that JavaScript uses. But all we care about is that we're able to serve these three files. What we've done is created our very first server. But you may have noticed something. When you went up over here, look at the URL path that we have. That's not what you usually type into a website, right? I mean, we saw that the website over here, xkcd.com, well, has the .com, uses HTTP. That's a real URL, right? Well, I'm sorry to tell you that we didn't actually create a real web server because all we've done is we've served to the browser some files from, as you can see, from our computer. So all it's doing is the browser saying, hey, I'm going to display these files that are located right here on your computer. So essentially we have a web server that's also running a browser, but that's not how real life works. Why would that be? Well, imagine if you had your own website. Do you really want to have people from all over the world access your website directly through your computer? Grabbing the files from your computer? I mean, no, right? There's a lot of security issues. There's a lot of issues with performance. You have to keep your laptop on the entire time so people can access your website. Instead, we want a web server, which, as the name suggests, serves files and specializes in serving files to browsers somewhere in the world that I don't have to worry about. It's not on my computer. Somebody owns that machine. Somebody owns that computer. And it's on all the time so that whenever we go to a website or a link, it's always going to be running and sending those files out. So we're finally going to get back to Python here. Because what we want to do is do something more sophisticated than just having these files on our machine. Instead, we want to build a real server using Python that we can deploy so that people can access our website anywhere in the world. Now, you might still be confused. This whole process might not make complete sense to you because we're just getting started. But don't worry, by the end of it all, it's all going to make sense. So let's forget about the browser for now and get into building a real server. Something more sophisticated than what we've done up until now, which is just a folder with these 3 files, and we just double click on index.html. I'll see you in the next video. Bye-bye. Welcome back. It's time to use Python and build our real server. Now, what should we do here first? Your first intuition might say, I wonder if Python has a module already for that. Well, if you actually Google Python HTTP server, you see that, oh, look at that, Python seems to have an HTTP server. Awesome. And this module actually allows us to create a server. You can see over here that all we need to do is use the HTTP server, and, well, we have ourselves a server. You can actually read through the documentation and see how you can build one. You can see over here, for example, that it's a simple couple of lines to create a server. However, if I scroll all the way up, there's a warning here. HTTP server is not recommended for production. It only implements basic security checks. You see, building servers is a very, very common thing. A lot of Python developers are hired as backend engineers to build things like servers. So when we use something like the HTTP server that's built in as part of the Python standard library, well, we're redoing all these things that, frankly, a lot of developers have done before. And when you have a problem that is constantly getting solved, or the problem is constantly being rewritten and rewritten and rewritten, we start to have something called libraries, but also something called frameworks. That is, instead of using something that, well, frankly, would take us a really long time to do, and as you can see here, there's still a lot of issues like security issues that we need to check and fix, we can use a framework like Flask to build a server because so many engineers are building servers using Python. Flask is a tool that uses, perhaps underneath the hood, something like HTTP server, but instead make sure that the security, the added tools and benefits are already pre-built for us. You can think of it as a kitchen. You're trying to bake a cake, and instead of you having to go buy the knife, go buy the bowl, the mixer, the oven, go buy the ingredients, all that stuff, Flask is like the kitchen where you get to enter the kitchen, you have all the tools necessary, you have the ingredients, and all you have to do is cook. Now, when it comes to Python, there's 2 really popular frameworks. There's the Flask framework and the Django framework. Right over here. Now, Django is one of those frameworks that it's really, really big. It's a big, big kitchen. On the other hand, Flask is what we call a micro framework. That is, it's extremely lean. It's a small library so that we can do things fast. I'm going to teach Flask over the next couple of videos because I like the simplicity of it all. Sometimes when you write in Django, it feels like you're not even writing Python because there's so many rules and so many tools that you can use. Versus with Flask, everything is clean and small, and it's great for our use. So how do we get started? Well, as you know by now, as with any tool that we use, we should read the documentation, right? And in our case, we can just go to installation and actually read through and see what they recommend. You see over here that they recommend we use a virtual environment, something that we've already talked about in previous lesson. And you'll see why this is important when we actually deploy the project to production. But it looks like we first create an environment, so we make a directory, a project directory, which hopefully we already have. And then we create a virtual environment. Now, one thing I haven't told you is that if you use Python 3, which if you're following this course, you already are using, it comes pre-built with something called venv. So instead of pipenv or virtual env that I've talked about in the previous video on virtual environments, this comes pre-built. So we can actually just run this command in our terminal. So let's give it a go. And look at that. A new virtual environment folder was just created. Now, you see over here that the virtual environment was created, well, in a new folder called venv. If we actually leave out the first part, or the last venv, or actually, let's go back one directory and simply say Python 3-m venv, and then say web server. The web server now becomes the virtual environment because we already have the folder built. So we don't want a new folder called virtual environment. We can just delete that and instead have the virtual environment right over here. Now, it also gives you the option on how to do it on Windows. So again, on Windows, you might have to run py-3. Or if you're using Python 2 and you don't have the venv module, in that case, well, you have to use virtual environment. And then finally, we have to activate the environment. And all we need to do, if you're on a Mac or Linux, is just grab this code, or on Windows, grab this. So let's just copy and paste this. If I paste it in here, well, let's talk about what it's doing. Here, we have to change this to where our folder is. In our case, we're doing the web server, right? So I'm going to say web /space server because, well, that's the folder that we want to go into from desktop. And inside of the bin folder, right here, we have the activate executable. So all we're saying is, hey, run this executable. We don't need to worry about what it does, but if I run this, we get a bit of an error. Now, the issue here is that I'm using something called a fish shell. And the reason I'm showing you this is because everybody's machine is different. So whether you're on Windows or Mac or Linux, or maybe you're using a different type of terminal, you might get these errors. Now, the best way to solve these is if you go to the venv Python module, and if you scroll all the way down, you'll see here that you can activate using certain scripts, but depends on which shell you're using. Most of you are using PowerShell in Windows or Bash if you're using a Mac. In my case, I'm using this, fish. So all I need to do is actually add this .fish at the end of my script. You'll notice here that you might have to add different things based on what you're using. So if you're on Windows, you're most likely going to add .bat or .ps1. So let's try that again. I'm going to run the same thing, but this time say .fish. There you go. It's now working, and I am in the web server, which is this folder, in the virtual environment. So now I can install packages here and just be in my own little world. Now, if for some reason activating doesn't work for you, you can actually still keep going with the lectures. It won't really affect you. This is just one of those things that it's a little tricky. You might not get it straight away, but the best thing to do is to always read the documentation and follow the instructions. All right, that took an unnecessarily long time. So let's finish off by installing Flask. If we go back to our guide, we can finally install Flask by doing pip install Flask. Now again, we want to make sure that our pip, if we do version, is for Python 3.7. But for some of you, you might have to use pip 3. So based on your needs, make sure you use the appropriate pip installer. Let's clear this. And just copy and paste and install Flask. Awesome. We've just installed Flask, so we can start using it in our project. But that was a whole lot of setup and a lot of downloading, so let's take a break, and I'll see you in the next video. Bye-bye. Oh boy, wasn't that last lesson super fun with all that installation and setup and errors? Hopefully things will be a lot better as we move along. That was, I'd say, the hardest part. We're back here at the Flask framework. And the next thing we want to do is we want to go to the Quick Start Guide. And I know I could just code along and show you exactly how it is, but I really want to show you the process of how you work as a developer, because once you're done with this course, you're going to be out in the world and you should know how to learn something new. Let's say at the next job, somebody says, hey, I want you to use Django instead of Flask. How do you learn it? Well, you read the documentation. So I just clicked on the Quick Start because I just want to build a server really quick. And you see here that the minimal application is, well, it looks like this. So let's just copy the code from here and we'll talk about it line by line, don't worry. So I'm going to close off these index files, the script files, and the CSS files. We're in our virtual environment. Let's clear this. And we can actually just create a new file. So in our web server, let's just say new file, and I'm going to say server.py. So we have a new Python file, and we're going to copy and paste that code. So we're installing, or we already installed Flask, so I'm going to import Flask from Flask. And then we do this funny thing called app equals Flask, and we use the Flask class to instantiate an app. And we do this __ name. Now, when something is confusing, I always like knowing what's happening. So I'm just going to run __ name here and actually just print it up so we know what it is. And for now, let's just comment out the bottom part of this. Just click save. I want to find out what this name is. So let's see if we can run this file. I'm going to say Python 3 and simply say server.py. Oh, and we're in the desktop right now, so let's cd into web server. Let's clear and run that again. So Python 3 server.py, and there you go. So our name in this case is main. And why is that? Well, because this is the main file that we're running. This shouldn't really be a surprise, right? So we've created an instance of a Flask app, or set up our Flask app, and this is our app. And when we run it from our command line, it sets the name as the main. So that's the name of our app, essentially. All right, so we've created our app, our Flask app, and then we see that we're using, what is this? This is a decorator, right? We learned about this. Again, one of the cool things about frameworks is that they give you what we call a higher level of abstraction. That means we don't necessarily need to know what this is doing, what the code is doing underneath. We just know that this app.route decorator gives us some extra tools for us to build a server. In this case, it's going to say anytime we hit / or what we call the root, I want you to define a function called hello world and return hello world. But let's go back to the documentation. Now, one thing I want to note here is that when you call your Python file, make sure you don't call it flask server.py because this would actually conflict with Flask itself. So name it server.py or hello.py, whatever you want, just in case you get that error. Now, the next part is to actually run our application, our Flask application. Now, there's one other trick here that we need to do. We need to run the Flask run command. So Flask also gives us a command line run to actually run our server. But we also see here that we need to export. Let's make this a little bit bigger. We need to export Flask app equals to hello.py. And as you can see here, we just need to give it that environment variable. So Flask app, just like this. And if you're on Windows or PowerShell, it shows you what commands to run. Again, I'll link to this resource so that you can copy and paste as well. In my case, I'll just do export. So copy and paste here. And instead of hello.py, I'm going to name it server.py. And then we can do Flask run. Now, another option is to actually do Python-m Flask run. But since we created a virtual environment, we should be able to run Flask run. All right. We get a little warning. This is a development server. Do not use it in production deployment. All right, that's good. We don't need to worry about it because we're not doing production right now. This is just something on our computers. And you see here that it's running on HTTP 127.0.0.1. This is the standard. It's what we call a local host. This is the URL or the address of the laptop I'm working on. And for you, that's the same thing with port 5000. So if I copy this and open this up, what? Look at that. Are you kidding me? We just created our server with hello world. Where is this coming from? Well, it's coming from this, right? The slash says, hey, anytime we do the root directory, so this is like saying here, slash here. Anytime the browser requests for this endpoint, it's going to hit our server, and look at that. It's actually logging out that 127.0.01, which is us. We logged this entry. The app route is going to say, hey, somebody needs some of our resources, some files, some data. What should we do? Well, we have this hello world function that we're going to run, and we're going to run by returning hello world. That's right. We just created our very first server. Just to prove that I'm not making this up, let's put your own name on it, refresh, and I'm refreshing and it's not working. And that is because you see here that I'm actually making these requests, but the changes haven't been saved. We actually have to do Control or Command C, let's clear, and run the server again. So now, if I refresh, look at that. Now that's really cool. And I also want to show you that, see here how it says serving Flask app server.py? Remember when we ran the command, this, where we used Flask app equals server.py? This is what it's saying. We are able to do what we call an environmental variable and set Flask app, which is going to get displayed here, as server.py. So I could have called our app whatever we want. So if I go back here and just say super duper, and I run, you see that my Flask app is named super duper. Now, the other thing I don't like is the fact that every time I make a change, I have to restart the server. And you can see here that the debug mode is off. I can actually turn on the debug mode by doing something like this. Once again, we use the environment variable, and if we go to debug mode in our documentation here, you can see here that if we do Flask env equals development, which again, instead of the Flask app, we'll say env equals development, and I run this again, you see that I'm now in the debug mode on. This is something that we use, again, just Flask specific, to make sure that it's in development mode. And what this does is, watch this, as I change this and save it, I go back and refresh. Oh, and I get an error. Again, this is one of the cool things with the debugger. So if I make this a little smaller, I get an error saying, hey, could not import super duper. Well, that's because I just changed the name from super duper, but it's actually trying to import this server.py, and well, we should probably name it server.py because it doesn't work. I only changed it just to show you what it does. So we can actually fix that. Again, the debug mode, as you can see, gives us a lot of information. So I'm going to close the server, fix my silly name from superduper to server.py. All right, we're all good. And then we're going to Flask run. All right, let's go back and refresh. And there you go. Everything is all good. But the cool part is that now, if I change this to just hello, save, notice how the server noticed the changes. You see over here, it detected changes and automatically changed things for me. So if I refresh, look at that. I don't have to restart the server and everything is working. Awesome. We have our basic server, but we still have a bit more to go because we want to get to the point where we can actually serve important information like HTML files, CSS files, and JavaScript files. Let's explore that a little bit more in the next video. Welcome back. So we have our, well, frankly, really boring website, but we've created our server. But what else can we do? A server usually accepts a request from the browser, right? Now, up until now, we've done what we call a root route. That is the home route, because in here, we haven't written anything. But sometimes in a website, you might see something like blog, right? And if I hit enter, you see that not found. The URL was not found on the server. Again, that's because right now our server is only waiting to hear for the root request. But if we type something like blog, well, there's no function here that cares about that, so it sees that there's nothing to care about and moves on. So let's create a blog route as well. I'm going to copy and paste and just say that, hey, we want to listen to the blog endpoint. This is going to be called, let's call it blog, and say, these are my thoughts on blogs. If I save, again, we have the debugger mode, so I don't need to restart. If I refresh now, look at that. These are my thoughts on blogs. And if I go to the root directory, I get hello. We now have multiple routes. How cool is that? By the way, if we open up the developer tools, go to developer tools, open up the network and just refresh here, you see that we're getting a document. Ignore this part. This is just the developer tools and the plugins that I have. But this is what we get back. We just get a simple document, a response, which is a text. And if I go to headers and I actually scroll down, you see that I requested this URL. I got a status of 200. And I see here that the content type that the server responded with was something called text HTML. Now, this is something that Flask does for us. You see over here that I just sent a string, but Flask automatically converts that to HTML so that the browser can understand it. As a matter of fact, if I go to elements here, you see here that I have my HTML with a body of hello inside of it. So that's something that we get automatically, which is really, really nice. But now we can start doing some really neat things. For example, let's create another route. And this time, let's say I want the blog from, let's say, 2020 about dogs. Can I do that? Well, yeah, absolutely. Let's say blog 2. And this says, this is my dog. Very engaging blog post there. So now, if I go back I do blog, all right, I get that. If I do blog 2020, let's say dogs, I get this is my dog. Awesome. So I can have multiple routes like this. What if I remove this and have 2 blogs with the same endpoint? If we go back and just go to blog, I get these are my thoughts on blogs. Because once it hits a route that it sees, which on line 9 it sees, it's going to automatically just return and forget about the rest. So let's bring our dogs blog post back. But you know what's a shame? Because we have this beautiful website, I'm being sarcastic here, this beautiful HTML website that we've created with CSS and JavaScript. Wouldn't it be nice if instead of me just sending out text, I can actually send those? Could I do that? Well, yeah, you can. You see, Flask has another thing called render_template. And this render template function is going to allow us to actually send the HTML file. So let's say the home route now, instead of hello, is going to do something different. Instead, it's going to run the render template function that comes with Flask. And in here, we give it the HTML file that we have. So we can give it a route in our case because it's in the same folder as the server file. We can just do index.html. If I run this, let's see if this works. If I go back to my home route, I get an error. Let's read the error. Template not found, index.html. So it tried to look for index.html and it didn't find it. That's not good, is it? What if we do a /, which means current directory, grab the index.html. If I save and refresh, I still get the error. Again, this is another thing that you'd have to just learn as you read the documentation. But the reason that this is not working is because Flask automatically, when you say render template, tries to look in a folder called templates. So let's create that. I'm going to say new folder, call it templates, and put all my HTML files, in this case, the single HTML file that I have, I'm going to say move, and put it in the templates folder. So now it's in here, and let's save, go back, and refresh, and look at that. I am a webmaster. Everything is working. If I go to blog, I get these are my thoughts on blogs, but my HTML file that I've created is working perfectly. How awesome is that? And Flask uses this idea of templates to add multiple HTML files. So for example, I can create a new file. Let's just say duplicate here. So I'm going to duplicate this file and call it about.html. And this about.html is going to say about me. And let's go into server.py and have the root folder as index.html. And perhaps add another route, say about.html. And yes, I can do that as well. And in here, we'll grab the about.html. Let's call it whatever we want. Let's say about function. And if I go back, go to about, well, it's not going to work because remember I added the .html. There you go, about me. Awesome, this is great. We're starting to learn about different routes and how servers work. And we're able to send our HTML file. But what about the JavaScript files and the CSS files? How can we do that? In the next video, we'll find out. Welcome back. Let's figure out how to add CSS and JavaScript to, well, our index.html. Because If you remember, we are using script and CSS in here. Now, once again, with Flask, if we go to, let's say, CSS, we see that there's static files. Static files simply means it's a file that's never going to change. That is, CSS and JavaScript, usually once we send them out, they're not going to change. They're static. And you see over here that with Flask, we have to store the files on the file system as static/style.css. So we need to create a static folder. Again, this is something that you just have to get used to, but let's say in here we'll create, just like we did with templates, we're going to create a static folder so that the Flask app knows to look in here for CSS and JavaScript files. So I'm going to move the JavaScript file to the static folder and do the same with the CSS file. So once again, move that to static. Now, if I just save this and run, you'll see that it won't actually work. Well, why is that? Can you figure it out? Again, because we haven't talked too much about HTML and CSS and JavaScript. Don't worry if you didn't get this. But if you remember, in our index.html file, we reference these files inside of here. But the file paths have now changed. They're now in the static folder like this. So I have to say static script.js. If I now go back and refresh, hey, look at that. My beautiful green website for, let's say this is Christmas website, is now working. If I open up the developer tools, go to network and refresh, hey, check that out. I have my document, then I have my JS file, and why is there no CSS? Let me refresh again. Oh, there it is, right over there. We have style, CSS, we have JS, and we have the document. Awesome. If you're wondering why we're getting this little favicon error, favicon is the little icon that shows up on tabs over here. So we can actually even add our own favicon if we wanted to and send images. And the way we would do that is to, again, in our endpoint, let's, instead of the blog, I'm going to say favicon.ico for icon. And we can just send it an image. How will we go about doing this? I'm going to show you the answer in the next video, but I want you to give it a try and figure out how you can send an image back to this endpoint so that we don't get this error. And when a browser automatically requests for this, which all browsers do, it's going to show up a little icon over here for us. So pick whatever icon you want and see if you can solve it. In the next video, I'll show you the answer. Welcome back. Were you able to figure it out? I just Googled around for some free .ico icons, and I really like this lightning bolt one, so I've just downloaded it as an ICO. And now it's in my folder over here as bolt.ico. Now, how were you able to solve this? If your first instinct was to Google for it, well, good job. That's what you want to do as a developer. You see over here that, well, Flask has documentation on how we can use it. Now, there's two ways to do it. We have this link way and a way that works with older browsers as well. Now, this syntax might not be obvious to you, but let's use this method and then I'm going to show you what it actually does. So let's just copy and paste. So we go into our index.html and in our link tag, I'm going to add this. So let's make this a little bit bigger so we can see and maybe a little smaller so that everything is in here. And we see here that we have this syntax that we haven't seen before that's actually going to be used with Flask that we're going to talk about. But we see here that it's going to be for the static folder, and the file name is going to be favicon.ico. But mine is called bolt.ico, so let's just call it bolt.ico. That's the file name. And it should be in the static folder, so I'm going to move this into this static folder, just like that. Now, if I just save here, I can actually comment this out, hit save, and see what happens. If I go back to my website and I refresh, hey, look at that. Do you see how I have a little bolt here? You see that the bolt.ico is now on my website. How cool is that? And I didn't really do anything crazy. I didn't even have to have an endpoint, which is really, really cool. Again, Flask, because a favicon is something so common, just makes it super easy for us so we don't have to clutter our code with a favicon endpoint. So I can just remove this. But you know what? I'm not a big fan of doing things without understanding them. And right now, what we just did here seems really, really strange. Where is this URL 4 thing coming from? What's with this double squiggly lines? In the next video, we're going to find out what all of this means. Welcome back. What is this weird syntax? In order for us to understand that, we have to understand this idea of a templating language. You see, the power of Flask is the fact that we can build things dynamically. What do I mean by this? Well, let's assume that in the body tag here, I write 2 curly brackets like this. If I do in here 4 plus 5, and I save, let's go back to our website with our cool lightning bolt, and let me close this for now. If I refresh, I get 9. Is that what you expected? How is that possible? Because if you're wondering, this isn't HTML. If I did this in a regular HTML, it will just show the actual curly brackets, 4 plus 5. But something is happening here. Flask looks at these double curly brackets and says, oh, this is an expression. This is a Python expression that I actually need to evaluate. And this is actually the exciting thing with Flask. Underneath the hood, it uses something called Jinja, a templating language. It's a way for us to do this, and Flask comes built in with that. So if we look at the favicon, what we just did is we've used Jinja to say, hey, I want you to evaluate this as Python. So if I copy this and I go to server.py, and in here, let's just do a print and paste this in. That is the exact same thing that we added to our HTML, except for we now need the URL 4 that comes with Flask. Let's move this here actually, inside of the route. If I refresh, I see over here that I get static bolt.ico. So it's printing the actual URL static/bolt.ico. Now, I could just technically have copy and pasted this and just done this whole thing as a string instead of using URL 4. But if you go to the documentation of Flask, it talks about URL 4 and why it's a good idea to build a URL instead of hard coding them. And it gives you actual reason of why you might do that. For now, you can just think of it as a safer way to build URLs. So that's all we're doing. We're essentially saying grab the bolt.ico from the static folder. And we're able to do this through this templating language. Very, very cool. And now we have an extra power in our tool belt. That is, we're now able to dynamically update parts of the page. What do I mean by this? Imagine if our super cool website, when I actually refresh here, gives me the username of that person. For example, if I request for the blog of Andre and I hit run, ideally it'll say, "Hi Andre," and then maybe show my blog post. Using Flask, we can do that. And let's find out how to do that in the next video. Welcome back. Flask has this other tool called variable rules that we haven't talked about. And what variable rules allows us to do is to do something like this, dynamic. So for example, /user/ with these greater than and less than signs and the username. Now, we'll get back to this in a second and some of this syntax. But if we go back, what we can do here in our server.py is perhaps, let's remove this because we don't need it anymore. Inside of our hello world, let's say that we want name in here. Or in our case, username. Now, the neat thing is that Flask is going to look at this and say, oh, this is something that we can pass on into this function. So I can now say username equals the username that we receive. So let's say username. And let's just change this to name just so you see what the differences are. So I'm passing whatever I receive here into the hello world name parameter. And now in my index.html, I can pass on this data by simply doing a second parameter and saying name equals to name. So now if I save this, go back to my index.html and put in name in here. And if I go back to our homepage, if we go to our homepage, and I made a little mistake here, this should be over here. So it's saying username from up here is going to equal a default if we want. So it's usually a good idea to have a default. I'll just do none for now. So that username now is going to be username in here, like this. If I save, go back, I get a not found because we don't have a homepage anymore, but anytime I do, let's say, Andre, I get, look at that, Andre on my page, I get Bob and my good friend, Sally. How cool is that? So it's able to read the URL and pass in data this way. And if we go to our Flask documentation and we go to variable rules, you see that we have different rules that we can apply. For example, we can actually require to accept a positive integer or a string or a float, a path, so it accepts slashes, or something called UUID, which is kind of like a unique identifier. So let's try that. Let's do a post ID here, or in our case, let's just copy this and say I also want the username, and then perhaps accept some sort of a number. So instead of post ID, maybe it could be, I don't know. Actually, post ID is good. Let's keep it like that. And let's make this a little bit bigger. Now in here, the second parameter can be the post ID. That's going to equal to none to begin with. And we're also going to pass this as post ID. That's going to equal the post ID. If I save this, go to index.html, and in here, let's do name, and then we'll also do the post ID in here. If I save, go back, and I refresh, well, again, because we've made our URL very specific, we'll just have to give some sort of a number. And look at that, I have Sally 2, so that's her second blog post. then the 5th blog post, so on and so forth. And if I do something that's not a number, so if I do some string, I get not found because I've made the rule using this syntax, so int with the colon, saying that this has to be an ID. And I passed data down this way. So now we've created a full-out server. We now are able to use URLs to communicate with the server and ask for specific data for it to receive. Our server, based on what URL parameters we give it, or endpoints, is able to decide what resource to send to the front end so that it can display the appropriate information. But we can also do something interesting, like perhaps when we submit a form, to actually send perhaps the user's name with the form so that when we send back a thank you note, we can say, thank you, Andre, or thank you, whatever the username is. Very, very cool. Now, these variable rules, as you can see, there's a few of them, and you can read through the documentation. You might also notice this syntax here, which is the %sign or %s or %d. This is actually another feature of Python that you can read about. But again, it's not critical to your understanding of Python. For now, though, I think we have the basic skills necessary to start building our portfolio website. Because up until now, frankly, this website doesn't look that great. So starting in the next video, we're going to build a really, really cool website. Something that looks, well, more like this. So that by the end of it, we can have a fully fledged portfolio website. And even though it seems like you haven't learned that much yet, you actually have learned all the skills necessary to build something like this. Well, kind of. Let's go explore some more in the next video. Hey, welcome back. I want to take a quick second to talk about this idea of data transfer from servers to the browsers. Now, we saw that when we open the developer tools, we can go to the network tab and actually see what type of data gets sent from the server. And here we saw that there's different types, but we mainly talked about HTML, CSS, and JavaScript. But we also see that there's a few other types in here. If I click on, let's say, the HTML, there's this field called content type that says it's a text HTML file. Now, this is something quite important because it uses something called a MIME type, and it stands for Multipurpose Internet Mail Extensions. Sounds very impressive, doesn't it? And you see here, and I'll link to this resource, and let's make this a little bit bigger, that browsers use this MIME type, not the file extension, to determine how to process a URL. So they look at the content type that our Flask app actually automatically sends to the browser to determine what to do with that file. So that they know, hey, is it an HTML file? Is it a CSS file? Is it a JavaScript file? Now, at the end of the day, all this data that we're transferring, it's all just text. But they can be in different forms, and the browsers can interact with them in different ways. For example, if we scroll all the way down here, we have different types, but we want to focus on the important MIME types for web developers. We have things such as plain text, we have CSS, we have HTML, we have JavaScript. So that if I go to the JavaScript file here, and I go to content type, I see that, yep, it's application JavaScript. And we see here that there's a little note about why it's application JavaScript here instead of text JavaScript. Either way, this way the browser knows I'm about to read a JavaScript file, do some certain things because it is a JavaScript file. Now, if we keep scrolling down, there's also image types. So again, if we look at the images, let's say the PNG, again, if we scroll down, we see that it's an image PNG. At the end of the day, it's actually text that we receive from the server, but in a way that it can be read as a PNG file. So based on this knowledge, websites work by sending all this data and letting the browser take care of, well, building the page for us. Now, so far we've only talked about HTML, CSS, and JavaScript. And usually that's how websites are displayed. But there's different ways that we can also use servers, such as what we call API endpoints. So right here, I have the swappy.co, which stands for the Star Wars API. And what it does, as you can see here, is it sends us data. So instead of displaying a web page, it just sends us information. So for example, if I copy this, like so, and then let's say we do people over here. So let's do people. If I hit enter, look at that. I get this data. And this content type is what we call JSON. And JSON is just this format of data that we can use in our applications. So again, a website might take this data and perhaps display the name Luke Skywalker on the front page. So this endpoint, instead of sending HTML, CSS, and JavaScript, just sends us this JSON data. Because at the end of the day, all a server does is send some data, right? It serves data. We can send all sorts of things. For example, this RoboHash website, if I do, let's say, anything I want in here, and I hit enter, it sends me a random image of a robot. If I change anything in this endpoint, I get a different robot. So web developers and mobile developers use this idea of servers all around the world to try and grab information, grab data from a server and display something useful on a browser. And I hope this shows you the power that servers have. We can do anything. The options are limitless. And we can build all sorts of servers with Python to do all sorts of things for us. All right, let's get back to our portfolio website. Welcome back. So we've learned the basics of Flask. We understand what servers do, and we also know what browsers do. But let's be honest here. This is kind of boring. I mean, this is not impressive. If you show this to a possible employer, they're going to look at you like a crazy person. So let's actually build a nice looking portfolio just based on what we've learned up until now. Now, I have a little gift for you. That is the fact that you won't have to write your own HTML, CSS, and JavaScript because, again, this isn't a web development course. And luckily for us, if you Google anywhere online for something like free templates or HTML free templates, you can find some really nice looking websites that you can just use for free. For example, let's look at Universe over here, and I'll link to this resource so you can take a look for yourself as well. If I preview it, check that out. You have a nice little website or portfolio page that you can just use. How cool is that? And it's actually already tablet and mobile friendly. So everything is already pre-built for you. That's pretty cool, right? So how can we use this? Well, let's just download it. And by the way, as you follow along, you can actually use whichever one of these you want. But for now, let's just use the Universe one just because there's a little astronaut here. It looks pretty cool. Let's just download this and see what happens. All right, I get a little question saying, how do we want to download the template? In our case, we want to pick HTML. And there you go. We get a nice little zip folder, and now we have this downloaded. So let's open this up. And oh boy, that's a whole lot of files and folders. So what should we grab from here? Well, there's a few things. First, this is the sample page. We actually don't need this, so let's just move it to trash. Next, we have assets. These are, well, different assets for our page to work, such as the astronaut page. So we'll keep that around. And then we have our HTML pages, which we definitely need. And then it looks like we have some JavaScript files and CSS files. Now there's a .gz here, which is what we call a compressed file, a gzipped compressed file. So this is just a way for the server to send a file, or the JavaScript file, which you can see is 138 kilobytes, but in a compressed form, so 44 kilobytes. So this way we're sending less data to the front end. And then we also have something like map, which actually helps us during debugging. But in our case, we don't need to worry about this for now. So let's just remove all the gzipped and map files. So we'll move those to trash so that we only have one CSS file and one JavaScript file. And then all the other ones are HTML files for our different pages. Now what we're going to do is we're going to copy this and move it to our project folder. Remember this folder over here? So ideally we move the HTML files into the templates and the static files, that is the CSS and JavaScript files, and maybe the assets in here. So that is the images in here. So let's do that. I have my web server here. I'm going to first just copy and paste what we just copied. And let's move all our HTML files into our templates. And you know what? Let's remove our existing templates as well, because we don't need them anymore. We have the pretty HTML file now. And then just have all of these. We have a new index.html that is going to be a lot prettier than our old website, so we want to use that. So let's move all that into templates. And then let's do the JS and CSS file, as well as the assets folder into the static. Awesome. So now that we have that set up, let's go back to our project and look at that. We have a lot more HTML that we haven't written, but luckily it's already created for us. Now, the last bit of setup is that because we moved our files around, we need to adjust the links between the HTML, CSS, JavaScript, and all the asset files. So if we scroll, if we go to index.html, we see that we're looking for the favicon in assets favicon. But because this is in static folder, we have to add static in here. So let's find where else we're using the assets in here. All right, so it looks like, let's make this a little bit bigger. So it looks like here for our background image, we're once again looking for the space image, but that's, as we know, in the static folder. And let's see where else we have. Oh, we have over here as well. Let's do static. Let's keep going. Static. All right, everything is all good now. We have the static folder. Oh, and we have to make sure we add a slash in front of the dot. Dot just means current directory, and then look in the static folder. So let's go back. Make sure we do that for everything. There we go. And there we go. Now let's save this. And I don't think we're completely done yet, but for now, let's go into our server.py. And for our home route, let's remove what we've had before. And let's just call it my home function. That takes no parameters. And instead, it's just going to return for us our index.html with no passed in parameters. So let's save, go back to our page or my website and see what we get when we refresh. All right, that's a pretty ugly website, but it looks like at least we're displaying something. But right away, we notice that, it looks like there's no CSS being applied. It looks like we have some HTML, but the links aren't working either. So once again, this is because we have to update the links between the files. So what we'll do is actually go back to index.html. And in the head tag, we see that we have our style sheet, our CSS file. But again, we have to update this to have it in the static folder, as well as the JavaScript file, which if we scroll all the way to the bottom, we have the JS file here, which once again will be in the static folder. All right, let's save and go back and see if that makes things better. Hey, look at that. That's pretty cool. Mind you, this looks a little big because I increased the size of my website by doing Command plus and minus, just so we can see better. But that's pretty awesome. Now, if I click on, let's say, works, I get works.html does not exist. So how can we fix that? We already know how to do that, right? All we need to do is to update these different routes so that it points to the appropriate template. Now, in the next video, I'll show you how to do that, but I want you to attempt to do this yourself because we've learned this by now. So try to make the website work exactly like we had it over here on our mashup templates, and I'll see you in the next video. All right, were you able to get that? If not, don't worry. Let's go over what we need to do to get everything on our profile working. So we obviously have an about.html page. So that can just stay the same as it is now. We can call it about. And if we copy and paste here, do another one. Let's say, what else do we have? We have work.html. So let's do work.html, which will be work.html. And let's just check that this works. I'm going to remove the old route just so we have the home, about, and work HTML. If I go back and let's go to home. Oh, looks like we have a bit of an error. And I did not change the function over here. You see that I have both about, so let's just call this work. If I go back and refresh, all right, let's go to works. Oh, it's works.html. Why isn't that working? That is because it should be works.html. Silly me. All right, let's go back. Let's refresh. Works. All right, works is working, but once again, the CSS is not being applied. If I go back and let's go to About Me is working as well, but the CSS isn't being applied. And we know why that is. Once again, if we go to Works, we have to update this to include the static folder. Awesome. And then we update the CSS page as well as the JavaScript page. So this is a lot of repetition, but I'm just showing you so you understand what the thought process is and why we need to do this. Again, we'll just fix these as well. And this one. I feel like I should have a song in the background as I do this so you don't get bored of me just doing this over and over. But repetition is good, right? All right, last one, the JavaScript file. Let's save. Go back to our server. Let's refresh. All right, let's go to home. Uh-oh, looks like index.html is not working. So we got to fix that as well. We have the route directory that's working. If I click on works, looks like the CSS didn't work. Let's see About Me. About Me is working, so we missed something in works. If we go back to, and that's because we have a work and works HTML. So we have to make sure that we incorporate the works HTML instead of the work one. I'm not sure what this page does, but I'm sure it's part of this. So again, going into our works HTML, doing the same thing we've been doing, adding the static. Like so. And all the way at the bottom for the JavaScript file as well. Let's go back, go to works, and hooray, look at that. All our works are being displayed, but it looks like some of the images are not displaying. Now, can you guess why that is? Well, if we go back to our works HTML and we look for images, we see that here we have to add the static as well. So again, I'll add those to the images, and just to make this faster, I'll just copy this and do Command F or Control F to search for all instances of images and make sure that we add the assets in here. An easy way of doing this, and this is what an IDE can